A very good morning to all distinguished delegates, esteemed speakers, colleagues, and participants. On behalf of Geological Survey of India, Western Region, Jaipur, I, Monomita Chakrabarti, welcome you to the second day of this international seminar, Unearthing the Past, Shaping the Future, on commemorating the Geological Survey of India's remarkable journey of 175 years in service to the nation. As we gather here this morning, it is truly an honor to reflect on the Geological Survey of India's extraordinary journey of 175 years, one of the oldest scientific institutions in the world. Since its establishment in 1851, GSI has been at the forefront of geological mapping, mineral exploration, geoscientific research, and national development. Over the decades, GSI has not only shaped India's earth science knowledge base, but has also contributed significantly to infrastructure growth, natural resource assessment, disaster mitigation, and scientific capacity building. Yesterday's sessions set an inspiring tone, reflecting GSI's legacy of scientific excellence and its continuing commitment to advancing geoscience for national development. Today, we will begin our deliberations with a set of stimulating plenary talks that highlight the breadth and depth of modern geoscientific research. Our first plenary will focus on the role of high performance computing and geophysical inversion in mineral exploration, an area that is transforming the way we acquire, process, and interpret subsurface data, enabling more efficient and precise resource identification. The session will shed light on how computational advancements and innovative inversion techniques are shaping the future of exploration. Following this, we will delve into an equally fascinating domain with a plenary on sauropod and theropod dinosaur evolution and phylogeny. This talk will take us back millions of years, exploring the evolutionary pathways, diversity, and biological significance of these iconic dinosaur groups. It offers us a glimpse into deep time Earth processes and enriches our understanding of past life and environments. It is now my privilege to introduce today's first plenary speaker, Professor Mrinal K. Sen, Professor and Jackson Chair in Applied Seismology at the Jackson School of Geosciences, Texas University. Professor Sen is an internationally acclaimed geophysicist whose pioneering work in theoretical and computational seismology, global Earth structure, and lithospheric dynamics has shaped modern geophysical research. With over 250 scientific publications and over 3 decades of distinguished contributions, he stands among the most reputed figures in contemporary earth science. He has held several key leadership roles, including director of the Institute for Geophysics at University of Texas, Austin, and vice president of the Society of Exploration Geophysicists, and has been honored with multiple fellowships and awards for his outstanding scientific impact. Please join me in warmly welcoming Professor Mrinal K. Sen.
Can I get the pointer? Okay. Good morning, and thanks for inviting me to this conference. It's really a great pleasure for me to be here. So, in the next 30 minutes or so, I'll talk about some of the computational work that are applicable for mineral exploration, especially in geophysics arena. So this is my general outline. I'll start with some background and talk about some new developments like use of active seismic experiments and passive seismic experiments, multi-physics data integration, and then talk a little bit about HPC and parallel computing. This pointer is not working. Okay, now this slide, I have some background information which everybody is familiar with. Traditionally, we have been using potential methods and like magnetic surveys, gravity surveys, EM, and so on. But as they say, resources that were easy to find have already been found. So now we have to really look into how we can try to find something that is not easily discoverable. And for that, we have to make use of some technology, particularly seismology. I have not seen many applications of seismology for mineral exploration, but in oil and gas exploration, we have been using this for decades and we continue to use it. So this can be used particularly to produce detailed, high resolution images of structures. And we have methods like reflection seismology, refraction seismology, and a new method it's called ambient noise tomography, which is generally used by earthquake seismology people, also has some potential for application in mineral exploration. So here, the reason seismology looks attractive is because now we have low-cost seismic nodes, and seismic data volume is huge, and the processing takes a long time on conventional computers. So we are making use of advanced computations, like we have one Texas Advanced Computing Center in the same building where I sit. And we have advanced techniques like reverse time migration and full waveform inversion and machine learning for analyzing those data sets. Okay, to basically put us all on the same page, what's new here? This is an image of the subsurface. The same data set has been used both to your right and to the left, but using different techniques. The one on your left is the conventional approach that used sort of incomplete physics, approximate physics. The one to your right is the same data, but that makes use of more complete physics and high performance computing. And you can see there is a day and light difference in the images. For example, the flank of the salt, which is hardly visible on your right, is very well imaged to the left side, and also the base of the salt has been imaged. Okay. So what has been done here is the steps called reverse time migration. So we use numerical tools to forward propagate the seismic waves. We backward propagate the data and we cross correlate. And at each step, it involves numerically solving wave equations. And that's where the computation cost is. Now, one other method that is actually the state of the art is the full waveform inversion. So here we make use of the complete data set, like we put the short gathers, and then we start with some starting solution, some velocity model. We solve the wave equation, and then we generate synthetic data. We compare against observation, and then the difference between the predicted and the computed data is what is used to update the velocity model, and it's repeated in a loop. So there are these steps here, forward modeling, And then adjoint computation is the step where we calculate the derivative. And then we apply optimization and we get a velocity model, and we can also estimate uncertainty. UQ is uncertainty quantification. And this whole approach is CPU and memory intensive. Okay. So I'll show you a couple of examples from the published work for mineral exploration. So this is a synthetic test where a model was built for subsurface using for deep metal ore bodies. And here they make use of seismic full waveform inversion. And this is how they set up their calculation. This is the 2D velocity model. It shows true velocity model. And the one in yellow is the body that is of interest. And what they have here is active shooting, where they have the sources on the surface and the receivers on the surface. And they also put in some sources inside the body, like a small earthquake sources, which we call passive data. So the idea here is that we first use the passive data to get a velocity model, and then we use the active data together with the passive data to get the full model. And these are the short gathers. The one on your right is the short gather for the active source. The one on the left is the short gather for the passive source. Passive source data are lower frequency. A combination of these then give you, not sure what happened. Can you fix this one? Something went wrong. Okay. That went into presenter mode. Okay, so then what's happening? Okay. So if you look at the result, on your right, you have the initial velocity model, which is the smooth one. If you just use the active data, you get an image which is pretty decent, but it has not imaged the body that we're interested in. But when you combine the active and passive data, we get a solution that looks very close to the subsurface. The only reason I wanted to show this to you is that introduces you to the complexities that we run into. Now, I found a recent work of FWI in field data. So this is an area from Sweden, Ludvika mines. And here, the objective was to delineate the deeper extension of mineralization zone. And here, we're showing you those green and blue lines. Those are the receiver lines. So 3D seismic data was collected in this particular area. And time domain 3D acoustic FWI was used here. And the first step, this is all land data. And the first step is to do some processing to improve signal to noise ratio. The top panel shows you raw data. And the bottom panel shows you the data after it has been processed to improve signal to noise ratio, where you can see the reflections are much better pronounced. And this is the data set that is then used for FWI processing. So what does it look like? Here is the final result. So here we have two slices. So this is basically inline and cross-line direction. And what you see here is some interpretation of the results. The blue arrows shows you some high velocity zone, and the black arrows are the faults. And in the bottom panel is the interpretation of the zone with the magnesite-rich mineralization body, which has been picked from the three-dimensional volume. And this was basically the outcome. So the major deflectors is interpreted as a cross-cutting fault, which is restricting deeper extension of the mineralization with depth. Now, this is the kind of thing that you get to see from the three-dimensional images that have been obtained from the field data. And this is something that you can't really imagine from looking at the surface expressions. And this is only possible with the use of seismic data and with FWI. This is one of the most interesting developments in seismology in the last couple of decades. What if you don't have enough resources to go and collect seismic data? All you do is to throw in a whole bunch of receivers and let it record noise. And then what you do is use the noise. Let's say here I have two receivers, X1 and X2, and the stars are the sources of noise. So one example of a noise series is shown on the left panel. And all you do here is cross-correlate the noise recorded at X1 with that recorded at X2. And then you sum those. And that gives you a virtual experiment as if you had a source at X1 and a receiver at X2. So without actually going to the field, and of course it has limitations, but this will give you data which can be used to get the first sort of first-hand velocity model estimation. And it's not necessary that you have to have sources all around. You can have limited sources of noise, like the one I showed you in the last panel. Even then, you can record something which is basically surface waves. So how good is the data? Well, this is an example from some stations of the west coast of the United States. And I showed you there panels B, C, and D. So B and D, B is actually the earthquake data. And D is the one that has been obtained from cross correlation. And if you look at those, they look very, very similar. Okay? So then all of these data sets that were essentially generated from cross correlating noise, we can generate the group and phase velocity surfaces. And from there, we get velocity model. And there has been some recent work on the use of this technology for mineral exploration. So here is an example from Germany. And this is where they actually looked at some of the metal provinces. That is the area that was studied. And all those plus signs that we have on the figure are the instruments. So all that they have done is put a bunch of seismometers there, and they recorded noise. So then, and at the same time, they had some 3D airborne time domain electromagnetic data set. Now, if you pay attention to the sequence of topics that I'm talking about, I started with very simple geophysics, then I said active seismology. I'm talking about passive seismology cross-correlation technique, and I'm now talking about some data set together with it, which is basically electromagnetic data. So I'm talking about multi-physics data set. So using these, this is basically the kind of picture that we generate from the noise. So here what we have, and the bottom panel is essentially a spectrogram plot that shows you frequency content as a function of time. And the top panel on the left hand on the left side shows you the direction from which the energy is coming. But the most important is this particular picture where it actually shows you a gatherer. Okay, it's almost like doing a seismic experiment and collecting those. All right, so with those, so these are the results. On the panel A are the vertical slices of the seismic velocity model. The middle panel is your EM size resistivity sections from the EM data. And the most interesting thing is that this particular work made use of seismic image and the EM image to come up with joint interpretation and essentially doing a classification of different objects and phases. Okay, so from single data, we've gone into multi-physics, and then we have used a technique here, which is machine learning. Okay, all right, so what is machine learning? Well, most of you have heard this term. So machine learning, we input the data and you get your desired output is a black box. Okay. In the blank box, you have something like the structure I showed you down there. It's a neural network. And you have so many architectures now that I can't even put one figure to represent it all. But this is the basic idea. So in this neural network, we have some input data, and neural network has some parameters which are called weights. And then it produces an output. So essentially, it finds a mapping between input and output. And it essentially comes up with a function. And for that, we need to adjust these weights. And the adjustment of these weights are done using some known results. Okay? And when it starts to predict the known results accurately, then we say that we have the right kind of weights. Okay, so I'll talk about this particular example of time-lapse time-lapse seismology for CO2 monitoring. So here we have an injector, and say we have another location where we are basically tracking the CO2 movement. So essentially what we have in terms of data, we have 4D seismic data, time-lapse seismic data. We have production in the sense that we have the monitoring data, and we're supposed to match both of these such that we get a subsurface model which is consistent with both. So that involves two physics. One is the seismic physics, another is fluid flow. And this can be done using physics-based method where we have to solve Navier-Stokes equation type of fluid flow solutions, and also we have to solve elastic wave equation, which is computationally quite expensive, but it's doable. So it's a large-scale optimization problem. So another thing I wanted to point out is that traditionally geophysics community have been using what is known as white model. That means deterministic equation. We assume that I know the physics, say for seismology, wave propagation theory. For EM, we know Maxwell's equations. That is the physics. So everything was physics-based. Then on the other hand, we have this black box approach, which is essentially agnostic to the physics of the problem. But in between, we have a gray zone where you can make use of both physics-based and the data-driven methods. And that is the approach we are taking. So here we have some data from Cranfield in Mississippi. And here we have time-lapse seismic data, and then the CO2 was injected into scalar formation. So this is the network. We call it, this is an invertible neural network. So this is a two-stage approach. I will spare the technical details, but just focus on the objective. So first, we input the data before injection and solve for porosity using this network. And then we put the monitor minus baseline data, and then we try to estimate changes in saturation. And the reason it's called invertible is because it can go both forward and backward way. And it can also give you uncertainties. So this is the kind of results you get. This is a map view of porosity at the reservoir level. You can see how the porosity changed. At the same time, we can get some kind of estimate of uncertainty. And this is basically the saturation estimation, and a lot of these have been verified from the hard data. And once the network has been trained, this actually goes very, very quickly. So that was the main purpose. Now, another approach I wanted to show you is for lithium, which I'm not an expert on, but I teach a course on machine learning in geosciences, and I give assignments to students. So one of my students took up this project. It turned out to be very, very interesting, so I just wanted to share it with you. We were writing a paper on that. So here, the goal was to predict areal distribution of lithium and likely identify key geological features. We used here something called a random forest regressor, and also looked at something called SHAP values. Okay, so
Across the average about 50 parts per million, 50 grams per ton in global ocean. Now this just shows one being collected. This is where it was attached to the substrate rock. This is what, if you cut that in half, this is it. Started growing here 70 million years ago and was growing when we collected it. So seafloor massive sulfides, they precipitate from hydrothermal fluids up to 450 degrees centigrade at extreme variety of depths. Gray and black smokers are mostly composed of iron sulfides and sulfates, and deposits rich in copper are the ones that are great economic interest. The dead systems are of the greatest exploration interest, and vent fields are hydrothermal. They die and come alive on a regular basis. So this is the distribution of vent sites throughout the global ocean in spreading centers and in volcanic arcs. There are 3 ISA contracts in the Mid-Atlantic Ridge up in this area, and there are 4 on the central and southwest Indian ridges. There's soon to be a 5th one in the Indian Ocean, I think up in here, that India is about to get. So India will have 2 sites in the Indian Ocean. Basically, the principle of hydrothermal circulation is seawater goes along fractures and heads towards magma chambers and heats up, and then also acquires chemicals from the leaching of the volcanic rock. And with the fluids, these fluids that go down are returned because they become buoyant due to heating up. They can become, as they move back toward the seafloor, they cool by conductive cooling. And if that happens, you get under different temperatures, white smokers, lower temperature, and black smokers, higher temperature. They can also cool by mixing with seawater. And in that case, normally you get diffuse flow fluids, less than 120 degrees centigrade. And in all of these different areas where hydrothermal systems form at the seafloor, they have their own different biological systems. So these are some chemistry. There's a lot of different areas that hydrothermal sulfides and sulfates can form. The highest zinc concentrations are over 18%. Highest copper are over about 13%. They're about 13%, and high lead to 10%. But the precious metals are really amazing. They can be for silver in this type of deposit under continental rift, 1,000 grams per ton or parts per million, and gold can be up to about 15 grams per ton or parts per million. Very high concentrations. So these are essentially copper, zinc, gold, silver ores. And they can also have these other rare critical metals in various areas, more so in volcanic arcs rather than spreading centers. Yeah, some tonnages. We're going to look at some tonnages in comparison with land-based. These are our maps that I showed earlier. For polymetallic nodules, there's about 55 million square kilometers of area that they occur. And for ferromanganese crust, about 39 million square kilometers. Together, it's almost 95 million square kilometers of area. Now, nodules comprise, in terms of tonnage, about 210 billion tons, and crust 930 billion tons, dry tons. And they're obviously a major resource for critical metals. If we look at the crusts and nodules, we can calculate the tonnages through the global ocean and get these kinds of values, 219 billion tons and 227 billion tons for manganese, etc. Cobalt, 5.15 billion tons, and rare earth elements, 2.35 billion tons. If we look at those in relationship to the identified global terrestrial resource, which are listed here, for example, manganese would be 5.2 billion tons. So it's 44% more abundant in the deep ocean deposits than it is in the identified global terrestrial resources. 9 times greater for titanium, 206 times greater for cobalt, and 16 for nickel, 6 for rare earth elements. The different one is for the land-based is much higher for copper. And it's also much higher for lithium and bismuth. But generally, all the rest are higher in the deep ocean than in the terrestrial global resource. Thallium is 209 times higher. I don't have the numbers here for tellurium, but tellurium is 650 times higher. So key findings of the new work that we've done on the global distributions is that hydrogenetic nodules cover 75% of the permissive nodule areas. Mixed origin nodules, the ones that are looked at in greatest interest for mining, cover only 22% of the permissive nodule area. Diagenetic nodules, 3%. So whichever is mined, this all determines actually which associated elements will dominate on a global scale. Of the
Additional powers. So we built parallel machines. This is from our advanced. We have I think in Texas, you have the probably biggest parallel computer in the country in academics. So these are some of the machines that we have: Stampede, Wrangler, Lone Stars, and so on. And what is really intriguing is making use of something called GPU. I'm not sure if you all are familiar with GPU. It's called Graphics Processing Unit. Every laptop, every computer has a graphics card. And the difference between the standard CPU and the GPU is that on GPU, you have a whole bunch of processors with very small memory, though, very fast processors. So GPU memory is limited, but CPU RAM is not that small. So all of our codes for simulation and inversion are now written on GPUs and make use of CPU as well. So we have to be able to transfer data from CPU to GPU, do the compute part on GPU, and bring in the results to CPU. And that has to be done the very, very fast way. And this is something that requires a lot of thinking in terms of algorithm. And one has to really understand the mathematics behind every algorithm to be able to do that. And we have been doing that. So with that, I'd like to summarize that I tend to see widespread application and integration of disparate and massive data sets. It's already started. We'll see more and more of these. Application of seismic technology. That is something that is not talked about a lot, but in the mineral industry, but I think we'll get to see more of those together with use of RTM and FWI, plus seismic interferometry, and then classification, interpretation, and ML modeling of large volumes of data. So advanced algorithm and HPC is what can help us basically to find resources that are not that easy to find. So with that, I'd like to thank you. And yeah, I read somewhere in the internet that somebody said that when I feel stupid, when I feel that I'm stupid, I remind myself that I managed to get my undergraduate and PhD without ChatGPT. So thank you. This is meant to show that we should not use these as black boxes. Thank you.
We now invite any queries, if there is, from the audience. Please bring the microphone.
Hello, sir. I am Paritro Mukherjee, a third-year undergraduate student from West Bengal. First of all, thank you for your amazing session. My question is regarding the black box. As far I know, black box is used for decision making, but it had a tendency to give wrong results. So how do geoscientists working in the AI/ML field validate if those results given by AI are right or wrong?
Okay, so again, it's a pretty involved question. So the thing is that AI cannot give you something that you yourself have not learned elsewhere. Okay, it just generalizes it. Again, I'll say this with a caveat because there are a few other things you can do as well, but that would be like more high level answer to your question. And like any other, for example, geophysics, geophysics gives you an image of the subsurface. How do you know it's correct? No geophysicist will tell you that you drill exactly to 500-meter depth.
You have 24 of these, 24, 25 of these going around. One breaks down, you pull it back up and fix it. You still have a big nodule operation going on. If you have a big crawler on the seafloor or two big crawlers on the seafloor and one breaks down, you have to pull it up. You lose your business. Pretty much your business is then non-operational. So this has not only the advantage of not disturbing sediments to a great degree, it will still disturb them a little bit, but it maybe have an advantage with the durability of the mining operations. So there's a lot going in right now looking at vehicle design with artificial intelligence, machine learning, deep learning, and all of this AI use. Mining without a sediment plume is key to environmental acceptance. Leaf nodules without biology or with biology. Thank you.
Thank you so much, sir. Thank you. The session is now open for Q&A. Any questions or queries from the audience are welcome.
Dr. Hain, it was a very interesting talk. I just want to know how did you measure the growth rate of the nodule as well as the crust? What methodology was the most appropriate you find?
Oh, I think for thin crusts, yeah, so there's many different ways to date them. But I think radiometric dating for thin crusts is really valuable. I think uranium lead has not been used much, but I think that's a really good technique as well. But yeah, beryllium isotope, if you have a thin crust, is probably the best way to go. Uranium series, if it's a very thin crust. If it's a very thick crust, you have only a few options, and they're all rather long options. And osmium isotope is, at the moment, is the best way to go. But you can also do it through paleomagnetics and through biostratigraphy. And the Russians have done a lot of the biostratigraphy, and the Japanese have a lot of the paleomagnetic dating. So generally, it's been osmium isotopes and beryllium isotopes have been the two key ways to do it. There are also some equations that have been derived to date them, and Halbach in his group designed one, and Frank Mannheim and his group designed another. Frank was with the USGS at the time. And so those equations are commonly used because it doesn't take any equipment, it doesn't take any special knowledge about doing beryllium isotopes or osmium isotopes. So a lot of people do it, and it's really kind of it's definitely it's got rather large error bars on using those techniques. I think the Mannheim equation is best because Frank Mannheim used a very large variety of manganese and iron manganese.
Thank you. And now I have a microphone. That's easier.
Yeah.
So I'm really interested in the use of seismic approaches for mineral exploration. But I can really see that if you have mineralization in a sedimentary basin, whether it's sediment hosted or structurally controlled, that you might be able to use seismic approaches to understand that. But in more complex geological settings, do you think that seismic approaches can really be useful, considering, as you've shown so nicely, how much more we can now resolve that sort of complex structure?
Yes, I do think that seismic can give you a lot more than what you can from other methods, other geophysical methods, with a caveat. But first of all, if you are interested in directly imaging the ore bodies, that may not be possible because if there is no acoustic impedance contrast, then you cannot see that in seismic. But seismic can give you structural details which you can supplement with other geophysical methods to do the interpretation for the ore bodies. So yes, I do believe that seismic can give you a lot more information.
Thank you. Basically, that ties into what you were saying about integrating all the different data sets.
Yes.
Yeah,
Yeah.
really interesting. Thank you.
Thank you. Okay. Okay. Thank you.
May I now invite our esteemed Director General GSI, Shri
To
Asit.
carry out a different approach, and as well for the Andamans you have to go for a different approach. So can you please enlighten us how to move forward and to bring out a correct resource position so you can go for further exploration in that area?
Yeah, I mean, always the issue with the manganese nodules is what's the best way for expert.
Now we'll move on to the second plenary talk of the day, and it is my honor to introduce our next distinguished speaker, Dr. Jeffrey Wilson Mantilla, Professor of Paleontology in the Department of Earth and Environmental Sciences and Curator of the Museum of Paleontology at the University of Michigan, USA. Dr. Mantilla holds a PhD in organismal biology and anatomy from the University of Chicago and is the co-author of the well-known book, The Sauropods, Evolution and Paleobiology with K.A. Curry Rogers. His extensive and influential work on sauropod dinosaurs has made him one of the most widely followed researchers in the field. His research continues to reshape our understanding of the dinosaur evolution, diversity, and paleobiology. I'll now invite Dr. Mantilla to kindly take the podium and deliver his talk.
Thank you very much. It's such a pleasure to be here and to be part of congratulating GSI on 175 wonderful years of their history. I wanted to thank additional DG Vijay Mughal for the invitation, and I'm looking forward to talking to you today about India at this kind of crossroads in Earth history. The crossroads that I'm going to be talking about today is during the Cretaceous Paleogene transition. And so, next slide. The research that I'll be talking about today was conducted under auspices of MOUs with the GSI as well as with other institutions. And I'm standing here alone, but I'm really representing a multitude of collaborators on both the Indian side and the US side. And so I'm very pleased to acknowledge them and to acknowledge the funding bodies that have supported our research over the years. I was reflecting this morning that my first collaboration focused on fossils that are from GSI Jaipur, just a little ways up the road from here, just a little bit north of here, and resulted in the description of a dinosaur that was found not far from here. The images that you're seeing are from where that dinosaur was collected in Gujarat. And I wanted to mention that the GSI has been instrumental and fundamental in all of that. In fact, it was the GSI and Dhananjay Mohabi, my colleague sitting here, who you've seen in the images, who opened up the western part of India towards dinosaur research. And in fact, that the image that you saw at the very end where we were focused on those dinosaur eggs says Geological Survey of India. Next. The motivation for my research is encapsulated in this series of images, these paleo coastline reconstructions that show India's position marked with the dot during the Phanerozoic. The principal question is how this tectonic pattern, a pattern of fragmentation, isolation, and reconnection, how that affected that
Climate modeling and understanding of Indian monsoon and its variability, mesoscale hydrological modeling, water resource systems, urban climate, and simulating land surface feedbacks to climate. He has more than
palimpsest. And we can see that in deep time 2, where the Indian plate biota should have sort of hints of its Pangaeic past, its Gondwanan past, a past in which it was isolated, and then more recently a past when it was connected to Asia. Next. Fortunately, the sedimentary deposits that preserve the fossils from this, that record this transition, have been preserved by the emplacement of the Deccan Trap volcanic system, which was much more extensive in the past, but even now is quite extensive. And along its fringes preserves sedimentary deposits that are below it and within it. Next. In the 19th century, going way back, there was developed a terminology that was useful in the field for recognizing sedimentary packages that are within the traps. Those are called intertrapians, and sedimentary packages that are below the traps. That shorthand, which is so simple and effective, eventually became a proxy for age. That is, the infratrapian rocks were thought to be older and all of the same age than the intertrapian rocks. So we had kind of this bimodal, if you want to think of it that way, sense of the age of the trap associated sediments. Next. This misconception was in part dispelled by efforts from the GSI, especially their flow-wise mapping of the Deccan Traps, which indicated that that many different flows can be capping or can be intercalated with sedimentary packages, and therefore should be of different ages. However, there was no absolute dates attached to this, and that 19th century infra-intertrapian dichotomy sort of persisted. Next slide. The work that have been involved in since the late 90s, early 2000s here in India in collaboration with GSI has endeavored to better understand the Indian plate biota and to put it in a chronological framework. And that has taken place very slowly because a lot of the work for understanding the Indian plate biota is by virtue of field exploration and museum work, which is very time consuming and tedious. It's also through efforts in the field to understand the paleomagnetic and geochronological ordering of these beds. Next slide.
So this one, with this, okay.
It can't, actually.
It does not work.
No. This image is still unpublished, but in a way it summarizes a lot of the chronostratigraphic framework that we've begun to construct. And so it's slightly noisy, but for each of these localities, you can see that there is a name for the locality, the PaleMag and geochron data, as well as a bar on the right-hand side that indicates its relative age. And so you can see some of them have a bar at the very bottom, those are the oldest. Some have a bar at the very top, those are the youngest. And then there are little icons there that reflect some of the organisms, the key organisms that we see there. Because what we would like to do is to look at how the organisms change through time, as well as to see how their connections to to other land masses change through time. Okay, and so we'll go through these in chronological order, and I'll show you some of the key fossils, not all of them, but some of them in these images, and we'll talk about them. And so the very oldest of the trap-related fossil horizons that we have in India for the Cretaceous-Paleogene transition are found in Gujarat. And they include these infratrappean horizons that we find at Rayoli and at Doli Dungari. And so you can see here in this image that we have two carnivorous dinosaurs shown at top and bottom on the right, Rahiolisaurus. Rajasaurus is the dinosaur that was found and was housed here in Jaipur. This is the specimen that we jointly described with GSI geologists back in 2003. On the left, you can see we saw a rotating image of a trunk vertebra, a backbone of a long-necked dinosaur that we think might be related to something from central India. Next slide. At the site of Doli Dungari, my colleague Dhananjay Mahabi discovered this fantastic fossil that we jointly described. It's a moment in time that's been captured, frozen, in which we have a dinosaur having just emerged from an egg. You can see that in the right-hand side of the fossil and in the image there, is at the point of being attacked by a snake that is wrapped around the egg that the dinosaur just emerged from. So if you look at the snake, within the coil of the snake is a smashed egg. There's an intact egg next to it, so we know that this is the smashing of the egg.
Yeah, and then
have preserved this really an extraordinary series of sort of a complex tapestry of evolution. So we have the evolution of snakes. We see that it has Sanaja means ancient jaw. This is a snake that had a very primitive jaw function and was able to eat a dinosaur not by having the ability to open its mouth wide, but rather by being large. It's an early strategy in snakes. We also see some of the early ontogenetic or developmental stages of a dinosaur preserved here. And we see some of the ecological challenges that those animals faced, some of the motivations for these. This is a large, the adults of these are very large, but they're born from eggs, they're hatched from eggs. And so there's a pressure for them to grow quite quickly. Next slide, please. Next, we have Anjar. This was originally thought to be a KPG site with an iridium anomaly.
Is very important. But if you neglect land atmospheric feedback, you can see there are overestimation of evapotranspiration. There are a lot of issues, series of issues which can come that will really result into wrong finding or sometimes uh, 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 incomplete understanding about the processes. Now, this is the paper which came out just yesterday. Yesterday night it was published in Nature Reviews Earth and Environment. Today morning I was just and in the airport I was looking at it, and then I found that this paper just got published. And this is very interesting thing. The first thing, what? So what are you talking about is AD covariance network. So
slide. We'll continue moving through. There are some important sites that are not associated with the Deccan traps, and so we find it more challenging to understand their exact age. It's very likely that these sites in southern India, the Kalamadu sites, are quite old, and they preserve a wealth of turtles, including this fantastic side neck turtle called Kermademes, which was the first really well preserved turtle found from the Cretaceous of India. On the left-hand side, you can see some examples of the carnivorous dinosaurs that were found there. There are also crocodiles and other animals that were found. Next. The Vitakri Formation of Pakistan is another area that's of signal importance to the Indian plate and understanding its biota. The material from the Vitakri Formation, it rivals the material we have here in India in terms of its numbers, and it preserves both organisms or taxa and body parts that we don't have in India. So on the left-hand side, we have the snout or part of the skull of a sauropod dinosaur. There's not a single element we have like that in India, but we have it there in Vitakari in Baluchistan in Pakistan. On the right, we have the only named crocodile from this time period. It's one of these long-legged crocodilians that was terrestrial. It's called a Notosuchian. It has blade-shaped teeth. It looks very much like a theropod or a carnivorous dinosaur. In fact, if you found the teeth in isolation, you might think you had a dinosaur, but in fact, these are dog-like crocodiles that were predating in Pakistan and likely in India in the at the end of the Cretaceous. Interestingly, the closest relative of Pabveshi, as that thing's called, is found in Brazil. Next slide. In the Chandrapur district of southern Maharashtra, we have some of the best sampled and some of the most prolific sites. Both Pizdura and Dungargon are quite old, found in the 19th century, described in the 19th century. An almost complete body. We still don't have the wonderful turtles that we collected from this area that were found side by side. And we are in the process of describing those right now.
शुभ दीपावली 2025 आप सभी के लिए मंगलमय हो यही कामना करता है आपका अपना महेश नगर व्यापार मंडल।
महेश नगर व्यापार मंडल आप सभी का हार्दिक हार्दिक अभिनंदन करता है।
महेश नगर में आने वाले सभी बंधु अपने वाहन को सही जगह पर पार्क करें, स्वच्छता सफाई का पूरा ध्यान रखें। विज्ञापन के लिए संपर्क करें प्रिया टेक्सटाइल व राज बुक डिपो विकी जी। मोबाइल नंबर 96719406 नवीन कुमार 926156726। दीपावली की शुभकामनाएं आप सबको देता है अम्बे वीडियो हॉस्पिटल 115 महेश नगर जयपुर।
अजी सोना पानी
बोल भाग्यवान का ही बात है।
अजी मेरी कमर में दर्द हो रही है मैंने कोई अच्छा से डॉक्टर में दिखाओ।
अरे भाग्यवान आपने पास ही अम्बे फिजियो हॉस्पिटल है। बताएं डॉक्टर संदीप भारद्वाज के द्वारा हजारों लोगों को कमर दर्द घुटना को दर्द 15 साल पुरानी दुकान श्री बालाजी पान भंडार।
हमारे यहाँ चॉकलेट पान फ्लेवर पान चॉकलेट आइसक्रीम इत्यादि सामान उपलब्ध है।
जी हाँ आपका अपना श्री बालाजी पान भंडार प्रोप्राइटर राजेश शर्मा।
3D models that are with us here in India. A brain case is at the GSI in Calcutta. The osteoderm body armor was found with these things and interpreted to be a completely different dinosaur, an armored dinosaur. In fact, it belongs we think to Janosaurus. Those bones are at the American Museum in New York. Next slide. On the same site, we also have theropod dinosaurs, carnivorous dinosaurs. Limetosaurus indicus was one of the first theropod dinosaurs named from India. Those bones are all lost. We have no trace of them. I've looked many different places. I've asked colleagues to look. We don't have any remains of these animals, just the photographs. And they're big. They're bones that are quite large. Indosaurus, another skull you can see in the top middle, it's also lost. Levisuchus indicus is small dinosaur. Its vertebrae are about the size of what I'm showing you here, a couple of inches, very small, beautiful dinosaur, preserved at the Geological Survey of India, along with Indosuchus. I'll mention that there's this collection at the bottom center that Durgasankar Bhattacharjee of the GSI and Charles Matley collected together in the 1930s a whole range of fossils that have never been described. They include many bones of carnivorous dinosaurs that are in the GSI waiting for someone to access them and to study them. Next slide. This is unpublished data that we collected a couple of years ago. An associated sauropod dinosaur, a titanosaur. That's its femur there. That's the only bone we were able to collect. This is in the bed of the Gaur River in Madhya Pradesh. It's a very difficult site to work. It's flooded many months of the year, and then when it's not flooded, the rocks are extremely hard and often very difficult to collect. And so it took us several days to just remove this one femur. Many bones remain there, but we unfortunately have not been able to collect it yet. But this is one of the youngest, this might be the youngest dinosaur that we have on record in India and perhaps elsewhere. It is from the last 200,000 years of the Maastrichtian. So this could be India's last dinosaur. And we would very much like to excavate it, but it's currently inaccessible. Next slide. Nazcal, I'll try to breeze through a couple of these so we can get to some of the interpretations. Nazcal is the first site, microsite, that was collected by GVR Prasad and Ashok Sani. Ashok Sani trained in the US, and in the 1960s and 70s, he wrote an influential article about microsite collection in India. And over the next 10 or 15 years, he and his students spent a lot of energy trying to collect, to find mammals, and they finally did at this site, Nazcal. And they were surprised because the fossils that were found there are eutherian mammals. So they're more advanced than some of the mammals we find in some of the other localities in the Southern Hemisphere. And so you can see some of the mammals that were collected from this place. They include Sanithurium in homage to Ashok Sani, Indoclemencia in homage to Bill Clemens. These are famous mammal people, as well as Decanolestes, the Deccan runner. Next slide. Kesavi is a site that I have never been to, but has been described. It includes a whole range of lepidosaur material, so lizards. And you can see a jaw of a thing that was called Deccansaurus recently. Next. Kisilpuri, this is a really tantalizing site because it preserves what has been suggested to be some of the first ungulate, the first relative of hoofed mammals. The age of this site is currently what we're in the process of resolving. It's been suggested to be Maastrichtian, but we have reason to think that it might be younger than that. And so in addition to mammals, we also have crocodiles there, but no good examples of dinosaurs. Next. I'm showing you here a site that's relatively, it's actually old, but this recent work there has produced a new fantastic turtle. I have a three-dimensional model or cast of it here if anybody would like to see an example of it. But this is a new species that's going to, I think, as I'll talk about in a moment, tell us something different about what's happening to the Indian plate during the Cretaceous Paleogene. This is a site that we think could be Paleocene in age. It's between Maastrichtian and Paleocene. It includes mammals, crocs, and turtles. Next. And the youngest of all the sites we have is this site from what are called the Bombay Intertrapians. This is definitively Paleocene in age. These sites, this site, unfortunately, is basically extinct. And so it used to be quite extensive, both the basalts and the intertrapians between the basalts. And now they are completely built over. There's no, to my knowledge, no exposure of these, but hundreds, if not thousands, of frogs. That's what you're seeing over here. Hopefully you can see the frog of this thing that were first described in 1847 by Richard Owen in Dubotrachus. Hundreds of these, thousands of these frogs have been collected and are in museums around the world. We also have a singular example of a turtle that was crushed so flat that it has no dimensionality in side views. It's really fantastic fossil. And again, it's going to be pointing towards, I think, an endemic radiation on India. Next. Okay. So I went through in a very short time what it's taken me and my colleagues a very, very long time to understand. That is the taxonomy and relationships of the Indian plate biota during the latest Cretaceous and the earliest Paleocene. I really can't tell you how challenging it has been to piece together a lot of what I just breezed through. It's really the meat of what we've learned. I want to try to pull it together a bit by referring back to a paper that was published in the Memoirs of the Geological Survey of India back in the 1930s. That is in the pre-plate tectonic, sort of a stabilist regime where scientists recognized the biotic or biological connections between India and the rest of the world. And so Von Hune and Matley recognized that India looks like the Indian biota, or the dinosaurs look like dinosaurs from Madagascar. At the time, there was no way to explain that connection. And so lost continents were invented, land bridges. Lemuria, if you've heard of that, was created in part to recognize the lemurs in Madagascar. But that ancient landmass was meant to be what was connecting India to Madagascar. So there's a long history of recognizing the Gondwanan connections between India and the rest of the world. And in fact, by and large, with all of the research that we've done, almost every single dinosaur, crocodile, mammal that we've collected has its closest relative on another landmass, either Madagascar, South America, or Africa. Next slide. And this is a compilation. I don't mean for you to read this at all, but this is a compilation of all the named taxa that we have from the Indian plate that records everything that we think is a valid species, the best we can do for its their age, and then their relatives. And almost all of these have a relative in Madagascar, and in Africa, or in South America, as I said. Next slide. The only sort of numerical or quantitative analysis of biogeographical, that is the relationships between organisms in space and time, paleobiogeographical analyses, this cluster analysis suggests that India finds itself within a cluster of Gondwanan landmasses that's just outside a cluster of European landmasses. So India, which you can see there in red, is connected very closely to Madagascar, which I think is in pink or in gray, can't tell, and connected very closely to South America in blue. And so the vast majority of Indian plate biota, despite the fact that India should have been isolated during the Cretaceous, show connections to other land masses. Next slide. There are only one or two, next slide, please. Yeah. There are only one or two lineages that show any evidence of endemism in the Indian plate biota during the time it was geographically isolated. So endemism is when organisms radiate within an isolated landmass. And the way that we would recognize that is to find a family or a grouping, a taxonomic grouping of organisms that are restricted to India. One of the only and maybe the best example we have of that comes from these turtles. Kermademes and its relatives are called Kermademene turtles. And we now have 4, and there's soon to be 5 of these turtles that are, we think, that have radiated in India and are disconnected from the rest of the world and show a small bit of evidence of endemism. There are mammals that also seem to show that, but it's really just the turtles and the mammals. One of the things that I will suggest is that a component of this heterogeneity is related to sampling. Turtles are among the best and most diagnostic animals that we've collected. Mammals, similarly, if we find just one tooth of a mammal, those are always very diagnostic. And so we can say with great accuracy where their affinities lie. For the dinosaurs, we just don't at this point have enough of them to even recognize a group. All endemic lineages start out as a single organism that has a relative somewhere else. And that, I think, is the stage we're at for many of these other animals. Next slide. I wanted to end with a few slides that offer a prospectus on maybe where to go in the future. And these are all directly related to either challenges that we've faced during the process of putting together the research that you've just seen, or ones that we've seen elsewhere that nevertheless apply to India. So I'm showing you here a view from the south, sort of a pre-plate tectonic view from the south. Next slide. And I use it because I want to remind you and to qualify what I've said by reminding us that we have heterogeneous sampling. The southern land masses, India, Madagascar, South America, Africa, Australia, Antarctica, are all much more poorly sampled than the northern land masses. But within them, they're also unevenly sampled, and the rock record is unevenly distributed. For example, in India, we have for the Cretaceous, we know that best for the Maastrichtian. That's the same for Madagascar and Antarctica. But we don't have Maastrichtian in Australia. We barely have Maastrichtian in Africa, and we barely have Maastrichtian in South America. So the comparisons that we make are really unequal. We can't compare to Australia. And that's a challenge. And so one of the things that we need to do is to, if we can, explore. There are rocks that are slightly older than the Maastrichtian that preserve fossil remains here in India. And we need to push towards understanding those a bit better to begin to make connections to other land masses. Next slide. We also have this issue of dark data to think about. Paleontological dark data is a global phenomenon. It's not restricted to India. In fact, a study of dark data in North America that looked at some really well-sampled Miocene localities in Oregon and California found that only a fraction of the data that's publicly available or scientifically available, only a fraction of the data that we have is available. The vast majority of data is in museum collections and is unpublished. And therefore, it's sort of out of the view of all but the scientists that go to those museums. And so that's a challenge for us. And so we should think about publishing or making available the data that's available in our museums here. Next. When I was invited to this symposium, the first thing I asked was whether there would be scientists from the Geological Survey of Pakistan that would be here. Because for the first 100 years, the Geological Survey of India was bigger geographically than it is now. And I realize this is a sensitive topic, but really the science should extend ideally beyond borders. And so to understand the Indian plate biota, we really have to look at material from Pakistan. This is MS Malkani. He's a colleague of mine. He should be a colleague of yours. He's collected on his own almost hundreds and hundreds of dinosaur bones. You can see him standing in front of part of his collection. That's a photograph I took in 2001, which was the only time I was able to visit Pakistan. He has never been able to see bones from here, and I don't think any of you have seen bones from there. But it would be a wonderful thing to connect those two either actually or virtually. I think it's important to understanding these questions. Next slide. I think we also need scientific access to sites. This is a picture that I took that's my brother's finger. He's also a paleontologist. We work together. This is in Raioli. This is one of the best sites that we have. This is one that the GSI that I showed you in the video at the very beginning when I showed you the egg site. There are literally bones that we don't have in museums on the ground, unavailable because they're protected. So some of the best sites that we have, we cannot excavate, we cannot work at because they're protected. And so I think that is an issue that we need to surmount in the future, that we should have at least scientific access to those sites, because those bones will disappear either by natural processes of erosion or by people who come in and take them. Because really, it's only law-abiding scientists who are following these restrictions. Vandals will still come in, and they have. As soon as we published on Sanaja in 2010, vandals came into the site and began to remove fossils. And so these should be sites that are available to paleontologists. Next. This is an image from a paper that came out by Joshi and colleagues recently about biological and paleontological collections. As all of you, I think, know, due to the history of colonialism, the data, fossil data resources from this place has been taken to other places. And so for me to study Indian dinosaurs, strangely, I have to go to New York. I have to go to London. But I also have to go to many different places in India. And those places are, in a way, disconnected. There's not really a central repository, a digital repository that links what's at GSI Central Region, what's at RTM Nagpur University, what's at BHU, what's at GSI Western Region. There's not a digital repository that links all of those. And so a person who hopes to study questions related to the biota of the Indian plate during the Mesozoic and early Cenozoic faces a big challenge. And so one of the things I think to think about in the future is to centralize, at least digitally, repositories so we scientists can access those data. Next slide. With that, I'd just like to say thank you. This is my colleague Dhananjay, who will be chairing a session later. It's been an absolute pleasure to work with him over the last 20 or so years, and I'm looking forward to many collaborations to come. I would be happy to take any questions that you might have. Thank you.
Thank you, sir. We'll be able to take only one or two questions due to time constraint.
For a very excellent presentation. And I want to add something that actually from Central Region Paleontology Division, Geological Survey of India, had a team, they have worked in the Salvador Gorpend area, which comes under, means it is between the two states boundary, Madhya Pradesh and Maharashtra. And some have work from also been carried out by the Amravati University. So in FS 2015-16, I myself and my team, Arun Bhadran and Prabhakar Lakra, we three have worked in that area, and we have reported more than 40 hatched eggs of dinosaur and one sauropod tooth. Recently, we had a paper on that scientific journal, and we have also identified one sauropod egg, that is Megalithus cylindricus, from that area. Sir, my question is that that area is very we can develop as a geotourism site, and you can have a collaboration between GSI also. And actually, what is the? I have seen that we had a very nice collections there from a few small size to large size eggs, that 5.8 mm to and mostly more than 18 or 22. So what is the cause of that reduction in the size? That is my question.
Thank you. Yeah, those are wonderful sites, and those are the ones that we visited together, which was wonderful. Thank you for that. Um, the question was about eggs and egg size. You're saying in the same clutch as a just change in size? So an interesting phenomenon in living animals like turtles is that so the eggs are produced from ovaries and they go through a shell gland and they come out the mother. And in modern turtles, this may be a mechanism for defense, in fact. They lay the eggs that have the embryos inside in the bottom, and then the last bits of their shell gland are used to produce what you might think of as blanks. That is, these are eggs that have shells and they have albumin, the white part, but they have nothing else. And they are smaller and they're often different in shape than the others. And so people have thought of this as a physiological response, an egg producing response, but also a defense, that it protects the eggs on top and provides more of a space and airspace for the ones below. And there have been eggs found like this in South America in the fossil record that suggest a similar, or I've suggest a similar physiological.
So it was due to weathering or some transportation. What was the cause?
Sorry, can you ask that again?
That smaller size reported was due to weathering. It formed due to transportation.
I think that it could be biological, that there are
Okay.
examples of that
Thank
in
you,
the
sir.
modern.
Just one question. You said that turtles are endemic. You have just one. Now, during the period when this turtle were endemic, there must have been dinosaurs who must have radiated independently from the others. So that evidence is there.
Yeah, so the question is about endemism. And so one of the things I think is an important factor to consider is sampling. And so turtles are among the best sampled of the animals that we have. Dinosaurs, we unfortunately in India, although we have them and we have species that have been named, we don't have on the order of 4 skulls. We don't have any skulls. And so it's much more challenging to understand their biological relationships. And so far we have we have 2 sauropod dinosaurs. They're not closely related. We have 4 or 5 theropod dinosaurs. They're not closely related. Each of them is related to something else. And so we don't know why. People like Ashok Sani have suggested that there are island arcs that were between the leading edge of India as it migrated northward that provided a route for connection with Africa. But that's really sort of a working hypothesis.
That's a
Yeah.
hypothesis. Okay. Thank you.
You're welcome.
I have a question. Right, Gondwana is not very much like very poorly. In fact, it is sample. And right now we are getting in northwestern India, in Jaisalmer Basin, we are getting some dinosaur fossils. So I was just want to talk to you about that because right now we are getting the Tibiosaurian clay, and while searching for fish teeth, we found the theropod tooth and one Spinosaurid type of angol, if you have seen a claw. So what are your views on that, those findings?
These are from the Jurassic.
These are from Middle Jurassic,
Yeah.
Plutonian.
I think that's extremely important. I wasn't able to, because I only have 30 minutes, I wasn't able to talk about really what I started working on here in the early 90s or the mid 90s, which was the Jurassic PG Valley material. I'm excited by what is coming the from the Tar Desert, Tarosaurus, other things. I'm very excited by that, and I hope that more discoveries continue because I think these early fossils from India will tell us about early evolution of those dinosaurs, especially the evolution of pneumaticity, that is the air filling of bones. That's very important. And these animals are telling us about that. And so I'll look forward to seeing more from you and other people on that work.
Okay, thank you, sir. And I would like to talk to you about those things.
Yeah, yeah.
Thank you.
Most welcome. There's one in the back.
Just a couple of queries. Just briefly, I want to ask that in terms of the recent geochronology of these late Cretaceous fauna of Indian basins, uh, do you have noted any biological stress within the dinosaur before KPG or any turnover before KPG? And what is the dominant morphological character of in Indian form with comparison to this South America and African? And any lineage dominant character you have noted for the Indian dinosaur? Because as already you have mentioned that we have very fragmentary type of bone and we didn't find the skull and more diagnostic feature. So it is really difficult to while doing the cladonistic and your issue with another Genoceras one to refer. So kindly give your insight on.
Yeah, so the first part was about biotic change and response to Deccan trap volcanism. That's an important component of what we're looking at. I didn't talk about that, but of course, the geographical changes in India are at the same time as the geological changes, the outpouring of the Deccan traps, the KPG extinction event. To date, in my opinion, and I differ with my colleague Dhananjay Mohabbi on this, I don't see any evidence for biotic change prior to, I don't think we have evidence for that yet. I don't see any evidence of biotic change leading up to the KPG. I think it's probably in part a sampling issue that we don't have enough data, that we have a much, much poorer record compared to Western United States in terms of looking at change in the biota ecosystems through time. In response to the second part of your question, which was about the relationships of Indian dinosaurs to dinosaurs from other parts of Gondwana, in India, we have titanosaur sauropods. These are large sauropods. They're the only sauropods that survived into the latest Cretaceous. And they look like titanosaurs from South America and Madagascar. The theropods that we have here are representatives only of the Abelisauridia. So Abelisaurids and Noasaurids. Again, those are found in Madagascar and South America. So far, we don't have two Indian dinosaurs that are each other's closest relatives.
Okay.
Thank you.
I'd now invite to the stage Sri Vijay V. Mughal, Additional Director General, Geological Survey of India, Western Region, to felicitate our plenary speaker with a token of our appreciation. For that fascinating and enlightening presentation. We extend our heartfelt gratitude to all the distinguished guests for accepting our invitation and honoring us with their presence. This also brings us to the end of our first plenary session. We will now break for high tea. High tea will be served in the convention hall on this floor. The poster session will follow till 11 a.m. The poster session will take place simultaneously at the multipurpose hall in the first floor, and we'll encourage all the delegates and participants to please visit the posters and engage with the presenters. Please note that an exhibition is also being held in the exhibit area in Exhibition Hall 1 and 2 in the basement. You're also requested to visit the respective areas and make the most of this interactive segment. Thank you. Technical session on geodynamic riddles, the depths of the solid earth at 11 a.m. in this auditorium. Simultaneous technical sessions on other themes will also be conducted in Mini Auditorium 1, Mini Auditorium 2, and the conference hall. Hello. Hello. Hello.
नीचे आपका नीचे वाले फ्लोर पे जा रहे हैं कोई नहीं है 10:30 का बोल रहा है तो नहीं गया तो वही है वन सेवन थ्री एट डबल वन ये है वो अपन को मैडम ये टीम वाला हम मैं लगवा देता हूँ मैं निकाल के देखना आज
मैं चलता हूँ और कोई ज़रूरत है सुबह सुबह
ये तो निकालूंगा ना। जा रहा हूँ।
Yes, unless we finish it, we are not able to.
मेरे को पता ही नहीं था।
Iraq we always attend. So, correct. Correct. The century is not used in our West. So precious treasures. Yeah, we have plans for even space heliport survey also. High resolution heliport. Based on the analysis detected through these airborne surveys. So there's a lot of work to be done. Thinking it's a continent with its rich and diverse geological system. Thank you, thank you. Yeah. Sorry. You have heard about the and the product of the TEM company? Yeah. One of the big advances we're using a phone as operating the system, right? That's really a big advantage. And we have multiple systems. We have the XCAM, which is really new. We expect more than 1,000 meters. And this is the electromagnetic methods. We send a current in the transmitter loop. We receive the EDT in the receiver coil, get the data, and then convert it into a model and translate it into geology. Archaeologists. So this is our most advanced system, but you need an ATV to drive around, and I don't think it's so useful. What about this? This one, yeah, this is our newest, so you can walk with it. And there's no, yeah, it's very, very similar to the loop system. But the advantage here is anywhere you can walk.
We need to have systems like that to go to places where we cannot take our vehicle.
Yeah. But of course, the different system, of course, if you put out a larger coil, you're able to look deeper.
I know.
I know, but in this system, it depends on the geology, on the resistivity of the ground, but maybe down to 70, 80 meters with this system. Other systems can go deeper. So you need to know what your target is, or you can combine them.
We have plans to purchase something like this.
Yeah.
Discuss once again with you. Whoever there are, whoever is providing this type of technology, we plan to purchase something. So we'll get back to you.
Thank you very much.
So this is the system just quickly, and this is the extent which is going deeper. What's the application?
Deeper since 1,000 meters?
This one the deeper.
Okay.
And the benefit is like this is the lab. The benefit is here you can able to see everything real time information. So that known the cities that are what you are going to see and you are to whether you are coming again to the distribution. Like so, whatever the by one issue by and yes, everything here.
And n numbers of people can connect this app to use this.
Can I just mention, this is number of
इसलिए मैं ट्राइपॉड के बिना कम काम करता हूँ.
The immersion already in the field and make a decision. Should I continue here? Should I go somewhere else?
So let's say people are walking in the field and geophysicist is monitoring the instrument using mobile, and a person sitting at headquarters will also be able to get connected at real time.
I know we can in the other systems. I think we will be able to do this also.
Okay, thank you.
Thank you.
Thank you.
Did we have a picture?
सर अच्छा ना जाओ.
Thank you, sir.
Thank you. चलो.
हाँ सर अब आए थे. भैया सर आपने भैया सर आपने एक्सपीरियंस नहीं है सर.
लाओ VR लिखा. हाँ सर उधर जाना पड़ेगा. अच्छा अच्छा.
हाँ क्लियर दिख रहा है. बीच में डिवीजन है.
नहीं जिंक तो हमारा ही है सर हिंदुस्तान जिंक इज ओनली
आप ही की तल्ले है वो जो भी है 100% कार्बन फ्री
Yes. I had an excellent experience at this Hindustan Zinc Limited stall, and I was greatly impressed by seeing enjoying the beer, where it was the whole process from mining to smelting and product generation, god generation is exemplified through the VR technology, and I hope Hindustan Zinc Limited will take its journey forward by venturing into the new age critical mineral scenario and indulge in developing the processing of critical mineral in India, because Hindustan Zinc, part of the Vedanta group, has the capacity, experience, and expertise to tackle this problem.
Thank you so much.
Thank you. चलो भाई.
लाइट लाइट के लिए पूछ रहा था.
वो बहुत हिट किया
किधर जा रहे हो?
And join the chair on stage. I also request Shri Said Ejaz Ahmed, Director, Geological Survey of India, Western Region, the rapporteur for this session, to kindly take his seat on the stage and join us for this session. The first keynote lecture will be delivered by our co-chair, Professor Mohammad Irfan Ali Mondal from Aligarh Muslim University. Professor Mondal is a professor of geology at the Aligarh Muslim University with over 3 decades of teaching and research experience. His primary research interests include igneous petrology, geochemistry, tectonics, and engineering geology. He has published more than 100 research papers and edited volume with Springer Nature. Professor Mondal is a recipient of the National Geoscience Award 2017 and the Outstanding Researcher Award 2018. He has served on several national and international geological committees, including the Science Program Committee of the 36th International Geological Congress, IGC 2020, and is presently the General Secretary of the Indian Association of Sedimentologists. He will speak on the interesting topic of unearthing the Precambrian crustal evolution of the Aravalli Craton, Northwest India. I welcome you, sir, to kindly now come forward and deliver your talk.
Good morning to all of you. I will be talking about unearthing the Precambrian crustal evolution of the Aravalli Craton, northwest India, from a geochemical, whole rock geochemical, isotopic, and zircon geochronological approach. This is the nucleus of my university, from which the university grew. My co-workers are Ausaf, Saj, Iftikhar, Wamik, and Ismail. So, unearthing the Precambrian crustal evolution of the Earth, for this we will talk mostly about the banded gneiss complex. I will use this word, banded gneiss complex, as a formal non-ranked lithogamic unit. With this term, BGC nearly satisfies the recent international stratigraphic code compared to many other terms which are in use. So I will only using this term banded gneissic complex. Uh, we know that the banded gneissic complex can be very conveniently grouped into two domains. One domain is called banded gneissic complex 1, that is the lower part of this Nathdwara downwards, and the BGC2, that is northern part of the Nathdwara, that is BGC2. And then in the BGC, we have also metasedimentary rocks and also the mafic rocks. We have done geochemical studies of this gneisses and the metasedimentary rocks and the mafic rocks to understand their genesis. Okay, distinctly, the banded gneissic complex 1, that is the southern part of this Nathdwara, this is definitely Archean. Ages are definitely Archean, and the BGC2, northern part of Nathdwara, that is definitely Proterozoic, which is affected by 1.7 billion year geothermal events. Important point is this Proterozoic event is absent in the BGC1 terrain. First, I will take up this gneissic rock of the BGC1. So, these are the gneissic rock of BGC1 domain. And when we did the geochemical work, we have observed that although in the previous literature, all the gneisses are actually termed as TTG, but we have seen that all the gneisses are not TTG. Most of them, about 75%, 76% are typically TTG, sodic gneisses, whereas some 25%, 24%, they are not typical TTG, but they have characteristics of TTG. We term them as transitional TTG. These are actually potassic rocks. And we have also seen that these geochemical characteristics are actually can be defined in terms of the melting at different depths. So their geochemical characteristics are because of the melting at different depths, and also the potassic gneisses, they can be characterized as that these are actually source characteristics. So we are talking about the depth as well as the source characteristics to explain the chemistry of these gneisses. Okay, so our geochemical studies, the isotopic studies, all these things indicate that the gneisses of the BGC1 terrain, they are actually derived from an enriched source and melting at variable depths, at shallow depth as well as deeper depth, depth is high, and they have also geochemical signals of subduction setting. So we say that the TTG rocks are formed in a subduction setting with melting of an enriched source at variable depths. Now, what could be this enriched source? In search of this enriched source, what we observed that there are some mafic enclaves within the gneisses. And when we did the detailed geochemical work of these mafic enclaves, we realized that these mafic enclaves are actually enriched in nature, not like a normal oceanic crust mafic rock, but they are actually a mafic rock which are generated by plume type of sources, what we call is as ocean island basalt type signals, which are actually call it as oceanic plateau type of rocks. So we say that these oceanic plateau type enriched mafic rock was the source, and this type of oceanic plateau type of crust was melted at different depths, as a shallow depth as well as in the deeper part of the thing, so that we can explain so it is proposed that these mafic enclaves represent the undigested part of such an oceanic plateau which melted to give rise to these TTG rocks. And the TTG rocks have been generated by partial melting of such oceanic plateau, and the vestige of these oceanic plateaus are actually occurring as enclaves within the gneisses in a subduction zone setting. And we explain the geochemistry of the transitional TTD rocks as heterogeneous, derived from an heterogeneous and enriched source, but at shallower depths, because you can see this part, the potassic gneisses are actually source characteristics, but they are confined mainly in the shallower part. So we say that this transitional TTG gneisses, they are formed from the partial melting of a juvenile TTG kind of crust at shallow depth. So this will explain the geochemical behavior of the TTG rocks as well as the transitional TTG rocks. So what we are actually proposing, that we have a normal oceanic crust which is depleted in nature, they cannot account for the enriched in nature of the TTG's crust. So we are proposing that there was a enriched mafic crust like an oceanic plateau which melted at different depths, shallower depth as well as the deeper part, that can explain the details of the chemistry. So a normal typical depleted mafic rock is not the source, it is actually enriched oceanic crust that is the source, and the vestiges of this enriched oceanic plateau is actually occurring as mafic enclaves. So we are saying that the TTG was formed in a subduction zone setting with melting of a enriched source like oceanic plateau at variable depths. We have also now talk about the metasedimentary rocks which are confined in the banded gneissic complex. We have two types of sedimentary rock. One sedimentary rock is immature in nature, like these ones, and there is another sedimentary rocks, bedding is there, bedding plain is there. In literature, these rocks have been reported as quartzite, but our detailed study, we have seen that actually these quartzites, these reported quartzites in literature is actually the bedded metamorphosed bedded chert. So these are confined in a linear basin there. So from geochemical studies of these clastics rocks, the immature clastics rocks, we say that they are derived mainly from the gneissic rocks and some part from the mafic rocks also. So major portion from the gneisses and also the mafic xenoliths. Interestingly, you see this clastic, immature clastic sediments, they follow the igneous composition line, indicating that the weathering process has been very, very less. So we say that the mild to moderate weathering of the source of the TTG under dry, cold, cold and dry climatic conditions were there and they were deposited. We see that we have also seen that the sediments recycling versus source features, sample plots in recycled field, but this is a deceptive signal because the recycling will increase the chemical index of alteration, but in this case these values are very low. So we say that the signal, that is the recycled field signal, is actually deceptive, and actually they are showing the source characteristics because there is very limited amount of weathering there. Okay, now we talk about the mafic rocks. There are so many types of mafic rocks. As we have said, there are mafic zonolis, there are mafic dikes, but we will be talking about those mafic rocks which are actually intercalated mafic felsic volcano. Now, this is a very peculiar rock association that we have observed. Such types of rock association, mafic as well as felsic, intercalated rocks, these are not very common from Precambrian Archean terrains. So we have clubbed all the mafic rocks geochemically into such different groups like arcthuliite, boninite, high magnesium andesites, and niobium enriched basalts. All these mafic rocks actually exclusively form in a arc setting. So we have obtained their tentative age from the field occurrences to be around 2.7 to 2.6 billion years. And their detailed geochemistry, I am very quickly coming to the interpretation part. So these different types of mafic rocks, they are different. Okay, so and we explain from the geochemical characteristics that these mafic rocks are derived from a enriched or metasomatized mantle in an arc setting, because all these rocks are exclusively formed only in an arc setting. So we are proposing that this banded gneissic complex, which is mainly the gneissic rocks, and in those gneissic rocks there are some enriched mafic vestiges occurring as enclaves, and in this part, in an arc setting, some linear belt was developed where sediments were derived, clastic sediments were derived mainly from this gneissic terrain, but we have also developing the chert is also deposited here. So this can explain the simultaneous occurrence of immature sediments as well as the very, very mature sediments, which in literature it is referred to as quartzite, but we are saying that they are actually metamorphosed chert. And then basaltic rocks mafic rocks were developed in this arc setting, in an evolved arc setting signature. So now we are saying that we explain now the field observations that we have this immature sediments as well as the chert, and which is these mafic rocks were emplaced, mafic lava were emplaced, and we are explaining these alternate bands of mafic and felsics to be belonging to a kind of probably a sheeted dike, which actually represents a spreading ridge type of scenario. So we are saying that these mafic rocks is actually the supra-subduction zone type of setting they are formed, and our findings are that the reported quartzite are actually the chert, and the basaltic rocks were formed in a supra-subduction zone setting. Now we take the next rocks. These are the new Archean granitoids. Their ages are mostly 2.5 billion years. We explain the detailed chemistry in terms of this. There are some rocks which will show, I have not categorized them from geographical locations like Barrage granite, Untala granite, not like this. All these granites have been explained in terms of this chemistry. They are TTG-like chemistry, there are sanukitoid-like chemistry, and there are high potassium sweet-like chemistry. The TTG-like chemistry can be explained by melting of a mafic crust, whereas the sanukitoid, in case of sanukitoid type of signatures, can be explained where we can involve the melting of a mantle wedge, and the high potassium granites can be explained in terms of crustal rock. So all the chemistry can be explained. They represent the same same tectonothermal event, but only the source is being changed from mafic crust to the mantle wedge to the crustal source. So now we are saying that, so now we have developed a BGC crust of 3.3 or maybe 3.5 now, up to 2.5, and in between the Aravalli opened, so that created the two domains of BGC1 and BGC2. Later part, this western part, BGC2 would be remobilized in the Proterozoic, and no effect would be observed in the BGC1 terrain. As a result, what will happen? The BGC2 terrain, that part, will have memories, geochemical memories, both geochronological memories as well as isotopic memories as that of the BGC1. So we now find lot of similarities in terms of model ages. Model age means the time when the BGC1 part and the BGC2 part they were derived. So that would be same. Their isotopic characteristics would be similar, but this BGC2 would be reborn, remobilized, reworked in the Proterozoic time. So we have also worked on this BGC2 part. I will first concentrate on the part near Ajmer, where it is called Annasagar granite gneiss terrate. This vegetation part is actually, the lower part is Annasagar granite gneiss, the top part is supracrustal quartzites. Now here there is a deceptive, again a deceptive signal, like the Annasagar is actually occurring as basement, that is the sediments, but close look will indicate that the granite contains, the granite is actually emplaced like a concordant body. So actually the granite is intrusive into the supracrustal sequence. We have also the xenoliths of the supracrustal metasedimentary rock into the granite gneiss. So this stratigraphy of this part has been equivocally explained in terms of that they may belong to Delhi, they may belong to Aravalli, they may be pre-Aravalli gneisses, and they may be Delhi sequence. So we did some work on this, geochemical work and etc., geochronological work, and we have observed that so one important thing, that this granite are intrusive into the supracrustal sequence from field observations, and that their geochemistry indicates that they are paraluminous in nature, and they are A2 type of signals, A2 type of signals. Now this appears contradictory, paraluminous and A type of signals, but A2 type, which is actually emplaced in a post-collisional type of setting, can be paraluminous, and nowadays so many reports of such kind of occurrence are also being from many parts of the world. So the the age of this Annasagar granite is actually 1.85. So this will indicate that the supracrustal sequence is more than 1.85. So the Annasagar supracrustal sequence becomes now penny-contemporaneous with the Aravalli sequence and not the Delhi sequence, although it is occurring in the Delhi supergroup terrain. And Annasagar granite is actually A2 type. This is an indication of a post-collision extension. Now in this part, conjecturally, we wish to invoke a slab window type of setting where a ridge, mid-oceanic ridge can be subducted, and as a result a slab window can be generated, and this can explain a huge tectonothermal event at around 1.7. This model can explain why everything happens in BGC2 at around, very quickly, around 1.8 and 1.7. The granite emplacement, the granulite, and all those things, they can be explained. So we are saying that as the Aravalli closed, like a accretionary erosion, and because of slab rollback or a slab window type of thing, the asthenosphere was uplifted, asthenosphere upwelling was there, and as a result, this A2 type Annasagar granite at 1.8 was emplaced into the sediments. They were contemporaneous with the Aravalli supergroup. And a large scale, because of this large scale asthenospheric upwelling at around 1.7 or 1.8, BGC2 has been remobilized, and many thermal events are observed in terms of granulites, mafic granulites, OPX bearing granite, etc., all those things. And this part of BGC will remain unaffected from those Proterozoic things. So as we are saying that we have to at this stage invoke a slab window type of setting so that we can explain these huge tectonothermal events at BGC2 at 1.7 billion years. We have also worked on this gneissic rock of the BGC2 terrain, where also, as I said, we have also signals of TTG, of BGC1, and also the potassic gneisses like that. So important point that I am trying to say is that these potassic gneisses are actually the reworking product of the sodic TTG crust. So, we say that there is a strong similarity of BGC1 and the TTG, some TTG type of rocks from the BGC2, whereas there are some other gneissic also. This thing can be explained in terms of isotopes and all those things. So implications is that BGC2 sodium rich TTG gneisses are actually the remnant of the TTG of BGC1. They are left over after reworking of the TTG crust during 1.7, and the potassic gneisses are the reworked product. We have also taken the work of the mafic rocks, amphibolites, and we have categorized the amphibolites from field setting and geochemical characteristics, that some amphibolites are occurring as dikes. So we call them these dikes as pre-rift phase. There are some mafic rocks which will represent the opening of a small basin called Mangalwar Basin, and there are some gneissic rocks which are intercalated with the metasediments. We call them that they represent a syn sedimentary volcanic phases. So we say that the Mangalwar sedimentary basin, which is now occurring as metamorphosed paragneiss and the metasedimentary schist, they were actually formed in a continental rift setting. And when the BGC, Mangalwar basin was opened and metasediments were deposited, and also the mafic rocks are also emplaced. So as we are saying that a small basin was developed there in the BGC2 crust. There are some mafic rocks which are occurring as dikes, some mafic rocks occurring as isolated body representing the oceanic crust, and there are some mafic bodies which are intercalated with the sediments. We call them as syn sedimentary volcanic rocks also there. So these are some of the works that we have done over the last couple of years, maybe 10 years. So I say, I understand that we have miles to go before actually we can say that we know our terrain, cratonic rocks. So I acknowledge my sponsors, SCRB, NRF, Ministry of Mines, NCPR, NCS, and NGRI. So thank you very much. These are my co-workers with whom I have worked, Ausaf and Saad. They are involved in the Newarkian granites. Iftikhar mainly working on the BGC1 terrain, Ismail working on BGC2, and Wamik is working on the Annasagar terrain. So thank you Thank you very much.
Thank you, sir, for your talk. We'll be able to take only 1 or 2 questions as we are running behind time.
Yes, yes, please. Yes, yes, I know.
Created all these granites. In fact, I was part of this
Okay.
program by all this Unthala, Gingla by lead isochrome with Alfred Kroner. Is it just I want to ask whether that granites are part of your BGC1 or BGC2?
BGC1, definitely.
Okay. Because all the ages they have given us 2.5.
Yes, around
Nearby
2.5.
2.5.
Around 2.5.
Archean Proterozoic complex.
Yes.
So this is
BGC1.
Okay.
So we don't have such rocks in the BGC2.
Okay.
Thank you, sir.
Okay, thank you.
We will now proceed with the oral presentations of this session. I'd just like to ask our presenters to kindly adhere to the allotted time limits for your presentation, as it will help us maintain the time. There is 10 minutes for your presentation and 5 minutes as discussion time. I'd now like to invite our session chair to take charge of the technical session. I formally hand it over to you, sir.
Thank you. In this session, we have around 8 papers. We'll begin with a critical appraisal of the fault wall model vis-a-vis metamorphogenic origin of lode-type gold deposit through numerical modeling by Sharnendu Bhuyan. I think the presenter is not there.
Sir, in that case, we'll move on to the next one.
The next is crustal evolution of Meghalaya Nisi complex, constraints from detrital zircon geochronology and oxygen isotope analysis by Shushoban.
पहले वाला Good morning, everyone. Good morning, the chair and co-chair of this session. I'm going to present some interesting fact about the detrital zircon and its significance in understanding the crustal evolution. So, detrital zircon geochronology is very old methodology to identify the maximum depositional age as well as the crustal recycling processes. But when I'm saying it's interesting, it comes with certain cost. And the cost here is the knowledge of your detrital zircon geochronology and advancement of the instrument. Here, advancement of the instrument, because GSI has purchased a new advanced secondary and mass spectrometer, and it is designed such a way for its increasing high spatial resolution. The high spatial resolution of this instrument allowed us to unfold many more hidden histories that was not previously able to understand with the classical geochronological and isotopic methodology analysis. So proceeding to that, so I have chosen an area from the northeast India, which is the Meghalaya Plateau. So why Meghalaya Plateau over here? Because it was earlier thought as an exotic crustal block in the northeast India, which preserves the Proterozoic crustal evolutionary history that is detached from the rest of the India. But thanks to the deep drilling of the ONGC over the Bengal basin, they found the continuity of the CITZ with the Shillong Plateau. So it was later believed by the later workers that the Shillong Plateau is the continuation of the Proterozoic mobile belt of the central India in further east.
And why this Proterozoic mobile belt is interesting? Because it was the classical crustal amalgamation zone, and recycling process happened over the two supercontinent assembly, that is the Columbia supercontinent assembly and the Rodinia supercontinent assembly. So these rocks are much more interesting in terms of the crustal recycling processes. What we saw today in the Himalaya, it's the classical example what happened in the ancient past in the Proterozoic time. So if we zoom that part of the Shillong, what we found that there are distribution of different Proterozoic rocks over there. It is defined by the high-grade granulites, which defines the basements, and these are of Proterozoic ages, mostly from 1.8 billion years to 1,000 million years. Then one rift basin at the eastern part of the Meghalaya Plateau, that is Shillong Basin, and these are intruded by abundant 500 million years anorogenic granite or the interplate granite. So this is the simplest Proterozoic geological map which I could have produced, and these rocks have been recycled by the horizontal plate tectonics at different time scale by clockwise and anti-clockwise metamorphic path, which defines the how these rocks has been responded by the horizontal tectonics. And if we zoom the Sonapahad area, which is the present study area, the rocks here are defined by massive metapelite rock, which is represented by the cordierite gneiss, and sillimanite schist, which are intruded by the late 2-pyroxene granulite, charnocite, and the late Proterozoic, Neoproterozoic granite. So how these rocks looks in the field, the metapelites particularly, where I am interested about the detrital zircon, to know what is the age of maximum deposition and what was the crustal recycling processes going on. I mean, what was the source rock of these sediments back in that time, because Meghalaya, you know, the northern part is covered up by the Brahmaputra Valley and the southern part is by Bangladesh Plateau. So it's hard to know what was the source rock of these metapelites in the Archean or the New Archean time. So these rocks are basically migmatized pelites represented by the garnet cordierite gneiss, and these rocks are melted by the partial melting during the late metamorphic processes. And when you see the rocks under microscope, these rocks are represented by a garnet cordierite assemblage at peak metamorphic conditions, and these rocks were retrograded to garnet cordierite to the again a second cordierite. Because why I'm saying this rock when I'm describing the detrital zircon geology, because detrital zircons are also impacted by the late metamorphic events, which we should aware while dealing with these zircons, what happened with this zircon when we move forward or when we subject the rock or the zircon to a higher metamorphic grade. So thanks to the previous work, one of the work by Nyogi et al. 2023, they have identified the rocks reach at 825 degrees centigrade temperature and 5.7 kilobar pressure when it was on the peak metamorphic condition, and there was anhydrous melting of the rock under granulite facies condition. So this was the maximum pressure temperature recorded in this rock. And the most important factor when these rocks were metamorphosed, because when I'm dealing with the detrital zircon, the time of late hydrothermal or metamorphic impact are very much essential. And this is again from our previous studies, which says these rocks from the Sonapahad area were extensively metamorphosed around 1035 million years and then retrograded again around 976 million years. So decided to collect the detrital zircon from this pelite to see further what happens inside there. So these are the images, cathodoluminescence images of the detrital zircon, and you can see the very rounded, corroded margins of the zircons, which is of no doubt that this zircon has suffered certain kinds of transport before its deposition. And the cathodoluminescence image shows that there are multiple growth event of these zircons. So these zircons are not representing one single cycle of igneous activity, rather these were subjected to different cycles of crystallization as well as late metamorphic impact. So when we date those rock, we found that most of the dominant crystallization age at the core of this zircon is around 1630 million years to 1665 million years. But the interesting fact, when we did oxygen isotope analysis of this rock on the same spot where we found the concordant ages of this zircon, these oxygen isotope values are tremendously low than the mantle value. This is around 1.6 per mil to 4.2 per mils. So it has immense significance. Why the oxygen isotope? Usually the oxygen isotope of the mantle value has 5.3, and if a felsic magma crystallizing by the fractional crystallization process from a mafic magma, the oxygen isotope ratio of this felsic magma get enriched in a positive way by settling the lower values in the first fractionation phases. So usually the granite and granitic melt, the Day-2 value of a granite comes around 7 to 9 per mil, but this is unusually low. So we have to think why this is unusually low and what is the significance of this oxygen isotope value. And the detrital zircon, as you know, we are blessed because the nature do the unbiased sampling for the detrital zircon, where there is no human interference. So whatever the detrital zircon we are getting over here is possibly the most unbiased representation of its source rock and what happened in the source rock. So moving forward, the ages when the Concordia plot shows there are multiple clusters over the Concordia, and if we resolve those with the PDP and KDE plots, there are multiple peaks of the Concordia around 1866 million years, 1709 million years, and the major peak is around 1648 million years, and there are some subsequent peaks. But when we saw the thorium by uranium ratio of these zircons with the ages, we found that the latter ages of 1572 million years to 1455 million years, these ages are having very low thorium by uranium ratio. So possibly these ages are representing the late metamorphic impact or the hydrothermal impact, while the dominant 1648 million years zircon, the thorium by uranium ratio is typically of the magmatic thorium by uranium ratio. So from this, we can interpret the maximum depositional age of the sediments over here is the dominantly 1648 million years, with the two minor peaks at 1800 million years and 1700 million years. So when we plot all the Day-2 value of these detrital zircons, at the peak clusters at a very low value between -1 to +5, and the maximum mode is around +3 to +4, which is very unusual for a zircon crystallizing from a magmatic rock. So when I compiled the entire data set available for the from the Shillong Plateau, what I found that the crystallization age of the Shillong Plateau is represented by, in the right side curve, it's around 1600 million years, and then a small peak around 1400 million years, then a peak around 1000 million years, and a big peak around 500 million years. So these are the okay.
You have to conclude.
Okay, so this represents there was a dominant volcanism or a felsic magmatism around 1600 million years, which the detrital zircons are recording. Now the detrital zircons are also recording the low Day-2 value. That means how these low Day-2 rocks are formed in the nature. There are multiple processes how this, sir, just 2 minutes. There are multiple processes how the low Day-2 rocks are formed. And the classical example today, if you go to the Yellowstone Park, where the source rock is hydrothermally altered at high temperature, then the oxygen isotope gets replaced of the source rock, which is of low Day-2, and again remelting of this low Day-2 source rock arises to the low Day-2 felsic magmatism. So there another paper came 2-3 days back by Nyogi et al. 2025 in Lithos, which they have calculated once again the melting age of these metapelites, which says around 1628 million years. And there is a hardly 20 million years gap between the age of this zircon, detrital zircon peak, and the age of the new remelting age. And again, that remelting ages, the detrital zircons, the oxygen isotope matches exactly the low value. So the idea is that how these rocks were evolved. because the 1600 million years rock, if you see the geochemistry of this rock, these are typically high silica granite with a tholate, a calc-alkaline trend and following a mid-crustal remelting. So the Shillong Plateau or the Meghalaya mobile belt was undergoing a subduction accretion process by that time between the 1.8 to 1.6 billion years, which is the time of Columbia amalgamation. So this subducting slab were hydrothermally altering the mantle and by metasomatism, and it was making the source rock with a low Del value, and the felsic magmatism coming out from the arc were basically of the low Del arc magmatism. And if you see the 1.4 billion years rock, these rocks are of anorogenic granite. So there was possibly slab rollback was going on, and one previous arc was getting subducted again and remelted to form the low magmatism over here. So it explains how the crustal recycling processes can be unfold with the advancement of the instrumentation and understanding about the zircon geochronology. Thank you.
Thank you, Shushovan.
Thank you, sir.
We are far behind schedule, so I think one or two quick questions we can take.
Hello. This is a known fact that crustal thickness in the Meghalaya region is like average more than the crustal thickness in the other part of the India. So do you see any relation between your study and crustal thickness in the Meghalaya region?
Sorry, sir, one second.
The crustal thickness of the Meghalaya plateau is more than the crustal thickness of rest of the India. That is a known fact proved by the other geophysical studies. So do you see any relationship between your study and the crystal thickness?
Yes, that is a very good question, sir, and I'd love to answer it, because whatever you are saying, the crustal thickness of the Meghalaya plateau is thicker than rest of the India, because Meghalaya was a part of fold thrust belt. So there was a double and triple thickening in some places. If you see the map of the regional map and unfold it, so this crustal over thickening caused the remelting of the lower crust many times, and the resultant is these granites. Okay.
Thank you. Thank you,
Thank you, sir.
We'll go to the next presentation. Unraveling the growth of continental crust across the Precambrian North Delhi Fold Belt, Rajasthan, a UPB shrimp geochronological study by Trishrota Chaudhary and others. Please adhere to your time schedule.
Hello. Yeah. Good afternoon, my respected colleagues. So, Geological Survey of India carried out a nearly 10-year long MOU with Geoscience Australia, and it had several components, starting from 2015 to 2025, and to uncover or to understand the hidden mineral deposits, because with time on the surface the available mineral deposits are getting used up or exhausted by the society. So Government of India realized or is taking newer strategies to understand and trying to exchange newer technologies to unravel how the hidden mineral deposits can be extracted and rather identified and extracted. And Australia has given a significant contribution in the world among this. So the MOU had different components throughout their activity, and one of the activities was geochronological dating in their shrimp. So today, and GSI took a big, long project of calling them Project Uncover, which has two components. One was carried out in the northern part of India, and another is southern part of India, and they have been called as traditionally the Northern Transact and the Southern Transact. So today in this presentation, I'll be presenting the geochronological data generated during the Northern Transact. Thank you. So in the Northern Transact, it's almost 620-kilometer long transact, which started from the northwestern part of the North Delhi Fold Belt, continued through three crustal entities, which is the North Delhi Fold Belt, Vindhyan Supergroup, and Bundelkhand Craton. And the idea was to get a detailed study starting from basic geological mapping, geophysical mapping, finding gravity anomalies, detailed surveys, collecting hard rock samples, soil samples, rigorous sampling, hydrogeochemical sampling, and at the last part, subsurface drilling, exploratory drilling, and stratigraphic drilling as well. And with that, GSI and GA decided to select some very particular samples, special samples for detailed geochronological study. Now, dating of a rock is not just dating of finding the crystallization age of the rock. It also helps us to understand what was its original source from the geomorphology or the morphologies of the zircons, and any other event, maybe magmatic, metasomatic, thermal event that has influenced these zircons. So we selected, or GSI rather selected 5 critical samples to unravel the history of the North Delhi Fold Belt. Among them, the first 2 samples, the Bairat granite and the Jaipur granite, they have given consistent ages of nearly 1700-ish age, which is also consistent with the field observations and the nearby geochronological data that they are A-type granite related with the initiation of the Delhi orogeny. And this data helped us to re-evaluate the structural and the stratigraphic relation between the sediments and the intrusive granites among these areas. More importantly, we also selected and analyzed the albitite near Babai area, which is a classical outcrop area of the Khetri albitite. And as albitite is a metasomatite, it must be having a host rock. So in field, we observed that the host rock is a biotite granite, which is myelonitized. And when we started getting the shrimp pages, we found 3 clusters of data. The first, most consistent data is also 1700, which probably gives the protolith age of this albitite. More importantly, we found a consistent uranium-rich rim, very thin rim, around every zircon grain, almost every zircon grain, which was even cross-cutting the earlier compositional oscillatory zones. And we understood that these rims mean something, and it's a later event that followed the original crystallization events. And thanks to SIMS, the beauty of SIMS, shrimp, or SIMS for that matter, both of them have very fine spot, almost 10 micron spot. So they can very effectively and precisely analyze the ages of such thin rims, which is impossible with other geochronological instruments like laser ablations or even TIMS. When we do TIMS, in the air ablation, these kind of rims will be eroded. So we won't be getting this kind of overlapping or later events. So thanks to shrimp, we could find a 1300 million year concordant age, which we interpreted as the age of albitization. And it has not been reported earlier from Jharkhand's geochronology, but it has been reported from uraninite geochronology or monazite geochronology as a metamorphic event. So we could correlate and interpret that possibly this albitization event first associated with uranium mineralization first started during 1300, which is much older than the previously recorded ages of 970 or 850 million years. And the next data, which is a drill core data, the northwestern part of the Transact line, which is a drill core data from Churu area, which is hidden under the Aeolian sand. And the uncovered team, when they mapped, they found consistent geophysical and geochemical anomalies, and they mapped a north-east-southwest trending fault and another east-west trending fault, which is named as the Churu fault. And because of this anomaly and copper values in the hydrogeochemical data, they planned 5 boreholes, and within all of these boreholes, they cut beyond 80 meters, they cut the granodioritic host, and in other boreholes, they found the metasediments, and in the granodioritic host, they found 6 prominent bands of sulfides. But even if we call sulfides, the amount of copper sulfide is very less, and the pyrites or the gang sulfides, they are more dominant. Now, why is that? So, more importantly, we found the age of 891 million years, and when we observed the CL images, we found consistently rounded xenocrystic core among them, and from the morphology and from the diverse ages, it is understood that maybe a reworked sediment has been a part of their source. So that's why we are getting a rounded xenocrystic cores and a diverse age. It would have been a single source, then we would have been gotten a consistent xenocrystic age, but we are getting Archean to nearly Proterozoic age ranges of the inherited ages. So possibly the Churu granite was maybe a sediment, had a sedimentary origin, and it's also very clear from their geochemical data because they have very high RE-rich composition. They are paraluminous in nature. So, if we correlate them with the regional geology, Mukhopadhyay and Bhattacharya, they earlier have, although the exposure, the extent of exposure in the Churu area is very less, but they have reported dismembered parts of ophiolite, which they have correlated with the fuller ophiolite, and now whatever age we are getting from the Churu granite, it's nearly consistent with the Fulad event. So it is possible that the late accretionary event, which is the Pan-African collision or latest accretionary event, we are getting imprints of that in the northern part, which was undercovered so far, but thanks to our project Uncover, we are getting remnants of it, or we are getting more evidences of it. But why we are not getting much sulfides as we expected from the Churu granite? It is possible that when oxidized magma, which has a high potential of having sulfides because copper sulfides or metal sulfides, it can precipitate sulfide within the magma if the oxidizing redox condition is low. I mean, it's a reducing condition. If it is very oxidized, it has a capacity of keeping the sulfides or the metals within it. And when it undergoes second boiling, when the hydrothermal fluid is separated from it, it can scavenge the metal. It has the capacity of it. But here, I need 3 minutes, sir. Here, we are getting disseminated sulfides within the Churu granite and the sulfide-rich hydrothermal veins within the vein itself. So it is possible that in the competition between the sulfide saturation and the separation of hydrothermal fluid, which was initially capable of separating the metals, and the hydrothermal fluid might have lost, and some sulfide already precipitated within the host rock. And another factor is amphibole crystallization. Amphibole has structural water in it. So when the composition of the Churu granite is a granodiorite diorite suit. So the granodiorite diorite component is very significant, which has significant amount of amphibole in it. It scavenges significant amount of water, which takes the total water budget from the magma system, and the remaining hydrothermal fluid is depleted and is less capable of carrying the metal. And at last, we dated another sample from the DOSA. This is also a drill hole sample, which was no exposure and hidden under the alluvium cover. We obtained age of 2527 million years, which is the age of basement of the Mangalwar complex. And the uncovered team detected two faults. One is north-south trending faults, which is called as a reactivation of D2 foliation, and another fault which is a splay fault where we are getting this offset. So they say that these two faults are contemporaneous, and they were identified by the geophysical features and the omission of the lithologies. And they targeted the north-south faults and obtained good amount of sulfide, granodiorite associated with good amount of sulfide with good values of copper and gold. Now, we would love to see what is happening at the intersection zone of these two sulfides, because these two faults, once there are two faults which are having opposite sense of movements, there should be an extensional or dilational zone in between. So we'd love to see the geochemical or rather the geophysical maps, because this area is under the alluvium cover. What is happening in between this extension, the interaction zone between these two faults? Are they metal rich? Because these areas are the high potential zones for hydrothermal mineralization, as they are creating open spaces within the brittle earth. So that's it, and we plan to take this work further with our GSI SIMs, because we have now the tool to identify the crustal sources from the in situ oxygen isotope of the zircons of different age domains, starting from the xenocrystic cores to the albitite rims, the 1300 ages. So from the 1300 million year age, we can find from the oxygen isotope values, we can find that what kind of redox condition the uranium mineralizing fluid had, what are the characters of the xenocrystic cores of the Churu granite. So we can continue this work with Geoscience Australia, and that would be the best thing for us to further together explore the unknown area. Thank you so much.
Thank you, Trishrota. Your traverse was for 620 kilometers.
Not my traverse, for others.
So do you have any plan of extending the work in Bundelkhand area? Because it's confined to only Rajasthan.
It's not my call, sir, really.
Okay, we can take one or two quick questions. Yes, please.
Excuse me. You have shown Berat granite as Paleoproterozoic age.
Which granite, sir?
Berat granite. No. Virat granite. Berat.
No.
First, you were showing the Berat granite.
Berat, yeah. So it's not working. Yes, I remember.
Paleoproterozoic age you are showing.
Yes.
But it is, I have worked in one of the prospects within Berat granite that is called Kala Joda copper prospect within Berat.
Okay.
Quartzites, it is intrusive in quartzites.
Yes.
If the quartzites are middle proterozoic, how it can be, granite can be paleoproterozoic?
So is there any evidence that the quartzites are middle proterozoic?
Huh?
Are there any evidences that the quartzites...
Yes, we have done mapping, seen that it is intrusive in quartzite.
Yeah.
So
I
it cannot be.
agree.
If quartzites are of Delhi, middle proterozoic, how it can be the granite can be paleoproterozoic?
So
my question is, my suggestion is that when you interpret a date,
yes,
be careful of the field relationship.
Sir, to answer, it's a very good question. Thank you for that, sir. It's unfortunate that the ages of Berat granite was repeated here. Actually, it has been dated earlier too by Parampreet Kaur. They have also obtained the same age, nearly 1700 age, and they have shown the enclaves of the quartzites within the granite.
No,
so,
it's reverse. When you thoroughly map the area, We have done extensive mapping in Kala Jota project. It's reverse. Quartzite is forming the base.
Yes.
Granites are intrusive in that.
Yeah, yeah, of course. That's
So
why we are finding
if
the
the
enclaves of
quartzites are of
quartzite.
Delhi's, Delhi age is not Paleoproterozoic.
Yeah, okay.
It's middle Proterozoic.
Yeah, maybe I'm wrong. Yeah, thank you, sir.
Okay.
We'll look into that.
Okay, thank you, Krishnan.
Thank you.
We'll go to the next presentation, Metamorphic History of Sulfide-Hosted Pelites from Pseudo-Section Modeling, Betul Belt, Madhya Pradesh, by Shampa Khan.
A very good afternoon to all. Today my topic of discussion is metamorphic history of sulfide-hosted pelites from pseudo-section modeling, Betul Belt, Madhya Pradesh. My co-authors are Parviz Akhtar and Ishar Bajwani. This is the location map. The red inside is the location of the Betul Belt, which is present within the CITZ, it's Central Indian Tectonic Zone, and which is the suture zone for the North Craton and the Southern Craton. And Betul Belt is located well within it. So this is the geological map of Betul Belt. Betul Belt is a long linear 135-kilometer long belt, and its width is 15 kilometer. This is the host for the lead zinc copper deposits here. So this Betul Belt act as the inlier where it is surrounded by in the north and western portion in the Gondwana sediments, and in the southern part and the eastern part it is dominated by the Deccan Trap. Now the Betul Belt is having various lithology. It is having volcano-sedimentary sequence, and also the later intrusives, some mafic ultramafics, as well as later granite intrusions. So this Betul Belt is very interesting, and it is having the different prospects that these black boxes are marked here, which are demarcating the lead zinc copper sulfide deposits within it. And this, the host rock for these deposits are mainly its quartz mica schist. Now these are some field photographs and micro photographs of different litho units. On the first figure, it shows the quartz mica schist in the field photograph, where in the bimodal volcanics, the rhyolites are also there, which are sometimes amphibole bearing meta-rhyolites, and meta-basalts are there. And these are the micro photographs where this meta-rhyolite is containing actinolite and quartz feldspar, and whereas in meta-basalt, plagioclase, amphibole, chlorite epidotes are there. Now coming to the other photographs, amphibolated another rock type here. So amphibole plage epidote is the major constituent minerals here. And now coming to the host rock of the sulfide mineralization, that is the quartz mica schist. This rock is very heterogeneous in nature, and it is having the Ginsian spinel, that is gahinite. It is the indicator of zinc deposit. So it contains gahinite, staurolite, and quartz feldspar, biotite, chlorite. So these are the field photographs where you can see that presence of garnet and presence of staurolite. These are on the upper surface of the rock type. It can be easily visible, the presence of staurolite, and dark green to bluish color gahinite. So the micro photographs corresponding to this, it can be easily understand that the staurolite and gahinite, the occurrence of these minerals are having the skeletal in nature. They are containing huge lots of quartz inclusion within it. Now this is the deformation of the area. So in the rhyolite, the flow banding is identified, which is S0, and S1 is the dominant foliation plane here in the quartz mica schist, which is east-northeast to west-southwest direction, and the small F2 folds are demarcating the D2 deformation. Now coming to the deformation and metamorphism. So the first picture, it is showing the presence of garnet, where the SI-AC relation, it can be seen that the SI is demarcated by the quartz, forming by the quartz, and the AC is demarcated by chlorite, biotite, as well as quartz. So since the foliation is truncating and it is for showing the pre-tectonic to syntectonic in origin, the garnets are. The corresponding figures also showing that the garnets are, the outside foliation is swerving around the garnet. So both the garnets are syn to pre-tectonic in origin, and the gahenites are present here, which are, as I mentioned earlier, that if these are quartz inclusion rich, and sometimes in the photomicrograph of E, we can see that the staurolites and gahenites are having different, that these gahenites are having different occurrence compared to the image of C. So probably these are the indication that we are having two types of gahenite formation here. And chlorides are also having two generations, which are one is cross-cutting and another one presence of sillimanite in the along with staurolite quartz. So the main the thing is here, the in Baitul Bel, the host rock is compositionally very much different, and it is having the different mineralogy as well. So in the garnet, in my mineral chemistry study, I have found that the huge variation of garnet in different area, that Baskapa, Koparpani, Delwara, different blocks are there in Baitul Bel. So I have compared the garnet of the three area. In the Koparpani area, it is marked in the blue color, which is rich in almandine component, whereas in the Bhuari, the red color, where it is mostly almandine and spessartine, both the components are here. And in the Delwara block, the garnet is having mostly spessartine in composition. The X-ray mapping is also showing the garnet core is Fe4, whereas the rim is Fe rich, and Mn is also there in the core. So not only garnet, in case of gahenite and in case of staurolite also, I am having huge difference in the huge mineralogical composition. Rather, the ZNO percentage varies from 27 to 38. In case of staurolite, the ZNO percentage varies from 3.80 to 10.89. So the compositional variation is well found within this. Now, if I try to understand the paragenesis of the minerals of this area, so this metamorphism, from the metamorphic reaction, we can say that in the first image, in image A, the sphalerite we are getting as inclusion within gahenite, as well as sphalerite we are getting as inclusion within garnet. So sphalerite, since it's a zinc sulfide, so the sulfides were having prior to metamorphism, since it is present as inclusion within it. So these sphalerites, desulfurification of these sphalerites is the main reason, and it's acted as the reactant, where chloride biotite also was there, and forming garnet, gahenite, biotite, and sulfur phases. Whereas in the image C and D, where we can found that the presence of garnet and gahenite, these are growing together with the staurolite, and sometimes it is showing that the engulf phases within staurolite, that gahenite and garnet. After studying of 3-4 slides, it can be seen that the gahenites are well within the staurolite and garnet as well. So that garnet and gahenite both are reacting and forming that staurolite and quartz. So this is the peak metamorphic assemblage here, that garnet, gahenite, biotite, staurolite, quartz, feldspar. And now coming to the other images, this is the BSc images, where now, still now we have seen that the gahenites are skeletal in nature, but here these gahenites are forming in the fracture, along the fracture of the staurolite, and the in close association, muscovite and chlorides are also there. So this can be another reaction we can suggest from here, that staurolite breakdown reaction, that is garnet, staurolite and biotite 2 is reacting, and it is giving rise to gahenite 2 and chloride 2 and muscovite and sillimanite. So normal thermobarometric, the conventional thermobarometric study has been also carried out, and it can be found that the garnet biotite thermometry, it gives 568 plus minus 11 degrees centigrade after Dasgupta et al. For prograde metamorphism, whereas the biotite muscovite thermometry, it gives the 493 degrees centigrade after Hoyes for this breakdown event. So since there was absent of this barometry, so barometry cannot be done from here, from this assemblage. So this assemblage has been treated in the phase equilibrium diagram, and to try to find out the exact pressure temperature. So since as I told that the compositional variation as well as the mineralogical variation prevails within the block to block, so I have taken out another prospect where the main mineralogical assemblage was garnet, biotite, staurolite, chlorite, K-feldspar, sillimanite, and quartz. And this has been treated in the Powerplex software, and the garnet from XMG and XFE isoplate of the garnet, it cuts and it gives a temperature of 590 degrees centigrade, and the corresponding pressure I got at 3.7 kilobar. So microbulk has been calculated and KF mass system has been used here to get the temperature and pressure. So the main conclusion of this study, it can be said that prior to metamorphism, there was a profuse hydrothermal activity which led to the formation of the base metal mineralization here, and also it creates a heterogeneous bulk for the metamorphism, and compositional variation we are getting just because of that. And textual study also suggests that prograde M1 metamorphism is manifested by the development of this peak metamorphic assemblage, and subsequently the system was subjected to a retrograde event, and it is from the staurolite breakdown reaction. But since the temperature is 590 for the peak, and the staurolite breakdown reaction I got for 493, so probably it is not a separate metamorphic event, only one metamorphic event is here, which is amphibolite phases of metamorphism. And this staurolite breakdown, it may have happened that when the system cools, within the same pressure regime, the staurolite breakdown breaks, and it gives rise to Day-2 and other assemblages. So that's all. Thank you.
Thank you, Shampa. Any question from the audience?
Yes, sir.
And 2007.
Yes,
and
sir.
I worked in all those as an exploration geologist in all those prospects, Koparpani, Delwada, Buyari, et al. And we did a lot of work on the what you call metapellites, and we found that those are actually not metapellites. There are a number of publications.
Yes, sir.
Me and my co-authors, we found out rather that those are hydrothermally altered rhyolites. And all these staurolite, garnet, and gahanite in particular,
Yes,
they're all
sir.
metamorphosed alteration zones. And there have been a lot of studies on gahanite in particular and the Zinshian staurolite, which all points to a metamorphosed VMS type alteration. But have you considered this, while doing your, work or research? I just want to know. Have you considered that these are metamorphosed felsic volcanics rather than metapellites, as you in your presentation have suggested?
So these are probably metapellites, since they're...
No, I'm asking you why do you call them metapellites when there are more than 10 or 12 international and national publications right from 2003 to 2021, which rather clearly proves in peer-reviewed journals that they are rather not metapellites as previously understood, but metamorphosed alteration zones related to VMS type mineralization. So you
Yes,
can
sir.
consider that while giving such presentations. Thank you.
Sir, since the mineralogical composition as well as the formation of this garnet forming reaction as well, and the textural support, that what we are getting here. So metamorphosed metapellites, the sediments which were there in the volcano-sedimentary sequence of Betul, so these meta sediments are acted as the metamorphism, acted as the reactant for during the metamorphism, and they are providing the assemblages we are getting and the metamorphism which we are constricting the pressure temperature. So it suggests that it could be the probably metapellites from this area.
No, it's good that you're doing the thermobarometry and all, but you should consider that there are clear evidences that these are not metapellites. That's my point.
Anyhow, Shampa, I think
Yes,
you have
sir.
to relook into it. There are a number of publications.
They're not.
Praveen has done.
There's no metapellites there. Actually,
relook into it.
Yeah, they are
Yes,
bimodal volcanics with felsic volcanics and altered felsic volcanics. There are no metapelates there.
okay, sir, I will take care.
Okay, thank you.
Okay, sir.
Temporal control linking differential stress and monocyte ages in the Rengali province, India. Abhishek Ghosh.
Hello. Hello. Uh, am I audible? So, good afternoon, one and all. Myself, Abhishek Ghosh, senior geologist from Geological Survey of India, and it is our team work. The topic is microstructural stress strain and vorticity constraints of shear zones, a temporal control linking differential stress and monazite edges in the Rengali province, India. So, the brief outline of the presentation. First, the introduction, then followed by a present geological understanding of the terrain, followed by disposition of the shear zone, and that will be followed by methodology, then the qualitative, semi-quantitative, and quantitative analysis we have done for selected shear zones, then a brief account on the edges of the shearing events, and finally the interpretation and conclusion. So, this is the Rengali province. These are the previous works has been done. And in this inset map, you can see that it is at the juncture between the Singhbhum Craton, Bastar Craton, and Eastern Ghat Mobile Belt. So several working groups have several introduction for Rengali province. Some called it exotic terrain, some called it hybrid nature suture zone. But we have mapped several areas based on the earlier works, and then it has been found that there are several shear zones. On the north, you can see that BSZ written is that Barakot shear zone, marking the suture between the Singhbhum Craton and Rengali province. Thank you. Then in the south, that RASZ, that is Rairakul shear zone, that is the suture boundary between Eastern Ghat Mobile Belt and Rengali. And then the intracratonic shear zone, that North Riamol shear zone, Riamol shear zone in the middle, and Kirajang fault zone, that is KFZ. This Kirajang fault zone in the western part, you can see in the western part, that is the Bastar Craton. In inset map, it is visible. So that western part is acting as intercratonic shear zone, while the eastern part is acting as the intracratonic shear zone. So for our study, we actually have taken these three intercratonic shear zones, and this is the, we'll go from north to south. This is the North Riamol shear zone. From the field observation, in the northern part, we have seen that it is steeply northerly dipping, reverse slip movement, and in the central and southern part, both are southerly dipping, and all the movements are reverse slip only. Now, in the thin section photographs, these are all the photographs of XZ oriented sections, and you can see the grain boundary migration is the dominating dynamic recrystallization process. You can see the reverse sense of movement in the mica face and quartz porphyroclasts, and then you can see the shearing movement also of the AC fabric. And we have studied grain by grain in these sections, and this north-south line is representing the variation across the shear zone. So the grain boundary migration process is actually dominating in the northern and central part over subgrain rotation, but in southern part, the grain boundary migration and subgrain rotation is having equal share. Now in the middle, this histogram bar diagram is nothing but the calculated differential stress, that how intensely the shear zone was stressed. From it can be seen that from north towards south, the differential stress has increased. Now in this RS, phi and WM, this RS is the imposed strain, and this is calculated by RFI method of calculating finite strain by Ramsey, and the WM, that is kinematic vorticity, that has been calculated by rigid gain net method by Jessup et al. And these are showing that RS, in the middle it is 2.03. So in the central part of the shear zone, it has increased to maximum, while in the margin it has been reduced. So the kinematic vorticity says that the WM value 1 means it is entirely simple shear, and WM value 0 means it is entirely pure shear. So 0.74 to 0.78, that indicates that it is a subsimple shear, but it is dominated by simple shear movement. So and in the middle part and southern part, the simple shear and pure shear is quite equal. These are the photographs of few analysis. We will not show all the photographs because that will kill the time. So now the Riamol shear zone. Again, in this Riamol shear zone, you can see the delta structure, you can see the flanking microstructure, you can see the ductile deformation of garnet, which indicates quite high temperature of deformation, sometimes cause 800 degrees Celsius also, and chessboard subgrain in the quartzite of Riamol shear zone. This also indicates deformation above the 700 degrees Celsius. So here also this from northwest and northeast on the above, it is written that same southerly dipping shear zone is acting as reverse slip and also normal slip. So there is change of direction of movement along the similar shear zone, and in central part it is southerly dipping with the reverse slip movement, and in southern part it is northerly dipping and normal slip movement. That can be possible because a shear zone generally acts as an anastomosing shear, so that can be possible, but the first northeast and northwest variation is quite unusual. So in the dynamic recrystallization part, in the northwestern part, grain boundary migration is the dominating process, while in the northeastern part, the grain boundary migration and subgrain rotation, we have found both are almost sharing equal proportion. And in the central part, again, grain boundary migration is dominating, but in the southern part, the subgrain rotation is the dominating mechanism of strain accommodation by dynamic recrystallization. And in the paleostress, you can see that from north it is to south in the core area in the central zone, the paleostress is again lesser, just like North Riamol shear zone. This can be due to that high temperature deformation and reduced viscosity, or just due to the rheological contrast. And then the strain analysis, finite strain, again we can see the highest value of stretching has been found in the central part, like North Riamol shear zone only, and the kinematic vorticity indicates that northern part is mostly dominated. All the zones are subsimple shear only, means general shear, but the proportion of pure shear is more in the southern part, in central part, in comparison to other parts. So next, this is the Kerajang fault zone. And though it is called a fault zone, but it is also a shear zone only. And here, Kerajang fault zone is quite narrow. That's why we try to find that east-west variation along the strike variation. And there is not much variation because in the west and in the east, you can see the sample locations. And the subgrain rotation is dominating mechanism. In the east, bulging recrystallization has also increased. But one thing that while in the other areas, other shear zones, you can see that the paleostress was, means differential stress was more than 4 or more than 5. Here it is only 3, and it is just equal or constant throughout the shear zone. And strain analysis is showing that The maximum stretching is in the western part, while in eastern part the stretching is less, while the angular shear, that minus 21.4, actually indicates that more dominance of pure shear or more effect on the pure shear in the finite strain, that is the final strain, what we are seeing now. And Wm is 1, that is that western part is completely simple shear, ideally simple shear. And in the eastern part, it is a subsimple shear, though simple shear is dominating still, but it is pure shear is considerably there. And in the field photograph, you can see that dragging and this means detachment are also there. So this is a representation of shearing in the brittle ductile transitional domain that is quite shallow crust in comparison to the earlier shown Riamol shear zone and North Riamol shear zone. So, and subgrain rotation is the dominating dynamic recrystallization process you can see from the photomicrograph. Now, the UPV edges of monazite, this left one from the overgrowth zone of monazite and deformed zone of monazite or deformed zone, and that is been found that Neoproterozoic 998, almost 1,000 years, so 1,000 million years. So Neoproterozoic movement is means calculated for Kirajang fault zone, and for Riamol shear zone on the right, it is 2167, almost Paleoproterozoic age. So Kirajang fault zone is quite younger, and together our interpretation and conclusion is this is representing a transpersonal partitioning. The movement reversal along the strike may be due to the the movement reversal along the strike of the northeastern Riamol shear zone is maybe due to the restraining and releasing bend along the step over of sub shear zones, and this also interprets that the Riamol shear zone, and it also validates from the map pattern that Riamol shear zone is slightly oblique in comparison to the proper direction of movement, and across the strike segmentation of produce the alternating reverse and normal behavior, and this is sometimes transitional releases are there in compressional regime also, so it is quite common. And central segments of both the shear zones of Riamol shear zone and North Riamol shear zone has experienced high temperature deformation in comparison to the margins. So the differential stress is lesser in younger shear zones. So that may be due to because Kirajang fault zone has tectonic activity in Neoproterozoic. So in other way, that stress release was in Neoproterozoic. So the time of stress buildup is quite less. That's why the stress is 3.09, differential stress is 3.09 megapascal, almost half of the Riamol shear zone, which is Paleoproterozoic. Thank you.
Thank you, Abhishek. The house is open for discussion. Yes.
Yes, it's a very nice presentation, and your data is also very good. I have one question. You are doing this vorticity calculations, and also these your strain gradient you are calculated in the whole area. Are you just get any, or you are having an inference of that, the relationship of this your displacement and the width of the shear zones?
Sir, last part, please.
You are just having some displacement during this shearing, and you have a relation of the width of the shear zone.
In the minor shear zones, the displacement has been calculated. That is in the meter scale from that is that deep separation or strike separation based on that. But for net slip, we need to get displacement of two different orientation that were not available in the field.
Quantify displacement in relation to the width.
No, in ductile shear, for brittle fault zone it is easy to calculate, but for ductile shear zone, until and unless we get that situation, that measurement will have no meaning, because that total displacement for that two different orientation has to meet a point, and that point in the hanging
because
walls
you are using the empirical method that Yes, that is based for on that the... it is required, it is having a relation because correlated all the three shears you go.
Empirical relation is based on the recrystallization processes and the grain diameter, and based on the long axis and short axis aspect ratios and phi angles. So that can be done, but for getting the displacement, that has to be done in the field only, and for that, that opportunity has to be there in that section fault plane in the hanging wall block as well as footwell block that was not available in the field.
Okay,
so for that we did not could not calculate that.
Thank you.
Yes.
Thank you. Thank you, Abhishek.
Yes. Mic is going.
Hello. Yeah. Abhishek, can you go to the conclusion part? Okay, fine. Yeah, Abhishek.
Just 1 second.
Yeah.
Yes.
The fourth point, central segments of shear zones are strain localized and experience higher temperature recrystallization GBM, whereas margins show more subgrain rotation bulging features. Now, how do you explain the margins of the shear? Means, if we consider the entire thing to be a shear strand, the margins are having higher stresses because you are having subgrain rotation and bulging recrystallization. These are features of higher differential stress. And the central segment is showing grain boundary migration, higher temperature, yet lower differential stress. You have used the empirical formula of Steep and Tullis 2003.
Yes.
Yeah. So from there, did you try to find out the differential stress at the margins and at the center?
Yes, that is I have shown here. This north-south line is actually the northern margin, southern margin,
okay,
and the central is the central part only.
Yeah.
So here also, that's why I have written this line that lesser stress in central part, but even in RS you can see, and I have mentioned also that RS value of the core part is maximum. So not only for grain boundary migration, the stretching is also more. So we thought about that why it is happening, which is unlikely. And there can be two reasons. One is that rheological contrast or fluid availability that sometimes that is why the reduced viscosity due to which that stress build up, means stress got accommodated. That can be one mechanism. And regarding rheology, we have we were quite careful. So rheological contrast was not that much until and unless during the fault happened, that fluid availability that was out of our scope of study. So that's why it is a bit risky to comment on that domain. But the thing is that this can happen because of this such lesser stress development, differential stress development can be there.
Okay, nowadays another concept has taken form, that is a hot on cold shear zone. Yes. So basically you can think about that, but it's out of scope for you right now, but you can think.
Now the last geothermometry thermometer I have used is trace element thermometry, that is titanium and zircon. I have used the revised calibration of Ferry and Watson 2007. The activities of SiO2 and TiO2 both were set unity in this formula because samples contain coexisting quartz and rutile. As we can see from the result, the maximum Ti ppm was around 76.50 and the maximum temperature was 980.40 degrees centigrade and the lowest was around 821 degrees centigrade. This highest temperature 980 shows that most of the zircon may have formed during prograde or post-peak metamorphic evolution. By combining all this, I have come to the conclusion that Bandavedi area of the Eastern Ghat mobile belt preserve a robust evidence of ultra-high temperature metamorphism with a peak condition exceeding 1000 degrees centigrade as demonstrated by the presence of textures like sapphire plus quartz, spinel plus quartz, orthopyroxene plus sillimanite plus quartz. The mineral chemistry also strongly supports this ultra-high temperature metamorphism with orthopyroxene showing Al2O3 content up to 11.1%. The pseudo-section model we have constrained given the result of approximately peak condition at 9.2 kilobar and 1025 degrees centigrade and the retrograde condition at 7 kilobar and 970 degrees centigrade. The conventional geothermometer, isoplate geothermometer and advanced trace element thermometer all are in concordance with the temperature derived from pseudo-section modeling. I have to as we can see in this image, the PT path is almost clockwise isothermal gradient. The clockwise PT path reconstructed in this study reflects deep crustal burial followed by rapid near isothermal decompression and exhumation linked to collisional tectonics within the Eastern Ghat mobile belt. Thank you.
Thank you. It's good to see a paper from BHU on classical metamorphism. So you have used so many thermometers. Which one do you think gave the best result?
Sir, actually...
and what was the necessity?
In Eastern Ghat mobile belt, the ultra-high temperature, we usually get around 970, 960 degrees centigrade. There is very less reporting of above 1000 degrees centigrade. So to confirm that, we have to do a lot of geothermometer because conventional geothermometers are not very useful around 1000 or above that temperature because they are based on Fe and Mg exchange that after 1000 the Fe Mg blockage starts and conventional geothermometer are not very good for that. That's why we used alien opaques and that trace element.
Any question from the house? Right, thank you, Abhishek Singh. We'll go to the next presentation. Signature of intracrustal carbonatitic metasomatism and its potential in RE exploration. Case study from lithoassemblage from the Khuntapara block of Eastern Ghats by Devjani.
Good afternoon to all. Our topic is signature of intracluster carbonatitic metasomatisms and its potentials in RE explorations, a case study from a lithoassemblage from Khuntapara blocks of Eastern Ghat. As we know that the demand of RE is increasing worldwide while the supply becomes restricted. The common alkaline, mafic, ultramafic intrusive complexes such as cyanide, pyroxenite associated with the carbonatite or phosphorite are now seen as an important host of common RE-bearing minerals. So they are also important for understanding the deep mantle processes or unusual magma compositions. As per global database, 530 number of carbonatite have been reported, among which 29 known occurrences are from India. In our study area, the Kuntapara, within Eastern Ghat mobile belt, the carbonatitic magma didn't reach the surface of the earth. So I will explain how this carbonatitic magma interacted with the surrounding rocks to form the alkaline or mafic, ultramafic bodies instead. Eastern Ghat mobile belt is a polydeformed and polymetamorphosed granulite facies terrain. So it has been classified into different domains as per the lithology and geochronological constraints. So our study area is located at the northeastern side of the Eastern Ghat within the Chilka Lake domains. So these areas have been subdivided into the 3 different suites of rocks. The first one is the older suites, consisting of the charnokite, mafic granulites or khondalite. And second one is the granite gneiss that cuts through the older metamorphic suites. And third one is the mainly cyanite, pyroxenes or apatite-rich rocks. So these ensembles is trending north-northeast, south-southwest directions and is transected by the east-west Mahanadi shears. However, these ensembles is unaffected by the regional granulite facies metamorphisms. Therefore, these ensembles was emplaced subsequent to the granulite facies metamorphisms, but prior to the Mahanadi shearings. The charnokite is the most dominant lithology of our study area, consisting of mainly quartz, feldspars with minor amount of garnet, orthopyroxenes and clinopyroxenes. Similarly, granite gneiss is medium grade, consisting of quartz, alkali feldspar, plagioclase feldspars with minor amount of biotite and pyroxenes. Pyroxenite is mainly composed of coarse to very coarse grained clinopyroxenes with diaphysetic compositions associated with feldspars and titanite as well as magnetite. Allanite present a significant amount within pyroxenite. Cyanite is also very coarse to very coarse grained and composed mainly of alkali feldspar, plagioclase feldspars with minor amount of monazite, apatite vasnesites, etc. EPMA data has revealed that the barium oxide concentrations of these feldspars within cyanides is ranging from 2 to 16% and has been considered as the barium-rich feldspars as per DR et al. 1965. Apatite. Apatite is mainly the randomly oriented vein occurring at the interface of cyanide and pyroxenides. So these are mainly leucocratics and formings, the medium grained, and in EPMA data, the BSc image shows the 2 distinct variants of apatite. The lighter one containing the high RE concentrations, approximately 6%, and the darker one containing the low RE concentrations, approximately 3%. So these 2 variants possess the vermicular intergrowth textures. The calciums and thorium content are inversely related. So that indicates that the thoriums is calciums is replaced by the thoriums. The apatite is mainly fluorapatite in compositions, and the fluid inclusions results indicate that the only monophase carbonic inclusions is present within this apatite. So this apatite is highly enriched in RE. Approximately 8.2% of RE has been reported from these apatites. So the trace elements concentrations have been analyzed. So these diagrams indicates how the trace elements concentrations indicate that these apatites derive from the carbonatics or mantle derived or from metasomatics or hydrothermal alterations. So in that case, the apatite have high concentrations of LRE but comparatively lower concentrations of strontiums by yttriums as well as the lanthanums by ytterbiums, indicating that there is the transitions between magnetics to metasomatics or hydrothermal phase. Similarly, in these diagrams, most of the analyzed apatite plot in our study area within carbonatitic fluid-driven field, indicating that this apatite has undergone the metasomatics or hydrothermal phase rather than the simple magmatic crystallizations. So there are the series of diagrams indicating the ppm values and the elementals ratios within apatites suggests that this apatite was derived from the primitive mantle source or with minimum plagioclase fractionations. At the left-hand sides, there is a plot of RE concentrations from LAQ ICP-MS as well as the bulk chemicals compositions. Overall, there is the downward trend indicating that this apatite has undergone or these apatites corresponds to the carbonatitic magma. Similarly, the EPMA data also follows the similar trends, but more scattered. So these scatterings is due to the compositional heterogeneity at microscales or due to the vermicular intergrowth textures or metasomatics effect. So on the basis of this study, we have proposed the 4 stages evolutions models of this intrusive complex as per the experimental work carried out by Vasukova, William Jones and other workers. So as we know that the carbonatitic magma has been generated by 0.5% partial smeltings of metasomatized mantle-derived rocks. So these carbonatitic magma, when interact with the surroundings rocks, this can form the other minerals. The early metasomatic stage involves these interactions with this carbonatitic magma with the surroundings granite gneiss or charnokites, producing the clinopyroxenes with minor amount of soda feldspars and allanite as well as the titanites. So these stage, the mass balance calculations also indicate that there is a sufficient transfers of calciums and magnesiums from the intrusives to the surroundings rocks. So this stage absorbs much of the carbonatitic magma and producing the alterations minerals around the intrusives. This stage is also called the first pulse of these carbonatitic metasomatisms. At the second stage, after the formations of sufficient quantities of clinopyroxenes, the residual smells becomes depleted to the calciums and magnesiums but highly enriched with bariums as well as the potassiums. Thereby, when these smells interacted with the surroundings wall rocks, so they replaced the earlier formed pre-existing plagioclase feldspars by the barium-rich feldspars. So even the small degrees of replacements require the large influx of bariums and thereby forms the megacrystic assemblage. So this stage is called the late metasomatic stage, and even the carbonatite is generated at this stage that can be infiltrated or precipitated as the secondary carbonate or calc silicate rocks. And the third stage is called the phosphorite stage. When the magma evolved, the residual smelt becomes highly enriched in fluorine, chlorines as well as carbon dioxides and phosphorus. Thereby, this melt facilitates the formations of apatite with RE and thoriums. At temperature less than 300 degree, fluorine act as an effective transporters to partitions the thoriums as well as RE. So this stage is called the phosphorite stage. future RE resource and refined the mineral systems models. Thank you.
That's a good work indeed. But did you do any stable isotope studies like strontium or oxygen?
Yes, sir. Yes, sir. We did some stable isotope study. The value is quite higher, approximately 0.716, the value. That means the crustal contaminations is occurring.
That's not convincing for that carbonatitic melt. Okay, the house is open. Yes.
Good afternoon, everyone. Madam, my question is, what is the strike length and width of this carbonatite you delineated?
No, actually, we don't get any carbonatite. So we only get the alkaline or the mafic, ultramafic source instead carbonatites. That was
So
our findings.
the analysis which you have shown, is it actually point chemistry or the sample analytical values? Because it's
Everything.
more than 80,000.
Yes, yes.
So what was the average value in your sample?
Average value is 8.1 in apatites. And we also get the high RE concentrations in pyroxenides and cyanide as well.
So that average value is 8.1%.
No, below that. In pyroxenite and cyanides, the concentrations is lower. I have mentions in my previous slide that.
Because I have worked quite a few projects while being in Andhra Pradesh state, especially in EGMB area only, and basically Eastern Charnocatic zones and Western Charnocatic zone, WCZ and ECZ. My work was mainly on things, but to my extent, we could find lots of monazite apatite grains, and we did actually tested it. But that much RE percentage we could not actually delete it or find. That's what I asked you, whether it is a point chemistry of that particular 1 or 2 grains, or it is actually systematic sample analytical values.
Systematic samples.
Sample values.
Yes, yes.
Okay. Then it's a very good prospect actually, maybe. Thank you, madam.
Okay.
Showing cyanide, so can it be a rift zone or alkaline rock?
Please.
Sorry, ma'am.
So I just want to know, you have shown cyanide and carbonatite, definitely they are related with the rift tectonic settings. So, but you are showing it at the, is the southern part of something rift zone or nothing? No. There are two lineament type of thing you are showing in your map, in EGMB map.
EGMB map, okay.
Yeah. Is there any nearby rift zone within the granulites where these late cyanide or alkaline rocks were intruded? Any idea? No.
No, actually our area is mainly constricted to Kuntapara and the surroundings area. So we have also studied from other data,
okay,
and we have integrated that parts. So there are also actually the carbonatitic magmatisms at this part. So this clan of rocks is oriented along these lineaments, mainly the silure. So trend is also similar to this body.
Actually, if you just plot all the alkaline or cyanitic rocks present in EGMB, they will simply fall along the boundary of the EGMB along with the other cratons.
Yes,
they
yes,
are mostly of DARC rocks. So
Yes.
that's why I just interested
Yes,
was
yes, yes,
about.
ma'am.
Okay.
Thank you, ma'am.
Okay. Thank you, Debjani.
Thank you, sir.
Yes, yeah.
We'll go to our last presentation. 2 minutes. 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 Paleoenvironmental and diagenetic insights from elemental proxies in the intertrapian sequence of the Deccan Traps, Gandwani, Dhar district, MP, India, by Arif Mohiddin Shikdar. Okay, I think is not there. So we can conclude here in that case.
So we do not have this.
He is not there, no?
I'd now request the chair and co-chair to offer their remarks and summarize the takeaways from this session, and then we'll conclude the third technical session. Thank you, sir.
Well, we had 6 presentations altogether in this session. 2 were absent. 2 from the SIMS lab and 1 from the EPMA lab, CHQ, and 1 on structural geology, 1 from BHU, and 1 from Odisha. All the presentations were very well done. SIMS lab, CHQ has been doing good job. I think they are confined to only oxygen and sulfur isotopes these days. So they may extend it to other isotopes. And the work in collaboration with Geoscience Australia in the northern zone was confined to mainly the Rajasthan part. I hope it will be extended to the other areas. The carbonatic metasomatism work by Debjani and others will definitely pave way for good deposit RE exploration, but they have to concentrate on direct evidences rather than indirect evidences, because the Bayanobor deposit of Mongolia is also of similar type, but the evidences are direct in that. I now hand over to the co-chair for his comments.
So it was a very engaging session. Altogether 6 presentations were there, and it created a lot of interest among the audience also. So I thank all the presenters and all the audience persons from the audience who were engaged. So thank you very much.
Thank you, sir. I would now request Shri Asit Saha, sir, Director General, Geological Survey of India, to kindly come forward and felicitate our session chairs. We are extremely grateful to the chair, co-chair, and rapporteur, and all our distinguished speakers for their invaluable contributions. Thank you, sir. We will now break for lunch. Lunch will be served in the convention hall on this floor. We will reassemble here in this auditorium at 2:30 p.m. for the fourth technical session on the theme of critical minerals, energy, and mineral resources. It is also to be noted that parallel technical sessions on other themes will be held in Mini Auditorium 1, Mini Auditorium 2, and the conference hall. Thank you. I hope you all had a pleasant lunch. Technical session will now broaden our understanding of critical minerals through global metallurgy, natural hydrogen potential, geothermal regimes, and the energy relevance of coal and copper-bearing system. To start the session, I would first invite our session chair, Shri Anindya Bhattacharya, Deputy Director General and Head of the Department, Remote Sensing and Aerial Service, GSI, to kindly come forward and take the chair. Shri Bhattacharya specializes in geological mapping, petrological and geochemical studies with a strong body of work on ophiolite tectonics, chromite petrogenesis, mantle geochemistry, and cobalt exploration. May I now invite the co-chair of this session, Shri Vijay Kumar R., Deputy Director General, Geological Survey of India, to please come forward and join the chair on stage. Shri Vijay Kumar's line of work spans geoinformatics-driven studies and mineral exploration. He has significantly contributed to geological and geochemical mapping for improved understanding of Earth's resources. I also request Dr. Suresh Kumar, Director, GSI Western Region, the rapporteur for this session, to kindly take his seat and join us. The first talk of this session will be delivered by our keynote speaker, Professor M.L. Dora from Jawaharlal Nehru University, New Delhi. Professor Dora is a distinguished geologist specializing in mineral exploration and ore genesis with a focus on critical minerals such as nickel, PGE, cobalt, copper, Re, vanadium, lithium, bismuth, tellurium, graphite, etc. A recipient of the National Geoscience Award and multiple accolades for his contributions to ore genesis, he served the Geological Survey of India for over 2 decades, culminating as Deputy Director General. With international exposure across 5 continents and editorial leadership at Gondwana Research, he currently serves as professor at the School of Environmental Science, JNU. Sir, I would now like to call you on stage to kindly deliver your keynote speech.
ये ना नहीं ठीक रहना जी. Very good afternoon to one and all, respected dignitaries, delegates, dear participants, and my dear chair and co-chair. I am going to present about global metallurgy of vanadium as a critical mineral, geological diversity, emerging Indian resource and exploration. Before that, I extend my heartfelt thanks to GSI organized committee, including DGGSI and Dr. Jas Bagchi, for giving me this opportunity to talk on this critical mineral, which is a national importance. Critical minerals are not mere a mineral resource, rather they are the power and progress and play a very vital role in geopolitical shift. That is the reason why the Honorable Prime Minister of India very oftenly emphasizing the importance of critical mineral for Atmanirbhar Bharat. In the sense, critical minerals are extensively used in green technology, almost all technology. Critical minerals are like today's oil, which fuel not only the transition, energy transition, but also the modern, almost all technology. And as a result, critical mineral mission has been launched by Ministry of Mines, not only to strengthen the global, indigenous supply chain, but also to reduce the import dependency. And also critical mineral list has been prepared 30. Why I have chosen vanadium? Vanadium of late is one of the most important among 30. Why so? During my presentation I will explain. Because of late it has been used as a redox flow battery, which is a game changer in energy sector. And moreover, it has been extensively used as in a steel industry as a traditional use. During this my talk, I will talk about why it is critical mineral, unique geochemistry that matters, why vanadium mineral systems, what is snowball earth, how it's play the role in vanadium enrichment, why and why not vanadium in all graphite deposit and almost all mafic ultramafic complex. Emerging Indian resources, what are the exploration implications, what are the challenges, and what are the global best practices in exploration about this commodity. The right-hand corner of this image shows the vanadium concentration crustal abundance is 60 ppm, whereas the left side, the down below image shows extensively used in steel industry. But the upside, the arrow indicates after 24, the orange color says how much vanadium is important for the energy sector, because this vanadium acts as a catalyst as well as a anode for both in a vanadium redox flow battery, which is nothing but a long, which helps in large energy storage system. Any amount it can be stored in form of a liquid form. That is the game changer in the energy sector. Since the Japan is the first country which has critical mineral has listed vanadium in 2006, almost all countries, developing country has developed the critical mineral list up to 25. Turkey and New Zealand is the last which has prepared this year. Everywhere, even including China, which control more than 70% of vanadium, still vanadium is the critical mineral in China's list. This is how these 4 countries, almost China, South Africa, Russia, and Australia control almost 95% of vanadium resource of the world. This is the most important slide of my entire talk. This vanadium possesses unique geochemistry. It has a multi-oxidation state, +2, +3, +4, +5. And it always loves to partition in a oxide, silicate, organic matter, sulfide. Every time it cannot participate, undergo partition, it requires oxygen fugacity and require other available condition in the system. I will explain how things. Because of this partition in a multi-minerals, vanadium associated with 65 minerals structures. Vanadium has no independent mineral. It always enter in the lattice of the other mineral. That is why maximum vanadium percent is 3%. We don't expect iron like 60%, manganese like 30%. The maximum is 30% because it has to accommodate the lattice of the other mineral. That we need to mind it. Then only we will understand the exploration strategy of this mineral. As a trace, I already told, this is one of the very interesting photo where I have carried out during 2019 before COVID. The image, BS image shows that ilmenite exhalation within magnetite. Ilmenite has a titanium iron oxide. The titanium has a 4 oxidation state. Vanadium has also 4 oxidation state, but this is in a reducing setup. Within a magnetite, vanadium is maintained as F3, but in presence of vanadium and in presence of magnetite and ilmenite, vanadium will only go to magnetite because of its oxidation state 3. And moreover, its ionic radius is 0.64 angstrom, both are same. So it will isomorphically substitute. Wherever the Fe mineral is there it will go, either biotite or a mica or wherever, or a goethite or something like that, iron oxide. But it will avoid hematite. Why? So there is a reason for that. In last slide, I will discuss that. And this, once the hydrothermal fluid comes, this V3 will become a V5, which is a mobile and soluble. That will come, but again, that need to be reduced. Once it will come across some
Okay, sorry. Once it is oxidized, then V has changed its oxidation state from V3 to V5. V3 is immobile, insoluble, whereas V5 is soluble and mobile. V5 will go through this hydrothermal fluid. Once it will come across some carbonaceous material like graphite, organism, or some clay minerals, then it will start precipitating. Or rather, it will replace in the form of reducing, that is F3 again. This is the cycle, F3, F5, again F3, because all dominant minerals are F3. Sorry, the hydrothermal fluid has come, these red are sulfides. With sulfide, reduction has started, and the deep blue, these are the vanadium garnet, that is called goldmanite, and the blue color is chloride, that is called muchinite, vanadium chloride, because in both Fe is there, that too Fe in 3 states. That is why this Fe has replaced. Global measure vanadium 5 type deposits, magmatic, that is a VTM, magmatic vanadium titanium oxide type, shale-hosted graphite type, sandstone-hosted Colorado plateau type, and the hydrothermal type, and the laterite type. In Indian context, 1 to 5 is important. That 3 I will discuss in detail. What are the factors responsible for vanadium? Source, two sources. Either it require a mantle or it require a marine. Either of it is required, otherwise there will be no vanadium. Process, if it is igneous, late magmatic, evolved magma, and if it is sedimentary, diagenesis followed by metamorphism, followed by hydrothermal. 3 processes required for a sedimentary type graphite type deposit. Redox condition, the change of valency is a play major role, and the oxygen fugacity which dictate the change of oxidation state. That is what the most important when magma comes melt, that time oxygen fugacity is very low. That time Fe3 states, and when evolved magma it comes, Fe changes its oxidation states. And what is the tectonic setting role? Vanadium will not, if it is associated with mafic ultramafic complex. Mafic ultramafic complex form in a rift setting, arc setting, subduction setting, but the vanadium always prefer in a layered mafic ultra complex under aneurysm setting, that is a rift setting, because of its conducive oxidation state of Fe3. If it is sedimentary, then passive margin intercutting basins are classical, and this is one example, layered complex. In a layered complex, vanadium will never come with ultramafics. It always comes mafics or at the transition of mafic and anorthosite. This is one of the very important photo I have taken from Rohit Pandey and Chalpati Rao sir paper from 2013, it is published. Very interestingly, the orogenic and anorogenic dikes, mafic dikes in Bastar Ketan, they are showing beautiful exolution of ilmenite magnetite. The magnetite carries very good quantity of vanadium. Why vanadium is not universally present in almost all layered complexes? The reason is that this is the global lithostratigraphy. Bushveld complex of South Africa, Windermere complex of Australia, or Lake Bay complex of Canada, and the Fanzhou intrusion which is in China. These are the typical layered complex, not much disturbed. It is like a stratiform sedimentary type deposit types. There chromite will come, along with chromite platinum will come. But vanadium will always prefer, because it's slightly incompatible with that, and it will always prefer to be in a melt. When magma is evolved at the late stage, when the mafic ultramafic transition occurs, there it will start reducing. That time oxide will start in the systems, then it will enter. Whereas India is concerned, more than 15 mafic ultramafic complex GSI we have mapped, rather we have compiled, not mapped, compiled from here and there. The circle part, okay, this, it is not working. That circle part is the west coast side. Because of laterite cover, only here and there we are getting plugs, but major part is covered by laterite. These are in the field photographs. This is the layered complex, the top layered complex. This hammer has kept there the magnetite layer. Entire thing you need not sample, only that part sample. Within that also we require, we generally we call it a platinum reef. Like that, it's a layer wise 1 cm, 2 cm, 3 cm, like that sampling we need to do. Entire you will sample, everything will be diluted, very difficult to get. These are the gabbro, melanogabbro and the gabbro, where the plagioclase starts appearing, that time oxide starts forming in the system. This is the one clue. Then, because of its diverse, it is associated with diverse rock types, very difficult to study and very difficult to plan in exploration. That's why it is a very much rather mandatory to understand the mineral system, applying the mineral system approach. Where the melt has come, how magma has come, what is its conduit, then how the oxide starts saturated. In our area, we get mafic, ultramafic rocks, but ultramafic, you don't get any vanadium. The reason is that vanadium will never competitive with olivine minerals. Vanadium is never competitive with nickel minerals. They are the one spectrum, but opposite end. First nickel PG, then the last will vanadium. So we need not to see ultramafic rocks when we are mapping. Our concentration should be on mafic rocks. Mafic rock, that too gabbro, anorthositic suit of rock. This is how the mineral systems will help you. If you are doing gabbro, then you need how that gabbro has come, how it has fractionation has happened, how the segregation, oxide segregation happened. That need to be hand sketched with that, everything you need to do. If it is a graphite hosted vanadium, it is almost all 99% graphite hosted deposits are structurally controlled. They are dismembered here and there intermittently 100, 150 kilo, 200 kilometers sometimes it happens, but they are always concentrated here and there along the structural either fold hinge or some shadow zone. The geological potential is concerned, India's geological potential is concerned, as for the Geoscience Australia 2019 data, we have, as for their data it is low, but it is not low. Low is only concerned when we are talking about BTM type. But now we have India has GSI has established enough resource from a graphite hosted as well as now adding from even a bauxite hosted laterite type deposits. So our geological potential is very good. Rather we can bracket it moderate to high. We cannot low. PG when we are keeping moderate in the same system, vanadium divergent and area is more. So it is better than PG. PG is only Bowlanwasa and Sitampundi, Hanmalabra, only 3 there. But for vanadium, the diverse field is there. So in nowhere it will be low, it is more than that. And in India, TBM type, graphite type, laterite type, and their geological potential is moderate to high type, low to moderate to high. Vanadium, graphite, uranium mineralization, they all occur together. 99% times they occur together, but some factors play the role, they sometimes miss. Why they occur together? Because of their shared geological environment, common physiochemical conditions, and metamorphism hydrothermal play a very important role. Graphite can withstand any temperature, it can withstand. But along with the graphite, vanadium occurs, but in a granulate system, vanadium will go out of system, out from the system. It will, because of the V5 state, it will be removed from the system. That is why many times, the reason is that why we won't get much encouraging vanadium in Odisha graphite, rather southern granulate graphite, Sri Lanka graphite, Mozambique, almost all they are the all high granulate granulate. We get, but not at the more than 1%. All are 500 to 1500 ppm like that. And vanadium always partition in a graphite type in a mica, that is a roscolite. It is always preferred. This is one Betul graphite deposit where we have carried out in 2019. Sasar was our that was supervising this, though he was RMS too, but like director, he was so closely interacting that time. It is a beautiful. Apatite is your uraniferous, amphibole is your vanadiferous, and because of the pyrite, the hydrothermal fluid is reducing agent got, and uranium has precipitated. In a 1BS image, once you see the assemblage, then you will have hope that yes, if it is occurring in a grain scale, it can occur in the mesoscale as well as the regional scale. The process is the same. This is the process. Sorry. And you see, sir, this image says the Colorado Plateau type of uranium, sandstone hosted uranium graphite deposit. There is no space left 5,000 square kilometer in the western side. You see, sir, our country only 5 green, they are the prospecting stage, only 1 red, that means it is in the advanced prospecting stage. You see the USA side, how much work they have done. Sir, it is exploration, we need to take a risk, we need to test with taking all risk, otherwise we can't get, sir, that is very difficult. First, understanding system, that is important. Why vanadium mineralization is not universal in all graphite deposits? Because of source rock. If it is not available in source rock, because in distant Ghat all are chondrites, their organic other associated, even iron oxide minerals are less in that. That's why one of the reason. High redox condition never allow. It will always vanadium in soluble states, so it will never allow to precipitate. High grade metamorphism, it will help to out of the system. Absence of suitable mineral, as I told, vanadium is no independent mineral. It always go with oxide, preferably first, then followed by clay mineral. The last one is the silicate. If it is there, it is there. In Rajasthan also, vanadium, we are not getting much. Not getting much because here it is a protolith is a pellitic rock, might be pellitic rock, not other rock like in a Betul where your blackish shell. In Odisha also, like that, Sri Lanka, Mozambique, there are so many examples worldwide. In Namibia, that is called Damara granulite belt, world-class giant, ultra-giant graphite deposit is there, but no vanadium. Then how vanadium has come into the system? Earth has undergone glaciation minimum 4 times during Proterozoic, Paleoproterozoic once, during Neoproterozoic type thrice. During this time, what happened, because of this, after the deglaciation, lot of fast weathering has happened, and as well as this time, ocean water is in euxine condition, massive burial organism was started, which was ideal condition to precipitate vanadium in the, and at that time iron oxide minerals were there, they scavenged, or even the organic clay in the ocean sediment, they scavenged. That is one of the example. During 2000 million years, Bethel graphite deposit formed. World few big deposits were formed. These all are sedimentary graphite hosted type, not BTM type. During this Neopatrician time, you see how many deposits were discovered across the globe. This is the period, is the fertile period for vanadium precipitation across the globe. If you see the bracketing age from 800 to 400, but the snowball earth age is 735 to 630. That 95 year is snowball earth. But you see, sir, during these billions of deposit billions of amount, 55 billions of ore has formed in Hunan province of China. That means 55,000 million ton of such a big deposit. In Sweden, 2 billion ton deposit. Elsewhere, it is a 3 billion ton. These are the, during snowball earth, these are the big deposits formed around the world, Mozambique, Namibia, all these things. As India is a concern, where we will stand? That is the, I think, sea, where the oxygenation has happened, twice it has happened after the deglaciation. This 800 to 640 period is our upper part of your Vindhyan basin, upper part of your Kadapa basin, Khoriar basin, Kaldagi basin, or Marwar basin. So many basins are there. But I don't know, I am not a sedimentary geologist, but what is the thickness of shell if one need to compile black shell, and in a black shell how much TOC is there, then we can model it. And the classic case is your uranium we are getting, and in a mineral system also we can do it from the Kadapa basin. This is one of the important and the emerging Indian vanadium resource. We never approach vanadium as our first target. We always tried for graphite, vanadium is always additional resource. We always tried for PG, vanadium is always additional resources. That is the second fiddle type, and for other bauxite, vanadium is coming as a additional. But we never, approach is different. This is such a tricky mineral, very difficult to do any exploration strategy unless very focused approach is required for this mineral as concerned. You see Himalayan belt from northeastern India, it is one of the emerging and many one like a critical mineral. If graphite vanadium is coming, everyone is talking in academic sector as well as industry sector as well as everywhere. And yes, Itanagar. GS has done marvelous in last 4 to 5 years, 7-8 blocks have auctioned, and but entire, not Darjeeling, Sikkim, your Sikkim Himalaya, your Garhwal Himalaya, your Himachal. One of the report I was coming across, 1880 and 1890 middle moss has worked. 400 feet graphite deposit has discovered in Jammu of that Himalaya. What is the status of that? I don't know about 400 feet, that means 150 thick graphite, big deposit. If that is there, it is in sedimentary form, it will never pinch out in a quick sense. It will continue. Like the Arunachal Pradesh status might be there, but I don't know where that area falls. We need to check. Then what are this is another emerging area, laterite. Even primary source we fail to get vanadium, but here we should not fail. This is a gifted one, but laterite can form anywhere, everywhere, because we are in the tropical country. But one thing, laterite not over ultramafic rock, laterite over a mafic rock, or then classic case is a Deccan basalt. I will whether it is there, Deccan basalt, your Pir Panjal basalt and Silet traps. But they all are not in the same geological domain. They are neither in a geological same domain nor a geological time scale. But Deccan flawed basalt, it is a tholitic, continental. Only unfortunate part, had it been a more related basalt, it is in vanadium enriched. Still, any laterite form over a basalt, then it will give fantastic value. One we have already tested, Vikarabad, we have taken the items during Janardhan Prasad's time in Hyderabad. 6,000 ppm vanadium in a graphite, in a lateriferous, ironiferous bauxite. That is a laterite, 6,000. But that zone need to be established, then sample accordingly we have to carry out. Then only you can establish where it is exactly coming. This is the laterite process I don't want. in the center, that part. And the, even the Deccan, the laterite which are formed in the Chhattisgarh over the Amarkand plateau, that is also very ideal. Whereas in Odisha, maximum laterite is over the ultramafic rocks where nickel is the dominant. If nickel will come system, vanadium will not form. That also, and this part, your Silla trap and these are the alkaline type of basalt. They are also one of the good indicator. And this is the where, sir, we need to do. And recently we have published in Earth Science Review. We have reviewed the entire, but no, it is not related to critical mineral, not to vanadium. But now we will think in that angle. Now, after going through this literature, I understand what is the system, how we need to go through. And because as our hinterland is a basalt trap, your Deccan trap, the west flowing rivers, even a beach sand also, we are getting very good concentration. It is a GSI publication, last year GSI publication, around 4,000, 5,000 ppm vanadium we are getting. Here ilmenite is less because ilmenite only vanadium will replace with the Ti4. In the vanadium oxidation state V4 is a very transition phase. Either it is F3 or a F5. It both require. V4 is a very, for a momentary period it will come. Otherwise it will go either this way, that way. Exploration challenges, of course, because of low grade discontinued mineralization, as VTM is concerned, they are always like occurring like lensodal bodies. Very difficult to understand because of so much alteration. We can't trace out it is whether it is from ultramafic or mafic. That is a challenge, but one can do, if passionately do, one can, one thing, it is not that much difficult, one can do, definitely. And because of metamorphic overprint, what happened, there is exploration guidelines for a vanadium exploration. What? These ratios, vanadium titanium, VTM, and it is for VTM, vanadium chromium ratio, vanadium numbers in a black cells for a graphite roasted. But this, where there is no metamorphic, in a metamorphic, I forget to tell, sir, the ideal condition for vanadium with graphite is lower amphibolate phases, up to that. If above that, then vanadium will be, sir, I don't know whether it will be in the system or not, that need to be thorough petrography, it will give help. Geophysical poor response, because of the sedimentary thickness is less, it is always intercalation with other rocks. We never attempted the way we are doing STM for other precament terrain. Sedimentary basins we have, I don't know much about this, but it requires like a sequence stratigraphy study or basin evolution modeling. Then we will understand definitely which layer, redox states, everything we can calculate, because this is, 4 number is a very important where we can revisit. And I have already told, second field treatment for this, that is also one challenge. This is a complex mineralogy and limited process technology. This is the where GSI has done and it will do. It has already 175 years, again another 175 years will live. This organization, its strength is there. But the biggest unfortunate with our country is, I openly say, mid-processing is the biggest challenge. Being an exploration geologist by profession, but now I practice as an academician, I understand what is the difference between this and that. But the biggest challenge is this. Unless we do this, difficult to think about the critical mineral, because hardly out of these 24 critical minerals, hardly 4 or 5 they form a deposit. Otherwise, they always occur with other mineral deposit as a co-product or a byproduct. In that circumstance, beneficiation is the most important one. Without this, we only follow the traditional powder, traditional methods like grinding and your sodium roasting, then followed by acid treatment. But that also, different type of vanadium deposits are there, different flows it is required. But in Indian literature, I didn't come across much compared to other. That is why I compiled another list. What is the global best practices? The global best practices is that vanadium always to be studied by using mineral system approach. That is the mandatory. Otherwise, this is such a tricky mineral. Haphazardly, randomly if you do, we cannot establish any zone. Because we are doing for other minerals, if you, anything it is getting, it is a buy one get one type, जो भी मिल रहा है उसमें खुश है. But ऐसा नहीं है. अगर if you target for vanadium, then exploration need to be mineral system approach, mineral system driven exploration strategy. And integration geoscience data nowadays GSI is aggressively doing. I need not emphasize much. But the analysis part where I need to emphasize thing is that we do vanadium analysis in our GSI as for my understanding is concerned by XRF, because it is a quick solid state, but it cannot possible if it is with graphite hosted, if it is with laterite hosted. we need to change that also. If it is laterite, then acid leaching type, aquaregia type. If it is black cell, acid leaching type, and the ICPM is the best for dissolution type. 1 or 2 deposit we can do experiment. And the beneficiation that I have already told, China, Canada, Australia, Brazil, they are doing microwave plasma study, sensor sorting. I must acknowledge Ministry of Mines has funded me a project for doing research. Just I started for vanadium. And DG GSI, Bakshi sir, other senior ADGs of GSI, and the chairman, convener, organizing secretary of this wonderful seminar, they have given me opportunity to talk about. If any questions, any clarification there, I love to take and interact.
Thank you so much, Dr. Emil Dora. It was a pleasure listening to you. It really had been a kind of a learning process for, I think, it was for me, definitely it was for many of them. So the session is open for discussion. Any queries, please?
Please bring the microphone in the audience.
Apology for crossing my time limit.
We'd love to listen to you.
Hello. Tell me, what is the age bracket of Indian, those vanadium deposits, the graphites of the Himalayas, and what are the age bracket? That is Cambrian,
sir,
right?
Crole Thal
Cambrian.
will definitely be on the neopatrogic side, sir. It means rather means I have
towards Cambrian.
Towards Cambrian, maybe that whoever worked in, I think they can comment on that. But Betul is concerned, I am pretty sure because rhyolites come after that bimodal volcanics. Before that, this because it has undergone intensive shearing, that means it is before 2000 million years.
These are the two basic ones, and for the laterite.
Laterite. I can, sir, thrust more on laterite.
And then the Himalayan ones are oxides.
Himalayan is a graphite type, that is a black cells, like the way.
Are they sulfides or oxide there?
Sulfide there should be in the system, but there, sir, all are graphite hosted. Graphite hosted. Without, sir, iron oxide, the takeaway minerals are, absorbing minerals are clay or your iron oxide mineral. If iron oxide mineral there, it will replace isomorphically. If a clay mineral is there, it will adsorb. It cannot replace, it cannot enter within clay. So only it will adsorb.
We have not yet identified the phase, no?
That, sir, mineral wise we need to go, sir. That the best way is doing sampling, then petrography.
And
then
what about the Betul one?
Betul one, sir, I think a very good resource they have established, and they got the National Geoscience Award.
What is the mineral?
Mineral, there is a rose collate, sir. Mica. And recently, this year, mineral award also got that is associated with phosphorite. I think in Himachal.
Nigalidhar. That is the Nigalidhar which you said.
Yes.
Okay.
Just a second. You have got vanadium graphite deposits in Arunachal Pradesh as well as in this northwest Himalayas.
Sir.
What is happening in the area between this, I mean this Nepal, Darjeeling Himalayas, Sikkim Himalayas, Bhutan? Is there any report of this type of deposits over there? Or if not, why? I mean, why it is not?
Sir, I am pretty sure it is a sedimentary type things, and it is along the MBT and MCT. Somewhere they might have intermittently, but that black cell might have continued, sir. As per my understanding, that is the why I was curious about Jammu and Kashmir. When I was searching for Jammu and Kashmir, one side northeast, it is sure, there we are doing. Other side, it is extreme, is Jammu and Kashmir. And the middle one, already this year they got mineral award. I know. But the Jammu and Kashmir, when I searched, I got the middlemost report of 1890, which is a 400 feet thickness graphite deposit. But that graphite deposit must have contained vanadium.
Uttarakhand में भी तो there are black shells.
है.
Vanadium is there.
हाँ सर.
ये जो Crole basin है ना, this is right from Solan, it is continuing up to that ये Uttarakhand में hill station Nainital.
Nainital, sir.
And they are asymmetric informal basins where it is basically in the Crole formation. It is not in Tal.
Sir.
Because Tal is towards Cambrian, and they are all sediment, this marine sedimentary basins. And beyond that, in the Central Himalayas, जो आशीष sir पूछ रहे हैं, बोल रहे हैं, I think that has been translated by the central crystalline thrust. So they have been translated, and the basin is underlying the center crystalline thrust?
Sir, actually, if it is a phenrozoic, we will get, sir, a big type deposit. If it is a proterozoic, then because of this metamorphism all has deformed so many times, metamorphism multiple times, process has recycled, it is very difficult to get big type deposit, only vein type deposit 5 million ton, 10 million ton. If we are thinking for big deposits, sir, then phenrozoic we can. No, sir, that's why I am saying, no, sir, in phenrozoic we can expect big deposit.
Any more queries?
Yeah, Professor Dora, actually, you have answered my query in your discussion with Bakshi Saab. I was interested to know the mineral phases because every year, Geological Survey of India and other agencies, we are going to prove reserves of vanadium. But due to uncertainty in the mineral phases, how we are moving for the metallurgy process, we are proving every year reserves. But it can be separated what metallurgy can do with the known data about the mineral phases. That was the concern. We are proving every year, but whether it can be extracted in real or not.
It can be extractable. If other countries are doing, why not we? But we are not in that process. We will slowly adapt. And you rightly asked the very important question.
We'll just take
mineral phase.
We'll just take another 2 queries.
Mineral phase. That is important. As I told, vanadium has no independent minerals. It always prefer to go with other minerals. It is like a cuckoo. It will never lay its own nest. It will nest in the crow's nest. It is a mineral character is like that. It will always enter in the other mineral. Like the first preferable mineral is magnetite. Then titanomagnetite. Then it will go to silicate. If organic material is there, it will go with pyrite also. If apatite is there, it will go with apatite also.
Dr. Roy,
Hello.
please.
If we we come to the Betul belt part, right? What according to you should be the genesis of graphite and vanadium in the Betul belt? Try to understand the geology. Betul belt itself is in the central part of CITZ.
Okay.
And that part, the Padhar ultramafics, and how does an ultramafic is situated inside the central part of CITZ is itself a riddle. And then you have got a very high-grade metamorphism there. And within that high-grade metamorphism, you are getting a huge graphite band and this resource and the vanadium. So what genesis will attribute to Betul belt occurrence of the graphite, according to you?
Okay, fine. Not only Betul belt in a CITZ, very good graphite vanadium is also established in Mahakosal also. That was my doubt initially in Mahakosal also. It is a paper is Patel et al. Current Science it is there 2022. Metamorphics occurring, they are like a isolated patches, Maharkur and your near to Padhar. But Padhar is non-metamorphosed, younger, they are younger intrusive. They from chrome spinels, once I have studied, it will look like a more of Alaskan.
Ultramafic.
Even ultramafic, it has no connection with your, this Betul graphite waste, they are controlled with total structural control shear zone, that is called Sonagati shear zone. One side is a Golihat, other side, I forget his name, I think the mineral award is also here, he was here, he can say, exactly. It is a total shear, it is a metasediment was there, then it has undergone through normal diagenesis process, then metamorphism. But it has not undergone beyond of amphibole phase. That is why I have shown the image. Still amphibole is there, and still other apatite is there, but other high-grade minerals, garnet, it has not formed yet. Had garnet been formed, I would have been, then gold might have formed, accommodated. But vanadium is not there. Up to amphibole it is there. That is the reason why we are getting 5,000 ppm in Betul. We are not getting that neither in Rajasthan or in Odisha.
Very unusual setting.
Thank you, sir. There is another query from Vijay Kumar.
Yeah, Dr. Dora. So, what could be the ideal cutoff grade for vanadium with iron titanium association as well as with graphite uranium association? And what could be the ideal cutoff grade for vanadium, secondary vanadium in laterite?
Very nice question. As for my understanding with literature, the global, worldwide, they are doing 3000 ppm for VTM, vanadiferous titanium magnetite. It is more than, for a graphite hosted, it will little bit more than that because of other factors are involved. As for laterite is concerned, I don't have any data. Because some final is there, as I am the member in threshold committee, yet it has to be published, so I can't reveal that one exact what is there. I know, but I will not tell here.
Thank you so much, Dr. Dora. I think we are running short of time.
As in confidential committee, so I cannot
stop
disclose.
the queries now. You have anything to ask? Please make it short. Please.
Just addition into your information, sir, wonderful presentation. Actually, the Nigalidhar you showed, that is in the southern part of Himalayas. We worked in the northwestern part of Himalayas. I think that deposit, you were talking about the J&K one.
Uri sector.
Yeah,
it is in Uri.
But no, we worked in the Chamba sector actually.
Maybe it is another one.
Yeah, another one, sir. In this seminar only, I have presented it. Another black shale, vanadiferous deposits we have got, and the mineral we have identified in EPA. It's a very preliminary work which we have done till now. It's again the potassium, the vanadium in mica, roselite only.
Phlogopite, any mica is there.
Yes.
It is the preferable is phlogopite.
Yeah.
Roscolite and phlogopite.
Yeah, but the basin is not related to the Nigalidhar one. It's a separate basin. But yeah, neoproterozoic again.
Yeah.
Any intracratic basin it can form.
Dr. Dora, it was really a pleasure listening to you. Thank you
Thank
so
you.
much. And I think he deserves
any question
a
we will
big clap,
discuss
in
there.
fact.
Thank you so much, sir, for that illuminating talk. We will now proceed to the oral presentations of this session. The presenters are requested to adhere to the time limit of 10 minutes of time for their presentation. I now request the chair to kindly take over the session and lead from here.
Thank you so much, Monomita. We have 6 presentations in line. So we'll start with the first presentation, that is role of fluorine and in dissolution and reprecipitation of monazite and apatite in charnocite and cyanide from northern Eastern Ghat belt. The presenters will be Jit Ganguly, and the other authors are Praloy Ganguly and Kaushik Das. Jit Ganguly, please. And for the presenter, the time is 10 minutes. You have to complete within that time, please. That's what is in front of you. And we'll only take queries of maximum 3 because we're running short of time.
Good afternoon, everyone. I am Jit Ganguly from Durgapur Government College, and today I would like to present my work I have done during my master's under the supervision of my professor, Dr. Praloy Ganguly. And the title of the talk is Role of Fluorine in Dissolution and Reprecipitation of Monazite and Apatite in Charnocite and Cyanide from the Northern Eastern Ghats Belt, Insight into the RE mobility at lower to mid crustal level. So, our main objective of the study is to understand the dissolution of monazite and apatite in presence of fluorine saturated fluid phase and its reprecipitation and the associated RE mobility involving the process. So, these are well constrained by different experimental studies and are needed to be matched with natural samples. In order to do that, we have targeted 2 minerals, namely monazite and apatite, monazite from charnocite and apatite from cyanide from the northern eastern Ghats belt. Both rocks are temporally distinct and of magmatic origin. So this is the field location, Fulbani domain of northern eastern Ghats belt, and the sample location of charnocite is from the southern boundary of Rani Pathor shear zone, and the sample location of cyanide is from the southeastern part of Noyagarh town. So the charnocite is essentially well foliated and with a quartzo-feldspatic leucocratic layer, and a garnet biotite bearing melanoclitic layer. And the feldspar are sometimes deformed to form organ shapes. In case of cyanides, the cyanide is intruded inside the older underlying mafic granulite, and it has two parts. One is a mafic layer, another one is essentially felsic, and in that felsic part, large megacrystic apatites are present. The long axis of this apatite is up to 6 centimeters long, and we can easily see these apatites in outcrop scale. And some other minerals like allanite, actinolite, etc. are visible in the close vicinity of the apatite grains in the outcrop scale itself. So now the metamorphic history and mineralogy of Charnokite. As I have told earlier, the rock essentially crystallized during a Charnokite magmatism, and the orthopyroxene, plagioclase, K-feldspar, quartz, monazite, ilmenite and zircon bearing assemblage was formed. You can see the relict hippediomorphic granular texture present, and this is signifying the igneous crystallization. Next, a post-emplacement cooling event happened, and the plagioclase and orthopyroxene contact zones formed a generation of garnet along with quartz, and you can see that on that BSc image in the left side. And as the cooling continued, the orthopyroxene combined with plagioclase and K-feldspar and ilmenite, and a hydration event happened, and the system found biotite and hornblende also, a little bit amount, but the most important thing here will be biotite. And a point I want to make is the fluorine is rich in, the biotite is rich in fluorine, that is up to 1.58% fluorine in its crystal structure. And this will be important later. Now, the biotite again melted during a later prograde metamorphic event, and that biotite created a younger generation of garnet and a granitic melt. You can see the trace of the granitic melt as these melt pseudomorphs, these cuspate shaped quartzofelspathic inclusions inside this younger generation of garnet. Now, the monazite is present in both microdomains, in leucocratic domains as well as melanocratic domains, but they have some differences. The monazite present in the leucocratic domains are essentially unaltered, and show this typical oscillatory zone pattern. But the monazite grains present inside the melanocratic domain are partially to completely altered by a corona-like texture around the older relic monazite by a apatite plus ferrite and a outer allanite rim. And during this replacement event, a thin rim of hatonite was actually formed around the older monazite grain, and you can see that by this brighter BSc patch. And the oscillatory zone domain actually gives us an age of 960 plus minus 11 Ma, and this is the crystallization age of the Charnokite, igneous crystallization, and this hatonite rich domain gives us an age of 938 plus minus 13 MegaNm. That is actually the age obtained from this recrystallized domain, and gives us the age of that M2 reworking event. Now, when we come to the cyanide, you can see in this K-feldspar dominated region, that is a high resolution scanned image of that apatite grains I have told earlier. And if we zoom into that apatite and see the BSc image, you can see a star like formation, like the stars in a dark apatite background, and these are essentially some micropores and some smaller mineral grains forming inside them. These are essentially mainly allanite, epidote, some RE fluorocarbonates, pyrite, thorite and monazite. In this secondary electron image, you can see the micropores clearly visible and the mineral nucleating inside them. So, during this event, monazite was also formed, and from the core domains of these monazite grains, we can get the edge of that hydrothermal replacement, that is that has formed the texture, and this edge is 734 plus minus 28 megaannum. So now I would like to talk about some experimental studies. It is actually said that fluorine generally increase the solubility of monazite and other RE bearing phases by forming stable coordination complexes. And it is also said that the presence of fluorine in the phase, the liquid phase, can also promote effective RE mineral deposition by the in neutralization of fluid acidity. So in this slide, I would try to put the whole thing together. So we had the fluorine-rich biotite formed during that cooling event, and then the later M2 reworking event has caused the dehydration melting of that biotite along with plagioclase and quartz, and this thing actually released aluminium, iron, calcium, silicon, aluminium, as well as fluorine into that granitic melt, and the granitic melt actually attacked the monazite crystal structure, and the monazite structure broken down, the RE got released, and a supply of the other minerals, other elements like aluminium, iron, and silicon, as well as RE, had created the outer allanite rich domain, and the rest thorium and silicon and phosphorus released from the monazite created the apatite domain, and the thorite granules in this, and the outer hydronite rich domain was created during this process by recrystallization. So now we come to the alteration of apatite. So what happened is a post-magmatic hydrothermal fluid of aqueous carbonic composition attacked the apatite crystal structure, and this apatite was actually fluorine rich, and it contained up to 3 to 3.58% fluorine in its crystal structure, so that when the aqueous carbonic fluid attacked the fluoroapatite structure, the RE along with some other elements got released, and this created the bitholite component inside the apatite to separate out, and this created a change in molar volume. A lesser molar volume created these micropores, and the free elements then connected with each other and combined with fluorine to create the RE fluoroapatites and other RE bearing phases like allanite, and thus this happened. So fluorine have promoted dissolution and reprecipitation in monazite and apatite in presence of granitic melt and hydrothermal fluid, as we have seen, and by forming RE fluoride complexes with the constituent RE ions, and this resembles the claim of Topper et al., Shea et al., and Zing et al. The fluid complexes have shown limited mobility or grain scale mobility, as we have seen, and deposited near the original phase. So this resembles the claim of Megdisov et al. 2016. Thus, the whole thing promoted RE mobility and associated enrichment in microdomain scale in lower to mid crystal level. This has been my time. Thank you.
Thank you, Jit. Wonderful presentation. Now the session is open for any queries. We'll take a maximum of 3 questions. I think there are no queries. Thank you so much. The next presentation will be Exploring the Natural Hydrogen Potential of India, Insights from Global Analogs. It's by Priyank Jaiswal, Prem Bikinia, and Xavier Vilkais. So I request Priyank Jaiswal to be present here in the podium. I think he's not there, it seems. So we'll go to the next presentation. Decoding the energy potential of Permian coals through pore system and fractal analysis. Presenters will be Madhurima Majumdar and Ashutosh Tripathi. Madhurima Majumdar, I think she's also not there. So we're going to the next, the fourth one, that is delineation of, is Ananya Parthaprati Mukherjee present here in the hall? Yeah, there. So Animesh is there, okay. So the presentation, the title presentation is Delineation of Subsurface Configuration and Associated Thermal Region of the Mahanadi Geothermal Province, Odisha, based on gravity modeling and magnetic spectral analysis. It will be presented by Mr. Animesh Mandala. Please.
Okay, so good afternoon, everybody. So through this topic, basically, I will be trying to give an overview of the findings that we have achieved through gravity magnetic studies over the Mahanadi Geothermal Province, Odisha region. And this is basically a part of the PhD work of my ongoing PhD students, Ananya Mukherjee, and also partly it will cover the like work done by another past PhD student of mine, Dr. Aurobindo Basantarai. So as you know, like geothermal hot springs, like whenever we have geothermal activity in a region, so they are generally manifested by hot springs. And they are mostly like linked with volcanism and also like maybe some technically active regions like plate boundaries, like mostly in a orogenic belt. And so not only this, but there are some reports which also indicate that presence of hot springs in non-orogenic belts where like they have no direct link with the volcanism or any kind of tectonic activities in the recent day. So in India also, we have similar kind of geothermal provinces, like in orogenic and non-orogenic belts, as you can see from the right figure. And one of such non-orogenic belt is Mahanadi Geothermal Province region in Odisha, which is situated in the northern and mostly central part of the EGMB, which you can see in the lower left bottom figure. And as per the present understanding, this region is mostly like at present date is tectonically inactive, and therefore the hot springs which are available over this region, they are basically considered to be non-volcanic in origin, and they are also low enthalpy in nature. So this region, this Eastern Ghat belt, is basically affiliated to ancient intercatonic intercontinental rifting system. It is believed that it has like the Mahanadi Rift Basin and Mahanadi Graben, which is believed to be formed due to the intra-Gondwana land rifting systems. And so in present day, mostly we don't have any tectonic activity over this region, and it is mostly bounded by Mahanadi Fault in the south region. So in the left bottom figure, the southern part of the shaded region is the Mahanadi Fault region, and then in the north it is bounded by Kerajang Fault, and it has also hosted like several hot springs, as you can see in the figure there. So this region also has been reported with abnormally high heat flow values by the previous authors. So the complex geological evolution and presence of clusters of hot springs in a present-day non-active regions, technically inactive regions, makes this case as a very interesting for the detailed subsurface investigation. And beside this region also basically has these regions, the hot springs basically, they are situated in a close proximity of the several cross-cutting shear zones, as well as it has similar kind of rock types, and the hot springs are also affiliated with similar kind of geochemical affiliations and the similar kind of temperature range. So all these similarities and the presence of the hot springs in a present-day inactive regions further strengthen this requirement of further subsurface geophysical studies to basically understand the subsurface configuration of this region, and also the understanding the thermal regime of the EGMB, and thereby understanding the relationship of these findings with the presence of the hot springs, and thereby try to give a comprehensive idea, try to get a comprehensive idea about the geothermal system which is there in this region. So to accomplish this job, we have basically taken different kinds of geophysical survey, like local scale studies, where we have used mostly near surface geophysical techniques to understand the near surface fracture networks over there using ERT, VLF, and all these things. And then we have gone for semi-regional studies surrounding the hot springs regions through close grid gravity magnetic studies mostly. And then we have as you can see in Taptabani Tarabalo region, as well as in Atri Tarabalo region and Taptabani regions, we have covered land gravity surveys. And then through the global gravity magnetic data sets, we have basically tried to understand the regional setting of this whole region as a whole. And now I will be presenting the results of these semi-regional and regional studies which we have conducted over there for better understanding of the overall geothermal system of this region. And through the studies using the land gravity magnetic data sets in Atri Tarabalo regions, we have delineated the regional fault systems as low, and the shear zones as low gravity anomaly zones. You can see in the residual map on the top left part of the screen. And then we have also using gravity modeling, 2D gravity modeling, as well as 3D gravity inverse modeling. We have tried to understand the deeper extent of this faulted region or the shear zones, and we have found that they have deeper connectivities through the gravity modeling. In the middle panel, you can see the 2D gravity modeling and where the one of the fault has been marked. And through the 3D visualizations using the 3D inversion, gravity inversion methods, we have also delineated the low density zones. And so this overall from these studies, we conclude that the hot springs located mostly in the low density zones adjacent to the deep seated fault regions, which are present over there, and they have a deeper connectivity. And then further to similar kind of studies also we have done in the Taptapani hot spring regions. There also we have found high-low gravity patterns, and that has a good, where we have high to low gradient in the gravity map, we found the presence of the hot springs over there. And through the 2D modeling of the joint modeling of the gravity and magnetic, we also found that there is a clear lithological difference, which may be marking the discontinuity in the subsurface and which may be allowing the water to flow through these discontinuous zones. Then for a comprehensive understanding of the whole region, we have used the global gravity magnetic data. Through that also we have found out similar kind of high-low patterns which are correlating with the geological features over there. Like you can see in the this map, gravity anomaly map, we can see clearly the monolith shear zone as a low gravity anomaly zone in the between the two high gravity anomaly regions. And further to get a understanding about the thermal regime of the regions, we have divided the magnetic anomaly map into different blocks, like 37 blocks with 300 by 300 kilometer size with 50% overlap. And using power spectral techniques, we have estimated the core depth using centroid method, which is a commonly used method for such kind of analysis. And then we have also compared the core depth with the Moho depth estimation using 3D gravity inversion in the Fourier domain, using the Parker-Oldenburg 3D gravity inversion scheme or algorithm, you can say. So, so now I'll be presenting that result. So the core depth, when we compare with the Moho depth over the whole region, we have basically found that the most of the regions, if you can see here in the 3D visualizations, the core depth is much shallower than the Moho depth over the whole regions. And that clearly indicates that the crust over these regions is basically thermally affected, and it has also very clear because of the presence of different cross-cutting shear zones over these regions, which are already reported by different geologists who have worked over this region. And mostly because of this, we can say that in this region, the water is percolating through these kind of fracture networks, and they are going deeper and getting heated. And it is basically the structural features are basically giving the pathway for percolation of the groundwater, and thereby giving rise to the hot springs on the surface. And further to analyze whether they are really the weather, we have to consider both as a, when you want to understand about the heat source of these regions, then we have to basically look into the possible sources over there, and we have compared the heat flow calculations through CPD values, which we have estimated from there. We have calculated the heat flow values. When we calculate these, at that time we are basically considering that crust is devoid of any radioactive nuclei. Even then also we are getting high heat flow values over this region. And then when we are, by the data from the previous literatures, we have did some lithological analysis, and from there we tried to find out the concentration of the radioactive nuclei like thorium, potassium, and the uranium over this region. And based on their concentration, using the popularly used formulas, we have calculated the surface heat flow, and that also coming to be higher than the global continental average, stable continental average values. So that clearly indicates that the heat flow due to the radiogenic sources, as well as the heat flow is coming from the deeper part. So these are importantly, both are important, and they have to be considered jointly. We cannot treat them separately. And further, we have to understand whether these are coming from the deeper source or not. We have did some analysis. So because this region is mostly tectonically inactive now, we can consider that this region is geothermally in an equilibrium state. So following the equilibrium state equations of the geotherms, we have tried to understand using different crustal heat sources, as well as concentration, as well as basal heat flow values. We tried to understand where the 60-degree geotherms will be lying. 60 degrees is the mostly surface temperature of the waters which we found in these regions. And we found that it will be always greater than 1.5 kilometer or some deeper. So these clearly indicate that the geothermal sources are deeper here. Deeper in the sense it's more than 1.5 kilometer deep. And so therefore, there is definitely the structural features which we have identified. They have a definite role in percolations of the groundwater, and thereby giving rise to the hot springs over these regions. So we cannot ignore them. So based on these studies, so basically we have, as we have already, I have already mentioned. So basically, through these studies, we have developed an understanding of the overall geothermal regime of this region, and thereby what are the possible sources of this region and how they are contributing. And mostly, we have found that heat sources from the basal heat flow due to the deeper like magmatic emplacement, or as well as the radiogenic heat sources, both are contributing significantly in the towards the geothermal activities of this region. With this, I will thank you. So I'll be happy to take any questions.
Thank you so much. Any queries? Thoda mic.
Very good presentation. Though you have done the geothermal study from using geophysics as a tool in eastern part of the India, have you studied anything, any geothermal field of central India and Himalayan belt like Puga and Arunachal Pradesh geotherms?
I have personally not worked on that geological domain, but Puga is already like several geophysical studies are available, and it is well understood now, I think. And drilling work has already started there. So
what are the similarity and dissimilarity where we stand?
So these are in orogenic belt, and the study area, it is in non-orogenic belts, mostly like tectonically inactive regions. So they are low enthalpy, and the temperature range is very like around 60 degrees. So maximum temperature is 60 degrees. So in Puga it is much higher. So geothermal activities are much dominant over there, and they are mostly due to because it is situated in a different geological domain. Like it is in an orogenic belt, there are activities and like it's different.
Then what about Gaya belt in Bihar?
Sorry?
Gaya.
Gaya belt means I mean to say Sonata belt, or like the...
Yes, that is the extension of CIT Jod within...
Yeah, they are also like the Taptapani is the most prominent one, which is in the Chhattisgarh one, and they are also high enthalpy, like comparatively like moderate to high enthalpy, we can say.
Okay, thank you.
So further details, if you want, you can go through these papers which we have published. Thank you.
Great. Thank you so much. There are no more queries, so we'll go for the next.
Okay, thank you.
Thank you, Dr. Animesh whether Kritibas Das is here in the... Yeah, Kritibas. So the next presentation will be petrographic and spectroscopic characterization of lower Gondwana and tertiary coals of India for generation of synthetic oil. Presenter will be Kritibas Das. Please.
Good afternoon, everybody. Myself, Kritibas Das. I am from the GSI, Kolkata. So my topic of discussion is the petrographic and spectroscopic characterization of the Indian coal for generation of the synthetic oil. This is actually outcome of a 2-year project we did with the Pandit Dindewal Petroleum University. So coal has a very diverse industrial application. We can see the coal is used in the, largely used in the thermal power plants and the steel industries, those coals which have the coking propensity. So those coals, those use are mainly the conventional use of coal. So now, if we see the unconventional use of the coal, we can see we can use it as a CBM production, that is the coal-based methane production, and the coal liquefaction also. So my this work is focused on the coal liquefaction, and my aim is to find out the best quality of coal so that we can go for the coal liquefaction studies. So before diving into the main topic, let's see the chemical framework of the coal. Coal has a very complex micromolecular network. It is composed of the polyaromatic and the polyaliphatic clusters, and those structures are attached with the different kind of functional groups, and all the things are attached with each other by the covalent and the non-covalent bonds. So our work starts with the sample collection. We collected sample from all the tertiary and the Gondwana coal fields of India, including the lignite coal fields. So the red stars are showing the sample location points. This is the roadmap or the flow charts we followed in this study. So after sample collection, we did the detailed systematic petrographic study. And after this petrographic study, we did the assessment of the hydrocarbon generation potential by rock-eval pyrolysis and the FTL studies. And we narrowed out to a group of samples from a large group number of samples. And after that, we used the solvent extraction process using the different polar components. And those extracted solvents are used by the different spectroscopic study, including the GCMS also. So from the next slides, I'll go through the details of these studies. So petrographically, coal has mainly the 3 building blocks. Those are mainly called the vitrinite, liptinite, and inertinite, in which those three minerals have the different macromolecular structures also. And among them, the liptinite has the much more the hydrogen saturation respect to the others. And vitrinite has moderate saturation, whereas the inertinite, they are the inert part, and they never takes part in the reaction. Only the reactive substance are the vitrinite and liptinite. That's why a suitable coal for the coal liquefaction, that coal should have at least 60% of liptinite plus vitrinite. Not only that, the coal should have a optimum maturation level. In coal, the vitrinite reflectance study actually defines the coal maturation. For a suitable coal which generates the oil, should have the vitrinite range from the 0.6 to 1 or 0.8. So this is the zone, the oil zone, and a coal should have that maturation. And beyond that, coal start to generate the gas. For those coals, those will not be suitable for those coals which are the much more mature. These will be used for the gas generation, not for the oil generation. So this kind of characterization we can make from the petrographic studies, and we can narrow down a large number of samples to the small number of samples. So we make a small inventory from all the studied sample, and we find the coal from the Rajmahal Birbhum, coal from the Talchi coal fields, and the coal from the Godavari coal fields, and the coal from the Makum and the Meghalaya coal fields. Actually, the northeast coals are suitable for the coal liquefaction. That is based on the petrographic studies only. So these are the key features of the few microphotographs, key microphotographs of the suitable coal. So that coal should have the rich vitrinite contents, and if it is better if we get the solid bitumens. Actually, the solid bitumens, those are the petroleum surface which are preserved in the coal as a solid state. And it is better if we get the parhydrous vitrinites. Parhydrous vitrinites are is a natural hydrogen-rich vitrinites. And it shows some fluorescence also in the UV spectrometer. So these are the microphotographs of the liptinite-rich coal. So these are the main contributor for the oil generation, because these are the liptinite-rich parts of the coal, and these are the hydrogen saturated. So all those things are extracted as a coal precursor during coal liquefactions. Now, after mesoral studies or the modal studies, we can classify or define the depositional setup of those coals. And it is better if we get the coal is deposited under a marine setup, because the marine setup brings the more liptinite-rich parts in the coals. So for those type of study, we need the provenance studies of the coal also. So after characterization coal by petrographic study, we need to assess the coal differently. So first of all, we applied the Rockybell pyrolysis study to assess the hydrocarbon generation potentiality. The Rockybell pyrolysis actually decomposes the organic matters at elevated temperature at inert condition, and it generates mainly the three diagrams or three peaks. I can call it as a S1, S2, and S3. S1 is generated at a temperature range of 0 to 300 degree, and it produces the free hydrocarbons, whereas the S2 is generated at a temperature range from 300 to 500 degree temperature, and most of the pyrolysate or the heavier organic matters are cracked down at this place. And S1 and S2 combinedly tell you how much petroleum kind of things or petroleum extract you can derive from the coal. Not only that, using this S1, S2, and S3, we can further assess, or we can generate some of the few indices called the hydrogen indices or oxygen indices, and those indices are mainly used to define the corrosion types. In nature, there are 4 types of corrosion: type 1, type 2, type 3, and type 4. Among those 4 types, type 1 and type 2 are preferably used for the coal generation, whereas the type 3 and the type 4 are used for the gas generation. So we need to find out which of the coals which they have the corrosion types on that is the corrosion types of type 1 and type 2. Not only that, that corrosion has to have some the maturation level also. If the maturation level lies in the oil indigenous, the pointer is not using, so I can show you. If the sample is falling in the oil indigenous, so those samples will be used for the further studies. So from this study, we need to identify the type 1 and type 2 corrosion and those coals which are falling in the oil indigenous also. So I already told you that coal is a very complex structure. It has a very large aliphatics and the aromatics portions. On those aliphatics and aromatic portions are attached with the number of functional groups. So what are the functional groups? We need to identify using some special kind of tools, and from these studies we applied the FTR studies. In this graph we had used the Rajmahal coal, in which the type A zone is showing you that the aliphatic zone, and B zone is showing you the aromatic zone. In this aliphatic zone also you can find the numerous peaks, and the B zone also you can find the numerous. Those peaks are showing you with a different kind of functional group attached with them. So we can find out the different peaks from this graph, and we can compare it with the established library, and we can identify what are the functional groups present with those coals. Not only that, we can assess the corrosion type also from this study after deriving the A factor and the C factors. So after narrowing down the large number of samples by detailed petrographic studies, rocky wall pyrolysis study, and the FTR studies, we'll go for the solvent extraction part. This is the main part. So solvent can be extracted in the two ways, that is called the indirect way or the direct methods. In indirect methods, coal are first converted to the sheen gas, then the petroleum-like substance are collected using the different catalyst. Whereas in the direct methods, coal are crushed and they are mixed with the different kind of solvents, and petroleum kind of things are extracted from these things. So in that case, you may require some kind of hydro treating if your solvent is the hydrogen undersaturated. In our present study, we use the direct method, but in a different way. We use the five kinds of the solvents. Those are namely the N-heptane, toluene, dichloromethane, and chloroform, and the mixture of the benzene, methanol, and the N-hexane. That is called the BMH. So as the coal has a very diverse group of chemical frameworks, and they have the different polarity. So that's why we have used the different polar substance so that we can extract all the polar components from that coal. This actually the photographs of in the laboratories, how we prepare our samples and how we extract our samples, how did we extract the solvents, and how we from the different spectroscopic analysis. So after extraction of the solvents, we did some analysis. We actually performed it a different way. Like we use a single solvent extraction for the different rank coal, and likewise, and unlike we use the different solvent for a single coal. The main funda is that, so if we use a different solvent for the different rank coal, we can find a diverse range of the solvent extraction. Just like the figure on the right corner, you can see we only use the single solvent, that is the chloroform, and we find a different extraction yield from the lignite, bituminous, and the anthracite. Likewise, we use a different solvent for a single coal. So likewise, we examine, so what is the base solvents, what are the base solvents, and how much yields that solvent can produce from the different range of coal. So because all the coals have the different ranks and they have the different macromolecular studies, they have the different proportion of the macedals. So that's why we make the permutation and combination to know how much extraction yield we can get from the different kind of study.
Kritibhash, please conclude. Your time is almost over.
Yes.
Right? Please.
So we can make a small inventory of the different chemistry we get after using the different solvents. Now, the spectroscopy will tell you is a broad structure of the aliphatics or aromatics. To know the detailed molecular framework or to know the each and every components, we need to apply the different kind of study that is called the gas chromatography. Gas chromatography actually tell you what are the specific chemical structure or the chemical proportion is there in your different kind of coal, and we can use some of the chemical structure as a biomarker, called as a biomarker, that is a chemical fossils. So from that biomarker study also we can define what are the paleodepositional environment and the source rock. So this will give you some leads for these studies also. So this is a conclusion. So if we have studied all the coal samples, collected coal samples, and from that collected coal sample we get the coal from the Makum coal fields, coal from the megalite tertiary coal fields, and the coal seams of the Rajmahal, seam 2 of the Rajmahal coal fields, and the seam 1 of the Talchir coalfields and the king seam from the Godavari coalfields are best suited for the coal conversion from the Indian perspective. Thank you.
Thank you, Krittiba. So I think the session is open for discussion. Any queries?
No questions?
I think there's a query from the chair.
Hello.
What are the applications of this synthetic oil that has been generated from the tertiary coal or the lower Gondwana coal?
As an example, sir, I'm showing you the picture. This is actually coal oil. You can see the calorific value of the coal. It is around the 10,000. Now the available petroleum and diesel we used in our vehicle fuel, those have the very less calorific value. So those liquids are very efficient because it contains a very shorter hydrocarbon chains which burn efficiently. And this is a kind of use, this is one kind of use we can use our Indian coal as a cleaner way, because all the using of the coal in the thermal power plants, these are all the pollutings. So these are the alternative use of the coal. Not only that, we can use some of the coals for the gas generation also from the CBM if their maturation lies in the gas fields. So that's how.
Among this coal, bitumen, or the lignite, so which one is best for that generation of this synthetic oil?
From our studies, we find the coal from the northeast coals, actually from the coals from the Meghalaya and the coals from the Makum coal fields, they are best for, because those coals are parhydrous bitumenite. This coal very rich in the parhydrous bitumenite. Their minerals contents is more than 95% is there, and all the minerals are hydrogen rich. So it's a God-gifted minerals which have the much more the natural hydrogens. So, and the maturation range also falls in the oil window zone. So we can easily get the synthetic oil from those coals.
Lignite is having less potential, right?
Lignite can generate the petroleum kind of substance, but it produces the very large group of aromatics. That structure is so complex. So those coal tars, those liquids can be used as a coal tar for construction of the roads and those things. You know that the tar those things. So tar can be extracted from the lignites, not from this type of synthetic oil, which are much more the calorific value.
Krittibash, just one simple question. What is the amount of oil which you can get from 1 ton of coal?
1 ton of coal, sir, if we use, it actually depends, sir. If we use the best quality of coal, that is, for our study, we find the northeast coal is the best coal. So we can get 40 liters of the synthetic oil from 1 ton of coal.
Thank you.
Hello. Sir, I just want to know whether this type of study has been carried out in Satpura Gondwana Basin, where Tawa, Kanhan and Pench Valley coalfields are there. Have you carried out such studies?
Madam, we studied, but the maturation level is much higher. So those coal can be used for the gas generation, not for the oil generations.
Thank you.
Krittibash, I have a small query. This is from me. Yeah, because we are trying to go away from the coal, in fact. We are going for green energy transitions. So ultimately, when you produce oil from coal, your pyrolysis is there, which means a lot of gas will be extracted definitely. So we have done this on a lab basis. On a commercial basis, it will again have a lot of pollutions. So what is your take on that?
It's a very good question, sir. Actually, now the CTL study, the coal to liquid study, India, we don't have the very large industry. There is only one commercial production in the world now is going on, that is the Sasol in South Africa. So they are commercially producing the synthetic oil from their coals. In India, we have started this study. Simfar Dhanbad, they have established the mini plants there, and they are applying that indirect method for the generation of the synthetic oil. But those coal they have used, those are from the Raniganj coal. So those coal are not suitable for extraction of the liquids because the maturation level is so high. So those coal can be used for the coal-based methane on those study or steel industry, not for the synthetical productions.
Thank you so much. We'll be going for the last presentation of today's. Please applaud him. It's a wonderful presentation. And the last presentation is by S.M. Joshi and P.S. Shekhawat. Are they there? I don't think. Gujarat Ambaji Copper Deposit. So I think we can conclude the session. I don't think the
Sir, the next speaker is not available as it seems. So I'd request you to conclude the session with
so
your
much.
feedbacks and remarks.
Sure. Thank you so much. And I was very excited to chair this session, in fact, because we had a bouquet of presentations. It was, we had a icing on the cake with a presentation from Professor Emil Dora from JNU. And I was looking forward for all the 6 presentations, in fact, because we're discussing on the sustaining our planet, critical minerals and energy and mineral resources. So there are, I think, only 3 presentations out of 6 were made today. And we have missed out on the presentations of natural hydrogen. Then there was another one from potential from Permian coals. And lastly, Gujarat coppers. So to start with the presentation, the special keynote address by Professor Emil Dora was, as usual, it was an outstanding presentation. It was going back to the classroom in a way, and where he has shown all his, balanced his presentation both with his findings, his research, and with the basic information. And the most important thing, as we know that for vanadium, India is a huge consumer of vanadium, but we don't only produce from the byproducts of the steel and iron ore industry. And what we came to know that the importance of vanadium is now increasing day by day, since it is being utilized for the battery, that is the vanadium redox battery. So he has taken us along a journey of the presence of the vanadium and how it migrates from with oxidation and with reduction, how it changes the different valence states, the importance of vanadium in assessing and also the importance of for the mineral system study, how mineral system study is extremely important for assessment of vanadium in different geological domains, in fact. So from Indian perspective, as he has pointed out, we have seen that there's a huge potentiality. It is not only the low potentiality has been given by the Australian study, but I think I totally agree with him that we have a huge potentiality, and with the I think the presence of vanadium reported from the carbonate of Arunachal is a groundbreaking work, in fact. And there are reports of vanadium from the graphites of Rajasthan, and these are the things which need to be taken forward. I think another important observation he made was that the snowball garnet and global vanadium metallurgy, and in which I think he has given us a hint for studying in the different sedimentary basins also. And another highlight of the talk was that we can look forward for vanadium, as we know that it's a element which can replace iron, and it is occur in different in micas and different in laterites also. So we look forward for getting more vanadiferous prospectivity in the Deccan basalts, also in the laterites developed over it. So it was followed by the presentation of the role of fluorine in dissolution and reprecipitation of monazite and apatite. It was again a wonderful presentation by Jit Ganguly and his team. So we all we had a little idea about the mobility of RE minerals in the presence of in fluorine ecosystem. So he had presented, and he has wonderfully matched the experimental studies with his own observations. So I think it's really an appreciable one, and also from a student of I think Durgapur College, it was really appreciable. A nice presentation. And I think he has also stated that given a kind of an age for the replacement of hydrothermal replacement of RE apatite by the RE fluorapatites. Wonderful work. Now the next presentation was also a very interesting one. It was made by Dr. Animesh Mandal on the delineation and subsurface configuration and associated thermal regime of the Mahanadi geothermal province, Orissa. So in the presentation, we have seen that the inactive tectonic belts, that is the non-orogenic, so-called non-orogenic geothermal provinces of Orissa has been taken into consideration, and how wonderfully he has correlated his observations with using the geophysical data, mainly the gravity and the magnetic data, in delineating the shear zones and the faults, and in which, and he could give an assessment of the depth of the heat sources also. So it was again a very interesting talk. And he had also made a point out of it that the Kuridip derived from was around 25 to 30 kilometers, which is much shallower than the Moho surface depth. So the average, and he also made an assessment on the average surface heat flow. Again, it was a learning process for all of us. It was a wonderful presentation. And the last presentation by the Kritibas on the petrographic and spectroscopic characterization of lower Gondwana and tertiary coals. I think it definitely has a lot of promise, as Kritibas has presented very well. And I'm not exactly sure how much pollution we're going to make to the system again, going back to the coal for the oils, but it's definitely on the experimental basis. And I think, as he said, that there's only one commercially producing plant salmon in South Africa. So we need to look into that, but continue with the research as they are doing. So with this, I conclude my remarks, and I congratulate every presenters here. It was a wonderful session for me, and I think everyone from the audience also had a great time. Thank you. I'll request my co-chair to make a comment, please.
Very good afternoon to everyone. So today it's a wonderful session to co-chair this Sustaining Our Planet, Critical Minerals, Energy and Mineral Resources. So during this, the special paper or the keynote speaker, Dr. Emal Dora, briefed about the significance of vanadium as a critical mineral throughout the world, and he told his importance in how he has selected for the vanadium commodity. And regarding he also briefed about the global vanadium deposits, followed by his genesis, and in which the vanadium can occur in diverse rock types. And also he highlighted the formation of the iron titanium vanadium system, as well as the vanadium graphite uranium association with the source, citing examples of the source, driver, fluid pathway and the depositional sites. Also he highlighted the significance regarding the secondary vanadium, where to look for, that is in the laterite over the mafic rocks rather than in the ultramafic rocks. So it was a wonderful lecture, Dr. Dora, and your insights on the vanadium is very much helpful to further our exploration activities. The other technical sessions by Mr. Jeet Ganguly, then by Animesh and by Kitibadas. So all are really fantastic, and it has given new ideas and new insights about the critical minerals as well as the energy and mineral resources. Thank you.
Thank you, sir. We extend our sincere gratitude to the chair, co-chair, rapporteur, and all our dedicated speakers for their significant contributions to this session. May I now request the Director General Geological Survey of India, Shri Ashit Shah sir, to kindly come up to the stage and felicitate our session chairs for their valued presence.
Have you chaired in the earlier sessions? Huh? How many of you
Thank you, sir.
is involved, and we're looking for some way to explore for more mineralisation in this area. So,
and very soon we'll also start serving high tea at the convention hall. The fifth and the last technical session on the theme, Geological Insights for a Thriving Earth, the Critical Zone, will commence in the auditorium at 5 p.m. Those who are interested may kindly join us for that session at 5 p.m. Technical session on other themes will also be conducted simultaneously in Mini Auditorium 1, Mini Auditorium 2, and the conference hall. Thank you, and we look forward to your continued participation in the conference.
ठीक है फिर ठीक चाय बिस्किट होगी वो अदर मेरे को भी नहीं वही होगा चाय बिस्किट मेरे को तो बताया नहीं है तो कल कहाँ जाना तो बता दो टेंशन मैं नहीं लेता टेंशन तू ही पालेगा लास्ट में बात जा रही है पीछे लेते हैं उसको आगे लेते जब पूरा आता है मैं बोलता हूँ लेकिन इसके सहारे लेना कुछ रुपया तो मांगे आदमी ये सहारे इसके लिए लिया इसको अड़ नहीं रहा है अड़ नहीं रहा कैसे नहीं ऊपर से अड़ रहा है ना पूरा देख ऊपर देख टाइप बोल रहा है ना पूरा और इसी में हवा आएगी सीधी साइड इसके ये ना देख पेट्रोल बैग वाला ये बांध गया तो शायद पानी में जाने का है हाँ ये माइनिंग खुदाई का है कुछ है उसी टॉफी किसके बाउल में पड़ी दिख गई यार कैमरा इधर जो हमारा बहुत है बस 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 उस साइड चलेंगे
लंबा शॉट आएगा ना इसलिए।
Okay. So it will just catch up. Starting career. डेमो सर बस सर चलना है सर डेटा आ रहा है पहले प्लीज नीचे नीचे और थोड़ी देर तो मेरे हाथ में चाहिए
साथ में हो जाए, साथ में हो जाए।
एक मिनट फोटो खिंचा लो, आ जाओ। आओ सर, आइए सर।
अंदर की तरफ हो जाओ भैया।
आप भी दे रहे हो अंदर ही आ जाओ। ले भाई एक लास्ट दूसरा दिख रहा है, फोटो खिंचा लो।
आ जाओ सब लोग, आ जाओ, ये तो लाइव है वैसे भी।
आइए नहीं हम जा रहे हैं ना इसलिए अभी आ जाओ सर। आइए आइए
आ जाओ आ जाओ आ जाओ, पीछे छुपना मत। सब भैया थोड़ा सा और हो जाए,
इससे भी खींच देना बात।
थोड़ा और शिफ्ट हो जाओ।
और ये फोटो के नीचे लिखना है टीम जियो सिंह।
ये तो लाइव है, ये तो लाइव है।
डायरेक्टर बीच में ही है वैसे। हाँ यस। It will be like this, no? It's like I'm running. I tell you what. This is your upstate. That lunch dinner happens?
चल दी।
मेरे क्या है, हमारे साले की शादी है कल, वहाँ जाना है।
We'll move ahead with our first keynote lecture. The talk will be delivered by our keynote speaker, Professor Abhijit Mukherjee of IIT Kharagpur. Professor Mukherjee is a professor in the Department of Geology and Geophysics and the School of Environmental Science and Engineering at Indian Institute of Technology, Kharagpur, specializing in hydrogeology and groundwater sustainability. He is a leading authority on groundwater contamination, isotope hydrogeology, and water resource management. Professor Mukherjee is the first hydrogeologist to receive the prestigious Shanti Swarup Bhatnagar Prize in 2020 in Earth Sciences and has been recognized as a Fellow of the Royal Society of Chemistry, the Geological Society of America, and the American Geophysical Union. He has authored numerous high-impact publications, including the book Global Groundwater: Source, Scarcity, Sustainability, Security, Solutions, and his research has attracted extensive citations worldwide. In addition to his academic contribution, he has led several national and international collaborations and currently serves as the Associate Dean of Research and Development at IIT Kharagpur. Today, Professor Mukherjee will be speaking on delineating groundwater security of India. Please join me in extending a warm welcome to Professor Mukherjee.
Hello. Okay, it's okay. Thank you so much. A very good afternoon to all of you, and I'm happy that you could make to the last session, which is always the most difficult for a presentation. And I know, like, I'm just standing between you and the end of the conference. So I'll talk about the technical stuff, but possibly I'd like to tell you a story. Okay, the story of groundwater security of India. Can these lights be switched off? It's This slide? That's it, sure. Don't worry. Okay. So before I start, I would like to acknowledge my collaborators over the years. Instead of going, like by each agencies or organizations, I have listed few of the organizations whose work, with whom I have collaborated over the years, and whose work I'll be kind of representing through this presentation. Now, I'm very happy to tell that in addition to this, we have just started to work with GSI also. So we just signed a MOU, and our first paper with GSI has just been published 3 days back on critical minerals through the high Himalayas. So next time I'll also have the GSI logo in this slide. So groundwater. Now I understand that groundwater is not something that most of the geologists would be interested in, but as you can imagine, this is the life. And when we talk about groundwater, the general notion is that it is one of the most recent of the geoscience topics, and we have been learning about groundwater only in the last 30 to 50 years. But the reality is that groundwater has been known, or the science of groundwater has been known from possibly the cradle of human life. As you can see, the first image that you see on the slide, it is from the Jorbangla temple of Bishnupur area of Bengal, which depicts the 13th day of the Kurukshetra war, the battle of Kurukshetra between the Mahabharata, between the Kauravas and the Pandavas. And here lies, here lies Bhishma, the great-grand-uncle, on the arrow bed. And what you see is Arjun piercing the ground to give out water. Now this is something that we all know. But the matter of fact is what Arjun is doing is drilling the ground to bring out groundwater. So the science, the knowledge of groundwater was existing even at the time of Mahabharata. Now if this is a mythology, legend, I'm not going into that debate, but across the history of India, over the years, since the days of Mohenjo-daro to the present, you would see there are enough evidences that groundwater was something that was used by our ancient forefathers. So Mohenjo-daro, as you would see, it has been identified to have more than 800 groundwater wells, and that's why it's called the city of wells. And then across the history of India, you would see evidences where groundwater has been used. But then if that is history, and we kind of fast forward it to the present day India, you would look at groundwater, we all know, is used for drinking purposes. But the reality is that much of the groundwater is also used for agricultural purposes, food production. It's used for industrial purposes. It's used for urban development, and whatnot. So in a sense, 85% of the water, specifically groundwater, is actually used for food production. The notion that groundwater is important for our drinking purpose and so on is actually misunderstood. It is actually the food where most of your groundwater would go. So as in Bengal, we say that we eat water. It's not actually absolutely incorrect. So we actually eat water, right? Through the food, of course. And if you look at the other numbers, you would see that only 6.6%, and again, these numbers are a little old, so possibly even less, are actually used for drinking water and other domestic purposes. So it's a food production that actually controls the groundwater usage. So much so that if you look at the economics value of this resource, it's a geologic resource. Groundwater contributes directly 9% of the GDP of the country, directly. And if you take the indirect food production and other sources, these amounts to more than 35% of the GDP of India as of the day. Now, to understand groundwater, we also need to understand the issues. And the first issue, which we all know, is the scarcity. Being in Rajasthan, that is very prominent. And every summer, we would see people kind of thronging on the wells, trying to get their water sources for their drinking purposes, their agricultural purposes. But during the same time, in other parts of the nation, you might see there are water flooding. Like there are floods that are affecting people to live in. And again, the common notion is that floods are mostly caused by meteorological events, hydrometeorological events. Well, that's the truth, but it's also a fact that groundwater actually triggers the flood. There is a combined process between the surface water and the groundwater that actually relates to the flood. So when flood happens, it's also a reflection of how your groundwater dynamics is happening. So you have water scarcity, you have water excess, but at the end of the day, what we are concerned about is the drinking water directly. And whether scarcity or excess, drinking water security is something that is of paramount importance. We all want to secure our groundwater sources so that we have sufficient drinking water for the present times as well as our future times. And then comes something that we all know, contamination. And contamination is something that has direct impact on our health, groundwater contamination. Many a times they are geogenic, many a times they are human sourced. Now, these pictures that you're looking at, I did not take it from Google. I took it myself, like I photographed myself of the people of West Bengal, where people are just drinking bad water, bad drinking water, sourced to groundwater, pollution by arsenic, just 200 kilometers from Kolkata. And these people have not done anything else other than that they're dependent on their shallow drinking water well to have their, shallow groundwater well to have their drinking water. So if you look at all this, it looks like water is an issue, but it's also a management issue. Because while in some areas you have scarcity, just few hundred kilometers away you have scarcity, excess, telling you that there is a bottleneck that you need to understand. Same way, if you have pollution and then you have areas where there is water that's flowing out without any boundary, then that's also a management issue. And then comes the white elephant, the white elephant in the room, the climate change. Now I know there are thousands of literature that have come out of climate change in recent past. Now, very honestly speaking, I'm not a climate change scientist myself. Of course, I work in parallel domains. I would not say that I understand climate change, and I doubt anybody does. Okay? So we honestly don't know what climate change exactly is going to happen and how it's going to impact and so on. So we always have an arm waving of that. Some of the top bosses of the world now are saying that climate change is a hoax, as you all know. So we're still debating on that. But one thing we are sure, that if climate change is happening, would be happening, one of the first victims of climate change would be the hydrological cycle vis-a-vis the groundwater. And this is more true as we move to 2030. As you know, the year 2030 is a year of Sustainable Development Goals. And if you look at the goals, the 17 goals, you would see that goal number 6 is specifically introduced for clean water and sanitation. And when I talk about clean water, 80% of the clean water of the planet actually is sourced to groundwater. But indirectly, all the other 16 goals are somewhere or other linked to groundwater. So understanding the importance of groundwater in the global politics, the global socioeconomy, is extremely important. Now, why we are talking about all this? Well, one is the science part, but then there's society. Now, in the last about 16 years, since 2009, there has been a lot of hue and cry of the water scenario, the groundwater scenario of India. Now, before that, was that the people didn't know? They knew, but it was not that prominent. It was only in 2009 when 2 seminal papers came out, which kind of demonstrated that on a regional scale, that groundwater of India is depleting, and depleting in such a level that people are saying that there is a subsurface drought that is happening. So in the last, give and take 15 years, since I've been working at my present place, with my students and scholars, I've been working on a very simple question. The simple question is, how much groundwater, safe groundwater is available in South Asia, and what is the future? It's a very simple question. Can't have a more simpler question. But then I would like to use the word safe, with a highlight, saying that just the volume of groundwater is not sufficient. We also need to understand the quality of the water. So let's look at that. And in the global literature, it's said that the South Asian groundwater is an emergency. It's a planetary emergency. Why? Well, the statistics is very simple. The Indian subcontinent has about 3% of the global terrestrial landmass, just 3%. We host about 23% of the global population and about 33% of the global irrigated land. Telling you, 1/4 of the global population and 1/3 of the irrigation food production is actually from South Asia. Now, in no sane mind, you can say that 3% of the global terrestrial land can host this much population and food. Consecutively, sorry, the South Asian region, specifically India, is the largest consumer of groundwater in this planet. These statistics from my good friend Richard Taylor in 2014, it shows the 6 largest groundwater using countries of the world with prediction to 2099. What you're looking at, you know, like India, of course, standing tall, followed by China and US. The interesting part is that if you add China and USA, India still stops. So India, you know, in terms of the groundwater usage, is the largest consumer of groundwater in this planet, not just today, but also historically. And is it the whole of India? No. So if you look at this map, and the colors that you look at on the left, you know, there are this red and the scarlet color, 200 to 400 and greater than 400, which is the millimeter per hectare of irrigation. You see that there is one prominent place in this planet where so much irrigation is happening, groundwater irrigation is happening. And although there are some sporadic points here and there, the place where you have this maximum irrigation is the North Indian plains, also known as the Indus, Ganges, Brahmaputra, Meghna basin, right? The 3 mega rivers of the Himalayas and Meghna, they compositely form the IGBM, the largest groundwater aquifer system in the planet, okay? And the most stressed groundwater system of this planet. So this IGBM, as you know, also has the densest human population of this planet. So it makes a very interesting story. So it's not just a geological resource problem, it's also a human problem. It's a human tragedy in the process. So in present day, India is the largest user of groundwater, not just today, in the human history. No time in the past, in the 5,000 years of recorded history of this planet, any other nation has used as much groundwater as a geological resource that we are taking out of the subsurface. Now, to do this, to understand this distribution, we need to understand the geology, the hydrogeology. So on the left, I'm showing you the South Asian map, a simplified South Asian map, aquifers map, sorry. And on the right, the groundwater quality. So what you're looking at of this map, it's kind of simplified. If you look at a CGWB map, it's possibly 1,000 times more complicated. So it's very simplified. But it kind of gives you the broad picture. What you're looking at, 2 bright blue colors. The blue color on the top and the deep blue color on the bottom. The first blue color, the Indus, Ganges, Brahmaputra and Meghna basin, also known as the Himalayan foreland basins. This blue is made of soft sediments, alluvials. Alluvials to thickness ranging from 100 meters to few tens of kilometers. So in Bangladesh, they have been recording to 22 kilometers of thick sediments. So this is one of the thickest aquifer system of the planet, hosting almost 21% of India's landmass and 70% of the groundwater resource of the country. Whereas the deep blue color, the cratonic aquifers of India, they have about 30% of the groundwater resource and about 65% of the land coverage. So you can see that it is a very bipolar distribution. Consequently, there is no wonder that the IGBM has the highest density of human population in the nation as well as in the planet. The interesting part is on the right. You would see that these aquifers, among these aquifers, while this IGBM has a lot of groundwater, they're also a lot polluted. Something we already know is arsenic, and there is also fluoride on the edge of these aquifers. Some places also have the salinity problems. So although there is a lot of groundwater in the IGBM, the net groundwater that is available for human usage is kind of limited. Now this is an indicative map, and I'll show you a map with more data in a minute. I'll skip this because we are kind of running out of time. So this is the recharge that we calculated across India for last 20 years from 1996 to 2014. And what you're looking at is the distribution of recharge across India. Now you would see by and large there is a similarity that you have this Indus Ganges Brahmaputra basin having higher recharge, whereas the red areas are more in the south with a lower recharge. And by and large the pattern is similar, although there are interannual variabilities. So these interannual variability are possibly more linked with the climatic patterns than the geology. But the larger picture is definitely controlled by the geology or the hydrogeology. And then the human. We all know about the arsenic problem, at least in this community. And we know that it's geogenic. By now it has been reasonably established that it comes from geological sources. But what we also have realized over the years, that as much this problem is geologic, human intervention has actually made it worse. So while arsenic problem was initially a bit limited, because of human pumping and overusage and lack of planning, actually spread out into places where it was not there before. So the human intervention now playing with the natural system can make things really top of the edge. So what I'm showing you is the first map of groundwater arsenic across this country based on data. Previous to this, every map was kind of indicative or tentative, but this map is based on the Jal Jeevan mission, 2.7 million data points that the Jal Jeevan mission is monitoring on arsenic data, and we use artificial intelligence and other data science techniques to create this map. Now, as a geologist, what you might be interested in is the disposition, the pattern of the arsenic in the groundwater. It's not everywhere. It's very localized. It's localized in the North Indian plains, that is IGBM, connected to the Himalayas. It is in the CITZ, the Central Indian Tectonic Zone. And it is in the south, in the goldfields. Telling you that geology has a very strong component in influencing the regional distribution of the arsenic in the groundwater. But then it's not just not just geology. Human also has a huge role to control the quality of groundwater. What you're looking at is a study that we did a few years back, trying to understand the presence of emerging contaminants like arsenic, pesticides, PHs, antibiotics in the river and the groundwater of the Ganga basin. And what we found, something that we didn't know that far, that millions of people in the Bengal area of the Ganga basin are actually exposed to these emerging contaminants in their drinking water source both to the Ganga river, Hooghly river, and the groundwater. So, coming to the more technical part of it. So if this was the introduction, this is what we do. Now, as a hydrogeologist, like you possibly have been knowing, hydrogeology is a more modern branches of geoscience. And it's only in the last 40 years plus that hydrogeoscience has really taken its shape. So as a hydrogeoscientist, when we try to do a study, we don't limit ourselves to a technique, and we use whatever we can. And these techniques can stretch from subsurface exploration, deep exploration, earth observation and remote sensing, hydrogeophysics, piezometry, hydrogeochemistry, river pollution studies, hydrology, and last but not the least, integrating all this data into a big data analytics platform and going modern AI techniques to make a sense of this data. So over the years, over the last about 20 years that I've been kind of practicing it in a professional way, we have been using all these techniques to make a sense of what we do. So I'm going to show you a very specific example. And this is about the quantity of groundwater of this country. And this is a study that we have been doing since 2011 in collaboration with NASA. We are the official partner of NASA in this mission. And in 2002, 2 satellites were introduced by NASA in collaboration with the European Space Agencies and the University of Texas at Austin, where I used to work those days. And I kind of picked up those techniques from there. And these 2 satellites, they have been going around the planet Earth, 500 kilometer approx elevation, and in a distance of 220 kilometers, tied by a very thin, high accuracy laser beam. Now these 2 satellites have been going around the planet till 2018, and then the next set of satellites went out. 2026, another set of satellites are going out. This satellite mission was initially sent out for 5 years with a notion that we'll get 5 years data and we'll play with it. But now after 22 years, it's still going on. And so the first satellite, as you can imagine, is Jerry, and the second satellite is Tom. So this Tom and Jerry has been moving around. And what is it doing? The 2 satellites are measuring the Earth's gravity field. They are airborne gravimeters, okay? And these gravimeters are actually measuring the Earth's gravity field in a tile of 400 square kilometer in extremely high resolution. Very high resolution change in the gravity fields. And as you would know, that gravity is not something which is permanent. It changes in space, it changes in time. So if you measure the gravity of one place, you come after 1 hour, the gravity would be changing, okay, continuously. So NASA, this satellite mission, in collaboration with the Jet Propulsion Lab and other agencies, has been measuring these changes of gravity of a specific place on Earth's surface over the years, every day, every month, for these 22 years, resulting into a huge database. Now, why are we interested? Well, we are interested because these gravity data now can be transposed to make it groundwater data, okay? The first time we could sense the regionality, the continental scale distribution of groundwater and its changes. How? Well, the simple logic is that if you have, the Earth's mass, which is kind of constant, so unless, constant in a specific time frame, and unless you have a catastrophic event like a tsunami or a huge landslide or a huge earthquake, the mass is not going to change, 400 square kilometer. So if you are observing a change in that range, the change has to be hydrologic. And that hydrologic is the hydrologic mass exchange, water mass exchange, between the atmosphere to surface water to groundwater and so on. Now, if you have the data for surface water, which is SR, the soil moisture, SM, and the snow melt, which is SN, and you subtract it from what you call the TWS, terrestrial water storage, you get what you call the change in groundwater storage. So it has been a very well-proven technique by now, and NASA has been producing these groundwater storage estimates across all the continents for the last 22 years on a daily basis, okay? So it's an immense data set. And we have been very fortunate to be the group which validated this data set over India. So when we started working with NASA in this study, now I was working with them even before coming to India, but with my group at IIT Kharagpur, we started calibrating this data set with the Indian groundwater scenario. So obviously, I collaborated with the Central Groundwater Board, who was the custodian of the groundwater data of this nation. And with the support of their scientists, we demonstrated that the correlation of groundwater observation from the ground versus from the satellite are in a range of 0.6 to 0.8, which is quite good actually, for most of the places. It did not match in few places, but that's another story. So we did observe that the GRACE mission data is reasonably usable with some limitations to predict the groundwater condition of India. So what I'm showing you is the decadal groundwater storage change over 2003 to 2014. Of course, the data has now been processed to make it more recent. And these are all calibrated by groundwater measurement data from the field by CWB scientists and by our teams. Now, what is interesting to see here are the colors. So the colors ranges from blue to red. Blue is good, red is bad. Blue means more groundwater, red is less groundwater. So either you are having blue, which means excess groundwater, or red means you are having groundwater drought. So let's look at the colors, and you see the colors are changing. So every year the color changes. So every year the color changes, indicating that there are things that are happening which are changing the groundwater storage across India. But there is something consistent. The consistency is that the North Indian plains, the IGBM, where you have the maximum human population, maximum groundwater availability, has become from blue to red. Whereas, interestingly enough, the South Indian region, South and Western Indian region, which was red, actually became blue. Something very abnormal, at least that time when we first observed this. And we thought, no, this is something wrong, something that should not happen. I mean, we must have done something wrong. Now, this first one, the IGBM groundwater depletion, was known for a few years. But this rejuvenation was something absolutely new. So I started looking at what we did. We declustered the whole Indian region into 5 hydroclimatic zones based on the monsoonal precipitation ranges. And then we did few mathematical changes, and we plotted the GRACE data. What you're looking at the trends, and what you look is the north and east, you have groundwater depletion on a linear scale, with east kind of topping the north. So everybody talks about the groundwater depletion in Punjab and Haryana. Actually, the groundwater depletion is happening more strongly in West Bengal, in Bihar, Eastern Bihar, and the Northeast. Again, something that was new. Whereas, the West, Central, and South, you actually have groundwater increase, the storage increase, something that, of course, was not new when these papers were published in 2017. Now, if you ask me, which is a very obvious question, which are the places where you have the maximum groundwater depletion rate that you're observing, you'd be very amazed to hear the answer. It's Assam. It's not Haryana, not Punjab, but Assam. A place where you think there is a lot of groundwater, there is, but it's also depleting at the fastest rate. So after all this, let's show it in a more eloquent way. So we declustered all the data again, and I took out all the blue points and all the red points. So the blue points showing groundwater storage increase, the red points showing decrease. And when you try to look at this, the red one, let's start with the red one. So you look at groundwater drought. So this is groundwater drought that is happening across India. And what are the reasons? Well, very obvious reasons. You have introduction of high-yielding crops since the grain revolution, more specifically from 1990s. And these high-yielding crops, mostly the Bodo rice, needs flood irrigation, extensive flood irrigation, which needs to abstract a lot of groundwater. Many places, including Western UP and others, you would convert the crop, the food crop, to cash crop, like sugarcane. And sugarcane and crops like this are water guzzlers. They would take 3 times the groundwater to feed than the food crop. So in these places, you have more groundwater usage because of the change in the economic practices. So all of this lead to severe groundwater exploitation. Now some people do say, and I partly agree, that some of these storage change are actually a reflection of climate change. Now it's possible, I'm not saying it's not possible. However, there is one policy that we follow for climate change studies, that we look at a 30-year cycle. Whereas what I showed you is a decadal cycle. So even if there is a climate change that is happening, so that signal would not be that prominent in a decadal scale. So climate change might be influencing, but possibly it's a larger framework of thing where you have human intervention that is causing the groundwater drought. One more thing that is absolutely not observed, not discussed, is the rivers. And you think like, what has river got to do with groundwater? Well, the matter of fact is that rivers are actually extensions of groundwater systems. We call them one water system. So rivers are actually window to groundwater systems. Interestingly enough, when we did this study in 2016-17, we just concentrated on Ganga, and now we are working with ISRO to extend it to all rivers, all mega rivers of the country. The rivers are all drying. So Ganga is drying. There was a subsequent paper recently by IIT Gandhinagar guys talking about the same thing, but in 2017 we showed that Ganga has been drying, and it's drying because it's not the river, it's not climate change. It's actually groundwater, abstraction in the upland. So if you look at in this figure, my pointer is not working. So those regional groundwater flow that would actually keep the river alive, if you're taking out the groundwater in between, the river is dying, no question. And in extreme cases, the river now can enter the groundwater system to kill it in double way, both way. Okay? So Ganga is drying. That's the baseline. I had a reasonable fight with the CEO of Namami Ganga project, where they tried to say, no, nothing is happening. I said, that's a lie. It's happening. Ganga is drying. No question asked. Now, if Ganga dries, what happens? You all know. But if my mathematical model or this calculation doesn't look like a reality, look at these photos. This is the Ganga River from southern Vihar, northern parts of Murshidabad and Nadia. Do you look like a Ganga River? People are walking on it in summer. Okay? Of course, not all the times. Parts of the summer. Ganga doesn't have any water. Ganga or Hooghly doesn't have any water. Telling you what I'm showing you by a mathematical model is not a lie, it's a reality. And this is going to get more and more aggravated as we use the groundwater more and more in the North Indian plains. Consequently, so if the Ganga is drying, you are going to stall the SDG and the food security. And we estimated that by 2050, if we maintain a status quo, more than 100 million people are going to be strongly affected by drought. But my purpose of presenting here is not to scare you. Okay? Let me also give you something optimism, some level of hope. And that's the blue areas. And these blue areas are the areas where we talked about groundwater replenishment, which we initially thought to be not happening, but some kind of error in our calculation. So what we did, we went back to the field data and started looking at all the 19,000 field locations that Central Groundwater Board has been monitoring between 1996 and 2015, and try to do analysis, nonlinear rise analysis of those. And what we found out that literally in certain parts of India, groundwater actually is rising. It's a fact. And they are more rising in two areas. One is Gujarat and one is erstwhile Andhra Pradesh, now Telangana and Andhra Pradesh. So let me show you examples from those two areas. So this study that I'm just going to show and just showed actually came out as a NASA website for the day of 22nd September in 2017. So the NASA website was our study. Why are the groundwater rejuvenating? Well, much of this actually was not planned. Now, the reason it's rejuvenating are a series of groundwater management techniques that have been employed from a very local scale to sub-regional scales, but most of the times they were not planned for groundwater rejuvenation. And as it seems that this can be from rejuvenating riverbeds to recharge canals, infiltration ponds, check dams, rainwater harvesting structures, and so on. Many times they wanted to just rejuvenate their village or locality, but something else happened. What happened? Well, something they did unknowingly, which actually made a difference. The first one was Manrega. So there, you know that there is a scheme called Manrega, Mahatma National Gandhi Rural Employment Scheme. The mandate of Manrega is actually 100 days of work, as it calls 100 days work scheme. And it's a socio-economic scheme to give 100 days work to the unskilled laborers. But what happened is that these unskilled laborers, when they're employed by the local panchayat or local agencies, they don't have much work to do. So what they do is they go and dig ponds. And they dig pond everywhere in the country. They also dug pond in the southern parts of India. Not explicitly knowing that they are actually creating recharge structures. That was not the plan. They were planned to just give 100 days work to the people. But unknowingly, they created millions of recharge structures which started infiltrating and rejuvenating the South Indian and Western Indian groundwater. The second one, something that I'd like to highlight, is you see these two electric poles, and you would think like what that has to do with groundwater. Well, this is actually the Jyotigram project of Gujarat. This was a project that was instituted in 2003, 2004, when the present Prime Minister was the CM of the state. And what they realized is that Gujarat being a very dry state in terms of groundwater, I meant, you are not having a lot of groundwater for irrigational purposes. And in these, at least those days, agricultural electricity was free of cost. So people were using 24 hours electricity to just take out groundwater from the subsurface. So it was wasting electricity, wasting groundwater. So what the then Gujarat government did is they restricted the groundwater by splitting the feed. So they put one feed for agricultural fields, one feed for the domestic purposes for 24 hours a day, automatically restricting to 1/3 of electricity use, and thereby, possibly influencing the groundwater. So the conclusion is that the groundwater storage condition in India in the last 2 decades is that we are losing in the north and the east about 13 cubic kilometers of groundwater, whereas we are gaining about 3 cubic kilometers of groundwater, telling you that 10 cubic kilometers of groundwater we are losing every year. So if you compound it by a range of 20 years, you can do the math. So what we are looking at, that we don't go for methods of understanding our groundwater and rejuvenating our groundwater in immediate emergency. We are looking to a drought at your backyard. So obviously this study took a lot of limelight, a lot of media observations came out, and of course as a researcher it was a good thing to do. But what we are looking at is a scenario where there is still a hope. Yes, there is a lot of things that have happened, unknowingly possibly, but there is still a lot of hope. And I would suggest, if you have an opportunity, you take a look at this book that we authored a few years back. Much of these things that I talked about are kind of listed in this book. And with that, I'll stop and would be happy to take any question that you might have. Thank you. Yeah, Dr. Bhattacharya.
(2015).
1996, 2015. Yeah.
Right. So about this groundwater depletion or this increment. So what is the later data? That is the last decade.
Right. So
some must be.
So yes, the data of course has possibly it has increased. I mean both of them has increased, but I still have, we have been just recently we recently received that data because it was not in a very sharing mode. So we recently received that data, and we are in the process of kind of. So one of my scholars is now working on it to update it to till 2022. So hopefully we'll have a more recent picture soon.
Dr. Mukherjee, I know that you must be working with the Ministry of Water Resources. So they have got this Ganga rejuvenation problem. The pictures which you have showed us about Ganga is very grim. So what exactly is happening in this Ganga rejuvenation factor? I mean, how they must have acknowledged the fact that Ganga is, even if you say that they have not acknowledged, they must have. Otherwise, why there is Ganga rejuvenation? I mean, so, but what exactly they are doing, whether they are in the right path, or what do you think is to be done to rejuvenate Ganga?
Right. So I was part of one of the advisory council up to one time, but now I'm not there. So I exactly don't know what they're doing now. So when they were doing that study, so they brought out a law, the Union government has brought out a law in 2018 saying the environmental flow, securing the environmental flow in the Ganga River, saying that there has to be a minimum flow in the Ganga River that has to be maintained. Now, to do that, to my knowledge, they were treating the effluent plants so that there is zero discharge to the river. They are controlling some of the barrages and dams upstream so that there is sufficient flow downstream. But I still strongly don't believe that there is any integration of the groundwater and the surface water management in one cycle. So again, I would not like to quote anybody, but the custodian of this data, because I've been a part of their signatories anyway, so they take a 10% as a number that goes in this way or that way. So there is no data, honestly, that exists that can result to calculation of what exactly is happening. So in my own capability as a scientist, we are trying to develop this data set in whatever little capacity we can. But as of now, there is no data that can be found to substantiate or not substantiate it.
Dr. Mukherjee, you showed those two maps of depletion and that, and rejuvenation of this groundwater. So in the Indo-Gangetic plain itself, you see there are two blocks side by side to each other. So one place it is red, other is blue. How is that? How do you explain that?
Yeah. So again, there are.
And what is the resolution of this GRACE data?
It's 400 square kilometers. So that's
square
yeah, that's something. Now the modern GRACE data is 100 square kilometer with more mathematical smoothing and more finer resolution data sets.
Let's come to the one which is the single one. No, not this one.
Yeah.
This two.
Yeah.
Just see.
I know.
Even in the Indo-Gangetic plain, you have got a blue, say in UP, North UP or
right.
something.
So
and you have red. And same in the West Bengal.
Yeah.
You have a blue and a red adjacent to each other.
Right. So if you follow these areas, you would see there are a couple of big rivers that flow through those areas.
But they're dying, we are saying.
Yeah, but dying downstream. So they are coming in from the Nepal, so if you
Bengal? You
said
Murshidabad is dying, but
Murshidabad,
there's a lot of blue there.
Yeah, there is these are not perfect. I would not say none of these are perfect.
Okay.
But yes, so if you look at a more regional sense, they make sense. But in a more local sense, there are ambiguities. So I would say we have to take it with a pinch of salt. None of these are perfect. But wherever they are showing like a dominant blue, there are some local hydrologic features which are possibly influencing to have more interactions. Okay. Or more groundwater rejuvenations.
Or the blue and the red might be some other factors as well besides.
Yes, absolutely.
And then Manrega was active both in south as well as north. So only in south you get the bluing of groundwater.
Right. So that's a very good question.
No, you don't know.
No. So that's a very valid question. So I was in another conference yesterday where the Atal Bhujal Yojana guys were there. And I told them one thing as a word of caution. Of course, I cannot advise them. That don't create a scheme, a plan, with a thought that one shoe fits all. It does not. Because the two aquifer systems, one in the south and one in the north, they're very different. Their geology is different, their hydrogeology is different, and so is the hydraulics. So the way this Manrega scheme or the recharge pits would work in a crystalline rock would not work in alluvial settings. So it's a porous versus crystalline aquifers.
I see the Vindhyans, it is all working.
Yeah, it will work.
Bluing of the...
It will work because what happens is once you have these ponds and it hits some kind of fracture system, the water immediately flows in. Whereas in a porous system, the water doesn't flow that easily. Okay. So it's just reverse of what you would think intuitively. But that's exactly what is happening.
Just one question, since you're working groundwater. There's a huge problem with uranium and fluorine in groundwater. All along this Gangetic plain, even in the south, wherever your agricultural field, you have this. What do you think is the reason?
Okay, so uranium, thorium, selenium, arsenic, they're all geogenic.
And fluorine, are they geogenic?
Or? Yeah, uranium, fluorine, fluoride, uranium, fluoride.
You have so much of uranium in the Indo-Gangetic plain.
I'm telling you. Selenium and what else I say, arsenic. They're all geogenic. They're all in some way connected to the geotectonics of Indian evolution. So of these, selenium, arsenic, and uranium, they are sourced to the Himalayas. Fluoride is more to the granitoids in the crystalline rocks.
Another source of uranium and fluorine, which is being used everywhere.
The fertilizers.
Yes.
So I'm coming to that. It's not the source actually. So it's not the source. Yeah, that's a misunderstanding. What happens, in all these sediments, there is uranium. Okay, there has to be some uranium. And so is arsenic. Uranium or arsenic, they are redox sensitive. Okay, and they would behave to the redox environment in which they're existing. Arsenic releases in a semi-reduced to highly reduced condition, whereas uranium gets liberated in an oxidized condition. Now, if you look at the history of uranium pollution, you'd see like it's only the last 10 to 20 years that people are talking about it. The simple reason is that this is also the time when you started using a lot of phosphatic fertilizers.
Exactly.
People think that the uranium is coming from the phosphate. Actually not. Orthophosphate is an ion exchanger with uranium, uranium-5 basically. Okay? So uranium-5 is in the sediments as a sink. So you use the orthophosphate, they get into the water system, and then it starts ion exchange reactions with the sediment and the water. Consequently, the water gets enriched with uranium. But that's not enough. These water, now since they are having so much irrigation, they are now also oxidized. Uranium-5, pentavalent uranium, is more stable in oxidized groundwater. Consequently, the uranium that you are observing got liberated from these sediments in the last 20 years, and you are observing them in the groundwater scenario. So that's our understanding.
Okay, but Bhatinda, if you take the example of Bhatinda, they banned DAP fertilizers, and there was a decrease. There was a decrease in uranium. Bhatinda was the cancer capital of this
absolutely.
country.
So
they banned DAP fertilizer.
That's the reason. So if you don't have the phosphate, then it's not liberating.
So it's some way or the other connected with the fertilizer.
Yes, yes.
Okay.
Thank you. In fact, very illustrative and many new things, especially using the gravity data, airborne gravity data or satellite data for predicting or for using in groundwater purposes. One question, of course, partly asked by Bagchi Sahab. Another very important question and pertaining to Rajasthan, I don't know whether the question is appropriate or not. You see, in northern Rajasthan, where we have famous from our point of view, this potash, there we have lot of problem of groundwater is up, and a lot of situation is bad because of the up groundwater. It floods the area.
Yes.
But reverse is opposite for rest of the Rajasthan. So there are famous this river linking projects. But can there be aquifer linking project? And if aquifer linking projects, whether they are feasible or not, now number one. And number two, I don't know, it's to my mind, it attracted my attention since I feel you are the best person to answer.
Okay, so the first question, if I got, so the groundwater replenishment or groundwater level up, going up in the northern Rajasthan. Now, tell me, like, again, I have worked in Rajasthan a long time back. So is it the IG canal area? Yes. So exactly. So in the IG canal, catchment, so because this canal is leaking, okay, so there are groundwater mounds that are forming. And that mounds over the last 20, 30 years, I worked in the IG canal area back in 2006, 2007. I'm assuming like it has even increased now. So what happens is because of this groundwater mound that are happening, as the water is rising, it brings out all the dissolvable salts from the subsurface. As it does so, and it comes more to the surface, like the evapotranspiration takes over. And there is a high rate of evaporation happening over hectares throughout the day. Consequently, much of these soluble salts are now getting precipitated on the ground, thus salinizing the soil. Okay? Yes. So that's the first concern, I think, salination of many of the groundwater region.
In fact, land is altogether degraded.
Right.
Sir, kindly.
Okay, just
we,
I'll take
we
30
have
seconds.
in fact, opportunity to interact
Okay.
with such a learned person. Yes,
Okay.
sir. Please, sir.
And the second one, the aquifer connection thing that you talked about. Now,
My point is whether aquifer can be connected. The way river linking projects are
right.
there.
So, in modern hydrogeoscience or hydrosciences, we consider surface water and groundwater as one entity. We don't differentiate them. So, river and groundwater, they are one entity. So, one example of what you just said, I don't know in India that has been done or has been thought to be done, but in China they are doing it. So, what they are doing is, that they are creating this Three Gorges Dam and, kind of blocking Brahmaputra River. But another aspect of that dam, which is not very, very much in the highlight, is they are channelizing much of that Brahmaputra water to the North China Plain. And North China Plain is a semi-desert. The sole purpose of channelizing the Brahmaputra River to the North China Plain is basically taking the groundwater in a sense, it's not the groundwater, it's the Brahmaputra River, but that river would have actually replenished the groundwater down south. But in essence, they are taking the water to the north to replenish the North China Plains. So it's a virtual linking, if you might call.
My in fact point was that suppose some barrier is there separating the two different aquifers.
Okay.
So whether okay sir, okay, no problem.
I can talk to you later.
Okay. Thank you.
Thank you so much.
Thank you, sir.
Thank you.
Thank you, Professor Mukherjee, for that very illuminating and thought-provoking address. I would now request Dr. Joyce Bagji, Additional Director General, GSI Central Headquarters, to please come up to the stage and present Professor Mukherjee with a memento as a gesture of our gratitude. Thank you so much. It was a very nice talk.
Get the first slide. First slide. Your name will be.
We truly appreciate the direction and clarity that Professor Mukherjee brought to this very important subject. Thank you, sir. With this, we'll now proceed with the presentations of this technical session, and I would like formally to hand over the proceedings of this technical session to our session chair. Sir, please continue. The session is now yours.
Yeah. So first lecture by D. Meshramji. Anybody there? So second, we start with tracing geochemical characteristics of Schumacher Oasis, Eastern Antarctica.
Good evening, everyone. My name is Wasim Ahmed, and I'm a PhD student in the Department of Geology, Central University of Punjab. Today, I'll be talking about my work tracing the geochemical characteristics of in and around Schumacher Oasis, East Antarctica, and implications to the weathering and provenance. So, before I start, let me briefly introduce you about this region. So Antarctica is one of the most significant places on our planet Earth, as it plays a huge role in maintaining the climate change and in maintaining the climate change. if you look at the map of this region, you will see that most of this continent is covered by the ice sheets throughout. More than 98% of this continent is covered by the ice sheets. So whatever little present, I mean to say, it's less than maybe 5% that is exposed to the surface in the form of the nunataks, lake basins, or the oases. So these these lake basins particularly, they act as the natural laboratories that preserve the geochemical signatures that tell us about the transporting history, about the rocks, about how they have been deposited over the time there. So our main objective is to understand the two fundamental questions, like how does the weathering operate in these extreme polar environments, and what are the sediment, what they tell us about the source rock or the parent where from these materials have come from. So mostly when we talk about weathering, one thing that comes into our mind is that the weathering mostly is intense in the tropical regions where the liquid water availability is more. But when we see the weathering processes that occur in these polar environments where we have limited water availability and the biological activity is limited. But here in these areas, the weathering processes occur. So for this reason, we have chosen two areas are here. One is the Shimachar Oasis, and next is the Lake Untersee. So both are located in the East Antarctica. So these are one of the, I mean to say, ideal places. I mean, where we can address and see how the weathering process is occurring over there, because they give us the first-hand clues about the sediments that are coming from the parent rock, and there is very less reworking of the sediments. So these are the main objectives we are trying to understand here. So these are the samples which we collected from Shimachar Oasis and from the Lake Untersee. So first of all, we try to see the grain size analysis, how we try to observe the grain size analysis of these sediments. So we collected sediments from the proglacial lakes and from the landlocked lake and the Lake Untersee. From the proglacial lakes, here we can see most of the weight percentage of the fine-grained sediments is dominated here, and as you can see in the very first graph here shown by the proglacial lake. So fine-grained sediment, the weight percentage of the fine-grained sediments is more dominated here, and very less is from the coarse material here, and the widespread little they may be deposited during the higher energy meltwater pulses. Similarly, in the landlocked lake, we can see here also that the fine-grained sediments are very much dominant, and they have been deposited during the very low energy conditions, and there is more uniformity in the landlocked sediments. Why? Because most of the time there is not much influence from the outside. As compared to, if you see the Untersee, there is more gradual slope. It means that and here also we can see the sediments are mostly fine-grained deposition, and they have been deposited in a very calm and really in a very calm energy conditions. So here we try to see, to plot how the sediments are texturally. So here in the first plot, we see that most of the sediments are plotted in the gravelly, muddy sand, and there is a little bit of slightly gravelly sand. So there is also a little bit of variability. Maybe they have been deposited during the, there is some energy distribution when they were deposited. Here in the second graph, we can see that the sediments have been plotted in a silty sand, and they are very linear in nature. And this means that they have been most deposited in a high energy condition and are mostly maybe felsic in nature. So we also try to understand the weathering indexes. We use different weathering indices like the chemical index of alteration, plagioclase of index alteration, and the index composition of variability. We see from the both regions, if we compare, we see that in the Shimachar oasis, we have higher chemical index of alteration and the plagioclase index of alteration as compared to the Gruber-Untersee lake. So if we, we see that in the Shimachar oasis, which is relatively, which has relatively higher temperature as compared to the Lake Untersee. Here, mostly this lake remains perennially covered by the ice sheets. Here in the Shimachar, we have more water rock interaction, and there possibly this may be due to that there is a little bit of maybe chemical weathering, moderate to low. So here we try to see try to plot this these samples and see the rate of weathering from these different plots. So most of the samples from the Shimachar oasis are clustering near the felsic trend as shown by the red circles, and the Lake Untersee they're also clustered near that. So means that there is very little kind of a chemical weathering. Mostly they are dominated by the physical kind of a weathering, as we can see that in the graphs. Shimachar are relatively trending towards the elite, but that's not much alteration there. Similarly, in the second graph, we can see that they are clustering near the granite gneissic complex here, and here also we can see that the weathering is not that much higher. It's comparatively lower side. And here also we can see that the weathering is near to 40 to 50, and which is considered as kind of a moderate weathering. So overall, we can see from these graphs that the mechanical weathering is much more dominant as compared to the chemical weathering. Here also from the ratios from the CI and ICB values, we see that most of the sediments from the Shimachar are having moderate kind of a weathering as compared to the Untersee Lake sediments, which have which are weakly weathered, means that there is kind of a negligible, we can say, the chemical weathering, and they are compositionally immature. That means that they have been mostly derived from the mechanical weathering. From the major element chemistry, we see that most of the, from the Shimachar oasis, we have higher SiO2 values and KTO values. From the oasis, this Untersee oasis, we have higher Na2O and Al2O3 values. This means that most the sediments that are coming mostly from the felsic in nature from the Shimachar, and this has mafic to intermediate in nature, the Lake Untersee oasis. So from the RE, we try to normalize using different normalization patterns to see the provenience and how does the sediment samples vary from these two different regions. So overall, from the overall pattern, we see there is positive anomaly in the Shimachar oasis, but few of the samples are also showing negative anomalies. Negative anomaly. Maybe this is due to the plagioclase fractionation. And here we also see that there is enrichment in the LRE elements progressively, and flat HRE means there is not much alteration in these elements in the elements. So particularly. So overall, what we understood so far in this work, that most of the sediments that the weathering that is occurring in both the regions, in the Shimachar oasis, it's dominated by the mechanical weathering, but there is relatively also a moderate chemical weathering. But in Untersee is mostly dominated by the physical weathering. Provenance indicators also confirms that the source of this is mostly felsic in nature, where in some Untersee lakes it may be mafic to intermediate. Thank you.
Thank you, sir. Any questions? One person. Mike.
Okay, sir. Yes. Yes, sir. Sir, I was just saying like mostly they are trending towards the fell signature. But if we look at the trend, it's slightly going towards this elite muscovite kind. Maybe.
No. You can see that illite and muscovite is somewhere in the corner of that AL right now.
Yes, sir.
But your samples fall very close to plagioclase and K-feldspar intersection right now.
Yes, sir.
So it means your samples has not weathered at all. It is completely glacial erosion. So there is no chance for weathering because that is the polar environment. There is no chance for the organic acid. There is no chance for carbonic acid present in that environment. So that is why your sample shows the very close to plagioclase. So you can talk about physical weathering, you can talk about mechanical weathering based on your data, but you cannot talk about chemical weathering. That is my suggestions, but you can read some more paper now. Thank you now.
Okay, sir. Yes, sir.
Hello. Yeah. Actually, you should have compared the weathering index of this region with some known weathering regions of tropical regions of the same age. What is the age of those lake sediments? Thereafter, it would have been very clear what is difference and what is the impact of that climatic differences between tropical and that extremely cold weather.
Yes, sir. Sure, sir. Actually, our work, this is in progress and we have not completed yet, sir. But sure, sir, I will take this.
Good presentation.
Thank you, sir.
Okay, thank you. Then we can So we come to our last presentation. Soil magnetic studies to decipher the coconut yield potential in Kanyakumari district. Anybody?
Yeah, please come.
Good afternoon, everyone. Myself, Dr. V. Kumaravel, Associate Professor.
Come close to my.
Yeah, good afternoon, everyone. Myself, Dr. V. Kumaravel, from Central University of Tamil Nadu. So I will be presenting about soil magnetic studies to decipher the coconut yield potential in the Ithamuri area, Kanyakumari district, Tamil Nadu. So before proceeding to topic, I just to give the brief intro about the rock magnetism or soil magnetism and iron oxides. So pedogenesis in the soil forming process is mainly governed by the various processes including the climate, vegetation, topography and biogenic activities, and especially the magnetic mineral like iron oxides and iron hydroxides, they behave very promptly to the environment, means ancient or the prevailing environment, and they preserve the first-hand information about the prevailing climate and environment. And rock magnetism or the soil magnetism is a simple and rapid techniques to understand their distribution and their characteristics. So earlier, it is being that rock magnetism or soil magnetism is being used for mapping urban environment to distinguish the anthropogenic or lithogenic magnetic fractions, or magnetic enhancement by pedogenesis, and the relevant paleoclimatic interpretation or characterization of road as related to traffic volumes. And it has been related with the soil color and elemental mobility also. And recently, what we have come through that it has taken into different dimensions. The soil magnetic studies has been used for the agriculture. Recently, Catalan et al. In 2021, he has used, it is from Indonesia, he has used the mapping the soil magnetic susceptibility of that particular area, especially in the sugarcane terrain, and he want to establish the relationship between the magnetic susceptibility and the sugarcane yield. And he has also luckily established that the highest magnetic susceptibility classes are coincide with the highest yield of sugarcane. And especially he would be able to delineate that there are some particular sugarcane types can grow in particular area where the soil magnetic studies or soil magnetic susceptibility can easily correlate. Similarly, and Suleika et al. 2022, he has studied the magnetic susceptibility or magnetic properties of the soils of orchids, and he could be able to successfully correlate the lower magnetic susceptibility values with the larger diameter of the apples. So that is what the research is taken into new dimensions in recent years, and we thought that how we can use those studies which are carried out in Brazil and Indonesia in the Indian soil terrains. And we have chosen the crop, means especially the coconut. We wanted to study how they are behaving, the soils of coconut forms, how they are going to behave, or how whether they are having any relationship with the soil magnetic properties, especially the magnetic susceptibility. And we have chosen that area for our studies. In the southern part of Tamil Nadu, near Kanyakumari, Ithamoli area, where the large number of coconut cultivation is going on. So what we did is that, so before collecting the samples, we prepared the coconut inventory, like where we want to take the soils, and near that area we wanted to have the coconut yield of that particular area, means whether it is having high yield or low yield, and whether that soil is having any relationship with the coconut yield. So for that we are preparing the field inventory with our field observation as well as the interaction with the farm owners. Those judicially our samples were collected in between 800 to 1000 meters interval by removing the upper organic layer and taking the soil from 5 to 10 centimeter depth. So that's what we have categorized the coconut yield into high, moderate, and low, where we are having the less than 10 coconut in the trees around the soil site, sampling site. We are categorized in the low yield area, and where we are having more than 20 coconuts in that particular site, we are categorized into high yield area, and in between we are categorized into low to moderate or moderate yield. So we have collected the samples from all the yield categories soils, where we are having low, moderate, and high yield areas. And about 19 samples we were able to collect it, and covering an area of 10 square kilometers. And the samples were air dried before doing the magnetic susceptibility studies. And the samples were packed in the non-magnetic 10 cc pots, and with a euro mark for a reference. And we have carried out the magnetic susceptibility studies in the magnetic susceptibility meter MS3 with MS2B sensor. Apart from that, we have also carried out hysteresis properties and thermomagnetic studies to understand the iron oxides, or what are the type of magnetic minerals present in the sample. So we wondered the results, what we got is that, so we have the low, medium, and high yield samples, and we could able to see that there is a linear relationship between the magnetic susceptibility and the yield potential of the coconut in the soils. So when we group it, we could able to see the high yield, the samples from the high yield coconut area where it is having the low magnetic susceptibility, and the low yield areas having the high magnetic susceptibility. So it can be easily correlated. It is having an inverse relationship with the coconut yield and the soil magnetic properties, especially the magnetic susceptibility. You can see here it is very linear. Low yield areas having higher range of magnetic susceptibility, and high yield areas are having low range of magnetic susceptibility. It is the magnetic susceptibility gives overall the quantum of magnetic mineral in that sample. So we wanted to know what kind of minerals are there, especially which is contributing the magnetic susceptibility. So in that one, we have taken the representative samples from the low yield area and high yield area. So where we can see that when we are going for a hysteresis properties to study the magnetic mineralogy, we got able to see the distinct difference in both the samples. Where we are having the low yield areas, it is when we apply the magnetic field, it is getting saturated at about 800 millitesla, around 90%, wherever the high yield areas, the samples keep acquiring the magnetic field even at high magnetic applied field. And it is giving that different samples, different magnetic mineralogy, means that the low yield areas having a soft magnetic mineral like magnetite, and the high yield areas having hard magnetic mineral like hematite. So to have that, confident in that results, we have done the thermomagnetic properties, like heating the sample and analyzing the magnetic field or magnetization of that particular sample to understand the Curie temperature of the sample. So when we are doing for low yield sample, that samples are getting, the magnetization of the samples are reducing to 0 at about 583 to 586 degrees Celsius temperature, indicating that there is a magnetite is present in that sample. Moreover, there is a magnetic inversion, means low temperature oxidation is occurring at about 290, means around 300 degree, where the titanium magnetite is getting oxidized to magnetites, which is indicating increase in the magnetization in the sample. In vice versa, when we are analyzing the high yield samples, it is delineating, means it is decreasing the magnetization with temperature, and about 680 degree or so in the magnetization is attaining to near zero. And it clearly indicates that there is a distinct magnetic mineralogical composition, both the samples, where the low yield samples are having the magnetite and the high yield samples are having the hematite. So this is the first kind of such attempts we have done here to understand, is there any kind of information can be obtained, like in case of crop yield. But if you want to understand the crop yield by doing the normal conventional method, we got to go for a soil classification, physical, chemical, and biological parameters to analyze, which takes a lot of time and energy. But just to doing these magnetic studies, we could be able to delineate the high yield areas and low yield areas just by doing the magnetic properties of the soils. And it is also inferred that the well-drained, oxidized, and sandy soil favor the high coconut yield in that particular area. So that's what now we are doing in the larger scale to understand and to have some particular control over the crop yield, and we are trying to apply for other crops also. Yeah, thank you.
Very good presentation and interesting topic. Any questions on this?
Hello. Actually, your study is general.
How many samples did you analyze in your study?
19 samples.
19
sir.
samples.
Yes.
And did you do whole chemical analysis for the bulk of samples?
Yes, sir. We have done it, sir, but it is more of silica rich. So only Al2O3 is having some relationship. So and
Well,
we have,
you didn't have any correlation between the chemical composition and the yield of coconuts.
yes,
You
yes,
didn't.
Yes, sir.
Huh?
Yes, sir. It's not having any proper relationship, sir. Maybe we have to go for trace element studies. It may throw some light, sir. But major oxides are not giving any proper relationship.
I mean, 19 samples, do you consider it statistically significant to draw a conclusion like this?
Yes, sir. Actually, the initial studies that we tried, because it is for a graduation dissertation work, and we tried to have some idea whether it is having or not. So we are having the positive result, and we are trying to do it for larger areas, sir.
Okay.
Sir?
The period of your study, how long did you see the yield of your coconuts?
So actually, this is for one session we have taken, sir. Moreover, in the discussion with the farmers, so they are knowing that where the coconut yield is more or less. So we are with our field observation as well as the discussion with the farm owners.
It's oral culture, basically.
Yeah. Hello.
Quite interesting, in fact.
Yes, sir.
But you see that magnetic susceptibility, whenever you measure, it doesn't restrict to the measurement of the soil. It goes beyond that also. So how do you deal with it?
Sir,
See, as DG sir has also said, data population is very less. From our perspective, you may consider it sufficient. That's why you have submitted here deliberations. But the point number one, I already told that any magnetic susceptibility measurement at any point, it doesn't deal with only the upper surface where our soil is, but beyond that also, number one. Number two, data density, of course, as DG Saab has said. Please.
Yes. Sir, actually, sir, we have not done the magnetic susceptibility in situ. We have collected the soil samples and we measured in the lab actually. So 10 ml or a 10 cc pot, we have taken like 15 grams of samples. We measured in the laboratory in the magnetic susceptibility meter. It is not in situ measurement, sir. So that though it will not have the effect of underlying soils.
Okay, thank you. I think time is there.
Thank you.
So okay, then it's thank you, sir.
Thank you,
sir. Carry on.
Very
it's
good,
a good topic.
presentation, Mr. But one just query: what is the thickness of soil there, and what is the rock beneath, because many a times this magnetic susceptibility, if it is high, it indicates more pedogenesis and more constituents in the soil. So they may affect the, rather they increase the yield of the coconut. So what is total consideration of the package? Because this cannot be applicable for all the regions, all the areas.
Yes, sir, definitely, sir. Actually, the soil actually it's a coastal area. The basement is lying much deeper actually. So 5 to 6 meter soil thickness is there actually. It is alluvial terrain actually, sir. Yes, sir.
Okay, thank you.
Thank you, sir.
Sabhi ko namaskar. The session was, though only 2 papers, but one special keynote speaker gave a lot of data, and it's a food for thought for everybody that we have to do something about how to restore our groundwater through various means, and how to change our agriculture practices. That is the essence, and in government also people are thinking about that. So that is good presentation. And regarding this second topic, Antarctica, this was also a new thing, though a lot of work is yet to be done. And this third topic also, we can have a lot of studies on this, because 19 samples are too few. Thank you.
Thank you, sir. Actually, the keynote speaker's topic was very apt for the theme Thriving Earth, the Critical Zones. His results, though his results studies indicate some water crisis, especially in the Indo-Gangetic plain, but this study will help in strengthening the groundwater security of India by sustainable use, proper recharge, and strict regulations. So by this, this session was really very interesting to have, though the total number of presentations were a few only. Thank you very much.
Thank you to the session chair and co-chair for presenting their concluding remarks. With this, we have come to the end of this technical session. May I now request our esteemed Director General GSI to please come up to the stage and felicitate our session chairs for their insightful inputs. May I please request, sir, you to come. As we formally conclude the technical sessions of this conference, we express our heartfelt appreciation to all of the chairs, we also express our heartfelt gratitude to all the presenters and all the delegates. Thank you all for your invaluable contributions. I would now take a moment to acknowledge our Additional Director General Finance and Head of the Department, GSI Central Headquarters, Dr. Joydeep Kuho, whose expertise and pivotal role in the mobilization of funds paved the way for the smooth execution of this event, making the international seminar a remarkable success. Please put a round of applause. And to extend our sincere gratitude, I would request our esteemed Director General, sir, to please felicitate Dr. Joydeep Guho, sir. I request you, Guho, sir, to please come up to the stage. And accept our token of appreciation. Thank you, sir. Thank you to all the delegates, participants, and audience for being with us all this while. We will now move on to the closing ceremony next, and I request everyone to please stay with us as the closing ceremony will be starting very soon. Thank you. That's it from my side.
Namaskar, Adab, Khamaghani, and a very, very good evening, distinguished dignitaries, esteemed delegates, respected guests, and all our dedicated participants. A very warm and sincere welcome to the closing ceremony of the International Seminar, Unearthing the Past, Shaping the Future, 175 Years of GSI. I'm your host, Anamika Anant. So as we gather here this evening, it is truly inspiring to reflect upon the journey of the past 2 days, a journey marked by profound insights, vibrant discussions, and a collaborative spirit that has defined this seminar. Our discussions have encompassed the strategic significance of critical minerals, the role of emerging technologies such as artificial intelligence in exploration, the complexities of geohazards, and the revelations found in the Earth's deep past. Notably, our thematic sessions addressed the evolving landscape of resource management, energy, geodynamics, geoheritage, and the integration of computational advances, demonstrating the depth and interdisciplinary nature of modern geoscience. So together, these deliberations have not only strengthened our scientific insight, but have also fostered invaluable collaborations, reaffirming the essential role of geoscience in building a sustainable and prosperous future. Ladies and gentlemen, it's now my distinct pleasure to guide you through the concluding session of this profoundly enriching seminar, Unearthing the Past, Shaping the Future, 175 Years of GSI. So to formally commence the ceremony, may I respectfully request our esteemed dignitaries to kindly ascend the dais and take their seats. We are honored to have with us Shri LMS Mora Sahab, Deputy Director General and RMH2 GSI WR and Convener. Mora Sahab. Let's welcome Dr. Catherine Goodenough from British Geological Survey. A huge round of applause for Professor Abhijit Mukherjee from IIT Kharagpur. Abhijit Mukherjee Sahab. Hello, sir. We now invite Shri Joyesh Bagchi Sahab, ADG PSS, Central Headquarters, Kolkata. A huge round of applause for Shri Vijay V. Mughal Sahab, ADD and HOD, WR and Chairman, Organizing Committee. We are pleased to have with us Srimati Varsha Ashok Aglave, ADD and HOD, Eastern Region. A huge round of applause for Varsha Ashok Aglave ma'am, ADG and HOD, Eastern Region. And now, ladies and gentlemen, we would like to invite on stage our chief guest, Shri Asit Sahaji, Director General. Ladies and gentlemen, please join me in welcoming them to the stage with a very warm and generous round of applause. And now, as a token of our deep respect and appreciation, we will now felicitate our distinguished dignitaries with saplings and mementos. As you know, a sapling symbolizes growth, sustainability, and a commitment to a greener future, values that are at the very heart of GSI's legacy and vision. Ladies and gentlemen, let us begin with a huge round of applause for our chief guest, Shri Asit Saha Sahab, Director General. To do the honors, I would like to invite Shri Vijay V. Mughal Sahab, ADG and HOD, GSI, WR. Next, I would again request Shri Vijay V. Mughal Sahab, ADG and HOD, GSI, WR, to kindly welcome Shrimati Varsha Ashok Aglave, ADG and HOD, Eastern Region. A big hand for Varsha ma'am. Now I would request Shri LMS Mora Sahab, DDG and RMH2 and convener to please welcome Shri Vijay V. Mughal Sahab, ADG and HOD and chairman of the organizing committee. I would once again request Shri LMS Mora Sahab, DDG and RMH2 and convener to please welcome Shri Joyesh Bagchi, ADG PSS Central Headquarters. And now, ladies and gentlemen, let's welcome Miss Catherine Goodenough, Head of Regional Geoscience International from British Geological Survey. And to do the honors, I would request Shri LMS Mora Sahab. And now, ladies and gentlemen, a huge round of applause for Professor Dr. Abhijit Mukherjee Sahab from IIT Kharagpur. And I request LMS Mora sir, please come here and do the honors. And finally, ladies and gentlemen, let's welcome Shri LMS Mora Sahab, DDG and RMH2 and convener. And to do the honors, I would like to call upon stage Shri Harish Mistri ji, Director and Organizing Secretary. And now, ladies and gentlemen, to formally begin the proceedings, I call upon Shri LMS Mora Sahab, DDG and RMH2 GSI WR, and convener of this seminar, to deliver a brief welcome address and present an overview of the proceedings of the past 2 days. Sir, the podium is yours, sir.
Thank you, ma'am. So, ultimately, we come to the concluding session of this 2 days vibrant international seminar, the title Unearthing the Past, Shaping the Future, that's 175 years of GSI. Respected dignitaries on the dais, our DG GSI, Mr. Achit Saha, our Deputy Director General, Sri Vijay V. Mughal Sahab, and Chairman of the Organizing Committee, Ms. Catherine Goodenough, who is the Regional Head, Geoscience, British Geological Survey of India, Dr. Abhijit Mukherjee from IIT Kharagpur, and Ms. Varsha Aglave, ADG from GSI, and Sri Bakchi Sahab, our ADG, GSI, and distinguished plenary and invited speakers, esteemed delegates, academicians, geoscientists, professors, policymakers, researchers, then key stakeholders, and various institutions from India and across the globe, colleagues from these institutions, and dear friends. It is my honor to deliver the overview of this 2 days proceedings of the international seminar in this concluding sessions, which be the seminar organized for commemorating the 175 years of Geological Survey of India. In this seminar, in the inaugural session, we were very highly, I'm thankful that our chief guest, Sri Honorable Sri G. Kishan Reddy ji, and the Secretary, Ministry of Mines, and the Principal Secretary, Mines and Petroleum, had participated in the inaugural session of this 2 days international seminars. These international seminars bring together some of the finest minds of the geoscience, and over the past 2 days, we witnessed a remarkable exchange of the knowledge and high-level discussions, which has significantly deepened and expanded our collective scientific understandings. This international seminar featured high-level plenary keynote talks by the distinguished international speakers. A total 9 keynotes were delivered. Out of these 9 keynotes, 4 were online and 5 were presented in person in these seminars. Dr. Catherine Goodenough spoke on the hot topic of today about critical minerals' importance in the energy transition and the role of geological survey in understanding the mineral systems and studying the critical mineral systems and assuring the critical mineral supply. Dr. Fausto Gazzetti, who was from the Research Institute of Italy, and he discussed about the landslide geohazards and challenges facing in anticipation of landslides and its mitigations. Dr. Geoff Fraser, Geoscience Australia, addressed about isotopic mapping and isotopic studies of various methods and determination of age of geological materials. Then Professor Karanja, who misfortunately missed the flight to India, but he very readily agreed to deliver his important lectures online, and he discussed about the modeling of the mineral exploration targets with the help of advanced techniques of artificial intelligence. Then Professor Yani Najman of the Lancashire University, England, discussed about dynamics and tectonic evolutions of Himalayas and Tibetan plateaus. Then Professor Mrinal Sen, University of Texas, discussed about geophysical inversion techniques, its usefulness, and cautious geoscientists in the field of mineral exploration. Then Professor Jeffrey Wilson Mantilla, Michigan University, USA, takes us to the past and spoke about dinosaur evolution. Dr. James Haynes of the United States Geological Survey discussed about the mineral deposit associated with the deep sea beds, their current status of mining, and future prospecting of their mining and comparison between the terrestrial and deep sea mineral deposits. Then Professor Subimal Ghosh, IIT Bombay, Mumbai, he discussed about the climatic critical zones and interaction between the land and atmospheres. These lectures not only provided present-day advanced work and research in various fields of geoscience at global level, but also provided invaluable directions for future scientific endeavors. During these today's seminars, a total 5 technical sessions with 4 parallel sessions on different themes in different halls like main auditorium, mini Audi 1, mini Audi 2, conference hall for oral presentations, and 4 technical sessions for poster presentations in the forenoon and afternoon session on each day of this 2 days international seminars were organized. This seminar was scheduled to feature a total 317 peer-reviewed presentations, 114 oral presentations, and 213 poster presentations. And these presentations covers a wide spectrum of the themes. In fact, there were total 11 themes for this international seminar. Briefly, if I say, they are the geodynamic riddles, the depth of the solid earth, exploring treasures, advance in the understanding of ore formations, exploration and resource challenges, sustainable our planet's critical minerals, energy and mineral resources, next wave, innovations in analytical and computational frontiers in geoscience include AI, ML, geohazard decoded, research for a safer tomorrow, geological insight for a thriving earth, the critical zones, from origin to now, decoding the evolution, geophysics insights, imaging the earth, below the waves, the oceanic enigma, the pulsing planet, orogenic forces and rhythmic resonance, then guardian of times, geoheritage preservations. Each technical section began with a very interesting, thought-provoking, and informative lectures and talks by eminent and distinguished geoscientists in their field of interest and research. The respective invited speakers belong to various reputed institutions such as British Geological Surveys, Research Institute, Italy, Polish Geological Survey, IIT Bombay, IIT Kanpur, IIT Kharagpur, IIT ISM Dhanbad, IIT AMU, JNU, NCESS, Punjab University, BSIP, Delhi University, our serving and retired DDGs from GSI. These includes respected Professor M.A. Mamtani ji, Professor M.A. Panigrahi ji, Professor N.C. Panji, Professor Gurmeet Kaur, Dr. Begnew Melodeb ji, Professor M.E.A. Mandal, Dr. Moro Rossi, Professor S.K. Paul, Professor M.L. Dora, Professor Abhijit Mukherjee, Dr. P.R. Gulani, Professor Rajiv Sinha, Dr. Saibal Ghosh, Dr. Alok Podwal, Dr. D.M. Mohave, and Dr. N.V. Chalpati Rao. I thank all of them for their thought-provoking talks, their contributions, and advanced discussions on critical mineral exploration, metallurgy, tectonics, geodynamics, geohazards, remote sensing, geophysics, the critical zones, AI/ML applications, core to crush processes, and marine geology, which enriched this international seminar. In each technical session displays scientific depth, field-based insights, rigorous modeling, and constructive engagement, which reflecting the maturity and vibrant of India's geoscience community. The seminar presented both in oral as well as in poster covered a wide spectrum of the themes, and it includes ore deposit studies, critical mineral potentials, stratigraphy and sedimentations, quaternary geology, hydrogeology, geohydrohazards, innovations, and geospatial modelings. The energy and enthusiasm shown by the young researchers, the thought-provoking interactions between presenters and the listeners, and particularly inspiring, signaling a promising future for the geoscience in India. Across all sessions, several key priorities were clearly emerged during these 2 days interactions during this international seminar. One is the rising national importance of the critical minerals. We have to focus on the research and the search of the critical minerals for our safe future. The need of multidisciplinary data integration explorations, then expanding role of AI and ML and digital geology in more accurately predicting the prospecting areas for the future mineral explorations. Then role of advanced geophysics in the field of mineral explorations, new advanced technologies like DSRS, TEM, magnetic resonance methods, and various surveys, both conventional as well as using the advanced technology, for looking into deep, covered, and concealed terrains, and advanced instrumentations required for all these methods, and this cutting edge technologies for utilizing the GP surveys in the deep, our covered terrains. The urgency of the research on climate resilience and hazard mitigations. Looking for new mineral resources under the ocean beyond terrestrial resources, and looking for their exploitations without disturbing the delicate marine environment. And then the need and importance of stronger collaborations among professionals, academia, Indian and global research institutes, and industrial partners is more also emerged as an important outcome of this seminar, which may lead to the incorporation of advanced research for sustainable development, exploitation of the earth resources, and to fetch the ever-growing needs of the minerals in our mineral industry. It is symbolized through the MOUs exchanged during the inaugural sessions between GSI and IIT Bombay and IIT Kharagpur. An exhibition of our sponsors and exhibitors also attract a massive crowd and interest in this international seminar. The stall displays their products and their works in different parts of India and instrumentations they deal with. So, on behalf of the organizing committee, I extend my deepest gratitude to our Honorable Sri G. Kishan Reddy ji, Sri Piyush Goyal ji, our patron Asit Shah ji, our chairman of the organizing committee Vijay Mughal ji, all the organizing committee members, and these distinguished dignitaries, speakers, delegates, the session chairs, and coordinators of the different technical sessions, reporters, and sponsors, and every officers, staff members, and volunteers whose dedications make this seminar a grand success. Our sponsors especially deserve heartiest appreciations. Their support play a crucial role in bringing this event to a life. As we conclude this session, I am very confident that the ideas exchanged during these 2 days will spark continuous collaboration and scientific excellence, guiding us towards a future where we truly unearthing the past and shaping the future. Thank you.
Thank you so much, Rimora Sahab, for that insightful overview and for steering this seminar to its great success with your remarkable dedication. And now, ladies and gentlemen, let's put our hands together for Dr. Catherine Goodenough, Head of Regional Geoscience International, British Geological Survey. Ma'am, we request you to kindly share your perspective. The podium is yours, ma'am.
Director General, colleagues from GSI, ladies and gentlemen. I'd just like to say, first of all, congratulations to the GSI again on this incredible seminar to celebrate your 175th anniversary. It's been wonderful to see so many talks and to hear about so many topics. Of course, from critical minerals and green energy, all the way through geohazards, through groundwater, and even the movement of the continents and how we can understand continental reconstruction from dinosaur fossils, some of which was really quite new to me. It's also great to see so many people here, and indeed still here for the closing ceremony. So thank you all for staying and listening. Of course, we had a delegation here from the British Geological Survey and also from the British High Commission, and we've hugely appreciated the welcome that we've received from GSI and from all our colleagues here. And we were very grateful for the opportunity to meet with the Honourable Minister for Coal and Mines. I think it really shows the importance of the UK-India partnership in areas around critical minerals, the energy transition, and so much wider. And indeed, our collaboration between BGS and GSI, we've talked about it a lot over the last couple of days, and I really hope that this seminar will make that go from strength to strength. So again, I'd just like to say thank you all so much, and congratulations to the GSI on this superb seminar. Thank you.
Thank you so much, Dr. Catherine Goodenough. Thank you for your insightful perspective. Thank you once again. Kamagani. And now, ladies and gentlemen, we would like to invite Professor Dr. Abhijit Mukherjee Sahab, eminent geoscientist at IIT Kharagpur. Sir, we request you to kindly address the gathering. Please.
A very good evening. Thank you so much for inviting me to this valedictory session. Well, before I start, I'll just like to say a few personal words. You know, I was a student of University of Calcutta, and as many of my classmates were enthralled to go to the GSI library those days, almost 30 years back, I had the opportunity to do my MSc thesis at GSI, you know, working in the landslides in the Eastern Himalayas. And, you know, we used to really wonder the huge resource that GSI has, and you know, the lot of geoscience brains that have been serving the geoscience knowledge base of our country. Since then, you know, I'm standing here at the valedictory session of the 175 years of GSI, so that's quite a journey. And it's a journey for GSI too, an organization that has tested the test of time. You know, there have been many organizations, and I was just talking to Kathy on the relationship with British Geological Survey and the Geological Survey of India, and I just realized that Geological Survey of India is 25 years younger sister to the British Geological Survey. So, you know, it has been, I'm sure, a huge successful journey for GSI. And this conference, although I kind of joined a little late, just midday today, I realized there have been, you know, very eminent talks by some of the best in the world, and I see some of the best geoscience mind in the country to be gathering in this conference. So I wish a very good happy birthday to GSI, 175th of it, and a very successful conference. I'm sure like the young minds, the students, I see a lot of students here who are participating, to take away something very optimistic from these sessions. Now, on a different note, as our colleague noted that one of the MOUs was signed with IIT Kharagpur, which is my organization, with GSI at the beginning of this conference. And in my role as at the Office of Dean of Research and Development at IIT Kharagpur, we are really looking forward for accelerated collaborative relationships with GSI. There are already some GSI scientists working with some of our professors and students in more individual ways. Some of your GSI officers are doing PhD with us, but we want to make it a more widespread event, a more widespread phenomena. So I've been talking with the Honorable DG in finding out ways how to do it. So I'm looking forward, GSI and IIT Kharagpur, to be working in a much more stronger way from topics ranging from critical minerals to maybe water exploration to landslides in a future time. Thank you so much and congratulations again.
Thank you so very much, Professor Dr. Abhijit Mukherjee Sahab. Thank you for your address. And ladies and gentlemen, with a huge round of applause, we now invite Shri Joyesh Bagchi Sahab, ADG PSS Central Headquarters, to address the gathering. Sir, we would be privileged to hear your perspectives. Please.
Shri Asit Saha, Director General GSI, Shri V.V. Mughal, ADG and HOD Western Region, as well as the Chairman of the Organizing Committee, Srimati Varsha Aglave, Professor Catherine Goodenough, Professor Vijit Mukherjee, LMS Mora, friends, colleagues from different organizations, as well as friends from GSI. Good evening to you all. It's a very proud moment as a GSI personnel to be here today, celebrating 175 years of GSI with such a great, enriching international seminar. We had 2 days of very enriched discussion, deliberations, presentations, posters, exhibitions. I think all of us were very busy discussing with people science. There's one time where for 2 days we have been discussing science, and also, I must say, very good food as well. By, I think, unanimous consent, we can firmly say that this international conference is a resounding success. In terms of the objectives which we have kept in front of us, objectives was celebration of geoscience on the occasion of this great occasion of 175 years of GSI. We stuck to geoscience for 2 days without any encumbrances of politics or policy or acts. We have had excellent plenary lectures, started by Professor Catherine Goodenough and many others, including an excellent keynote addresses, the invited speakers. The last one from Abhijit Mukherjee was again, but unfortunately, all of us could not hear all of them because many of them were in parallel sessions. Be that as it may, whatever I heard, I felt much enriched, much more enriched than I had come 2 days back. I suppose I must take some credit for this as the chairman of the science committee. But to be very frank, my work was limited. The main work was being done by Basav Mohanta, who is here, Dr. Saibal Ghosh, who was here. I was just doing some formal approvals and yes to just give a support. And you have done a great job. I must say you have done a great job. The kind of work, even the papers which are selected by Shilat Sengupta and his team, I can't name all of them. I'm talking about those who were there from CHQ headquarters from Kolkata. I am sure Mughal Sahib will talk about those who are there in Lucknow and Jaipur, who have done a great job. I can at least certify one thing: your food was excellent. there were some excellent, people to interact with. Professor Catherine Gooden, I've seen her in this auditorium for those 2 days continuously for all lectures. That's an example. I must say that's an example for all of you. So these are the, and a special thanks must go to Harish Mistry and Vivi Mughal and my friend Mora and their team. I cannot name all of them, and I can see them working for the last 1 month continuously, and for the last 2 days they were hardly to be seen. Very difficult to even catch them over phone. I must thank you. It was excellently organized. All of us felt it was fluently, no glitches, to organize extremely well. And Anil Kumar, I must talk about the contribution of Anil Kumar, Dr. Jaydeep Guha, and Shilayata Sengupta. I have seen from there. I was just a witness. I did not much interfere. I just see they were working. And they also did not seek my advice, but they on their own done extremely good work. Especially Anil Kumar and Dr. Jaydeep Guha. I think if someone is to be awarded from CHQ, it's them and Basab Mahanta. Actually, my words fail me in terms of people who have worked here and people from CHQ. Dr. Asit Saha's, Professor DG Asit Saha's timely interventions, our sponsoring committee, they gave a lot of hiccup. Actually, they gave a lot of tension to our Vivi Mughal. Till the last day he was in tension, but I think our sponsorship committee ultimately had the last laugh. I think they need to laugh a bit more, isn't it? Huh? Yes, the sponsorship committee will laugh a bit more to finish the work. I have had extremely 2 beautiful, enriching days, and I go back enriched person in terms of the science. I have got many takeaways. I have got many things that we have planned to do immediately after this international conference. And I'm sure all of you here will go up as enriched as I feel I am. Thank you very much.
Thank you so much, sir, for your enlightening words. And now, ladies and gentlemen, to take us through a concise summary of the key outcomes and major recommendations that have emerged from our collective deliberations, I now invite Shri Vijay V. Mughal Sahab, ADG and HOD, GSIWR, and Chairman of the Organizing Committee. Sir, we look forward to your address. Let's have a huge round of applause for Vijay V. Mughal Sahab.
A very good evening. Really, this is a valediction session. On the dais, Shri Asit Shah, the patron for this international seminar, the DGGSI, and the overall guidance and my resource for taking directions. Then Srimati Varsha Aglavi Madam, ADG and HOD Eastern Region, Dr. Jayesh Bakshi Sahab, ADG PSS Central Headquarters, Dr. Abhijit Mukherjee, IIT Kharagpur, and Dr. Catherine Gooden from British Geological Survey, Shri LMS Mohra Sahab, DDG RMS 2, and convener of this international seminar. I welcome all of you, sir, here, respected esteemed speakers, distinguished delegates from India and abroad, dear colleagues and my friends. It's really a good evening for me, and I wish everybody a very good evening. When we first envisaged this seminar titled Unearthing the Past, Shaping the Future, 175 years of GSI. Before 4 months, it was told that it is to be organized at Jaipur, and it was finalized. During those days, we have started our preparations 4 months back. with all committees, formulation, or all those things. We dreamed of bringing together the rich legacy of our organization, the scientific endeavors of today, and the possibilities of tomorrow. Today, as we draw the curtains on these discussions, I feel with satisfaction and gratitude that vision has taken place. You already witnessed the entire 2 days program, and I think you really agree with my statement. For last 2 days, through sessions ranging from historical surveys of GSI pioneering decades to cutting-edge geoscientific research, we saw how heritage and innovation coexist. The maps, advancement, geostatistical modeling, all testifying that our past is not simply a legacy to glorify, but a foundation to live from. Let us carry this forward in our departmental functioning. It would be easy to conclude with applause and photographs, but the true value lies in what happens next. The papers presented, the discussions held, the new network formed, they must translate into the concrete outputs, enhanced field protocols, collaborative projects, publications, training modules, policy inputs, updates, GSI database, and better public outreach. I urge everybody to take ownership of actions, items born from this forum. I witnessed firsthand the dedication that went in behind the scenes. The organizing committee, technical teams, as said by Dr. Bakshi, he spoke about all the committees from central headquarters like Science Committee. I would like to thank here Finance Committee, the Chairman, Dr. Jaideep Guha, and Science Committee for taking care of all the international affairs, the international plenary speakers they are invited through international affairs, and the logistic media cell, volunteers, field visits especially for the British Geological Survey that was in between, and we have managed it like anything. Registration management, scheduling, hospitality, and much. Without each of you working seamlessly, this gathering would not have attained the level of excellence we witnessed. I thank you for from my bottom of heart. I would like to highlight a few acknowledgements to all of you, to our chief guest, guest of honor, keynote speakers, session chairs, and all paper presenters. Your presence and insights gave this seminar a substance. To our colleagues from abroad who traveled and shared global perspective, your participation enriched our horizon. To our sponsors, especially our event partners, RSSML, then SZL, Oil India, Shipping Corporation of India, and this SCL. Those are our major sponsors. Of course, there are numerous they have sponsored within about 2 days or like that. That has helped me, as said by just now, we could not laugh before 2 days, and after 2 days we were in a position to see some smile on my organizing committee members, because that was the main backbone of this international seminar, to have sponsorships. So I thank all sponsors from my bottom of heart. This could happen because of these sponsors. Friends, at this moment of valediction, let us carry forward sweet memories of well-organized sessions, well-planned logistics, and to harness the momentum we have built. Let us vow this event not to be a standalone highlight, but a catalyst for institutional strengthening and enhanced global collaboration through our plenary speakers or all the abroad and in India institutes. Sir, great occasions teach us, and great teamwork empowers us. I believe in my teamwork. To all the team members, right from CHQ to my Western region, the great and very strong team of Western region I have. I can do anything from with my district team we have witnessed, and I am very much thankful to my all the members, right from bottom to top, top to bottom, everybody. Sir, let's as we depart, let us remain connected in purpose, committed to in action, and courageous in innovation. Thank you once again for making this seminar a success. Wishing you all safe journey back home, fruitful follow-up engagements, and a future when the seeds sown here bear rich scientific harvest. That's all from my side. Thank you very much. Thank you very much.
Thank you so much, Sri Mughal, for capturing the essence and the significant outcomes of this seminar. We are truly grateful to you, sir. And I would like to say a few lines for Mr. Mughal. Ye couplets hain from a famous ghazal of great poet Dushyant Kumar Sahab. And it goes like this कि ये जो शहतीर है पलकों पे उठा लो यारो, अब कोई ऐसा तरीक़ा भी निकालो यारो. ये जो शहतीर है पलकों पे उठा लो यारो, अब कोई ऐसा तरीक़ा भी निकालो यारो. कैसे आकाश में सुराख हो नहीं सकता, एक पत्थर तो तबीयत से उछालो यारो. So you know we can achieve anything if we are dedicated, determined, passionate, and we want to achieve our goal as much as we want to breathe. So we are really grateful to VV Mughal Sahab. Under your guidance, sir, we have achieved this landmark and we did this wonderful international seminar. It was a successful execution of this grand seminar. Hats off to you, sir. And here we would like to felicitate Shri Mughal Sahab, and to do the honors, I would kindly request Shri Asit Sahaji, Director General GSI. Let's have a big hand for VV Mughal Sahab. Thank you so much, sir. Thank you once again. And now, ladies and gentlemen, we will now be addressed by Srimati Varsha Ashok Aglave, Additional Director and HOD of the Eastern Region. Ma'am, we would be privileged to hear your perspective.
Namaskar, Khambagani, very good evening to all of you. Respected our DG GSI, Ashisa Saab, Dr. Joyce Bagchi, ADG PSS from CHQ, ADGs, Western Region, Vijay Mughalji, our one member from British Geological Society, Dr. Catherine, and Dr. Mukherjee, and our RMH2 from Western Region, Mora sir. A very good evening to all of you. Respected dignitaries, distinguished guests, dear delegates, ladies and gentlemen. I am also very happy to see that our senior officers are sitting in, and I had very missed opportunity to have some discussion with them also. Namaskar sir, namaskar. It is my great honor and privilege to address you all at the valedictory session of this landmark international seminar here in Jaipur. Firstly, I extend my heartfelt gratitude to our chief guest, honored speakers, international delegates, young researchers, and organizing committee whose dedication has made these past 2 days truly memorable. Over the course of this seminar, we had the opportunity to engage in rich dialogue, sharing insight across discipline, culture, and geographics. We explored key themes around unearthing the past and shaping the future, challenged assumptions, and chartered pathways for future collaborations. The contributions have been exemplary. As we draw a close, I would like to highlight 3 key reflections. Interdisciplinary collaboration in today's complex world No single discipline hold all the answers. The fruitful interactions of science, policy, technology, and society we witnessed here are a very fabric of innovation, global plus local synergy. While we had global perspectives in this room, it is only when this translates into local action, whether in Rajasthan, India, or elsewhere abroad, that real impact is realized. Let us ensure we carry forward this knowledge to our regional jurisdictions, institutions, and field operations. Sustainability of outcomes. A seminar is only as valuable as the actions it scans. I urge each one of you to convert insights into outputs, papers, field studies, policy beliefs, training modules, and collaborations. Let us not let this end here. Let us make this our beginning. On behalf of the organization and on my personal behalf, I congratulate the organizing team for seamless planning and execution, from registration to technical session, from cultural programs to networking breaks. Your professionalism has made Jaipur proud. I also express sincere thanks to our sponsors, technical partners, venue staff, media team, student volunteers, and local licensing officers. Your behind the screen efforts have enabled this success. To the delegates, thank you for bringing your energy, curiosity, and open-mindedness. Whether you presented a paper, chaired a session, or simply participated in discussion, your presence enriched the seminar. As we leave this venue, let us remember that knowledge finds its true value when shared, adopted, and implemented. May we contribute to stay connected through this network we have built, and may this friendship, partnership, and ideas born here thrive long beyond these days. And I was very happy to see Dr. Jeff from Michigan University. Actually, we had collaborated project in Central Region when I was there, and we had done field work in Bara Shimla, Chota Shimla area of Jabalpur, and sir was also there in our MP Bagh beds. So thank you, sir, for we have met for so long years, and Dr. Mobe also, under whose guidance I have done some paleontology work. In closing, let me quote, "Alone we can do so little, together we can do so much. Let us commit to working together across boundaries for a brighter, inclusive, and sustainable future." Thank you once again of your participations and for making this seminar sounding success. Wishing you a very best and fruitful journey. In this closing note, let me say a few quotes. "Alone we can do so little, together we can do so much. Let us commit to working together, together. Dhanyavad. Thank you.
बहुत shukriya. Thank you so much, Shrimati Varsha Ashok Aglavi ji, for your valuable insights and for your kind words. And now, ladies and gentlemen, the moment we have all been anticipating. We are now honored to hear from our chief guest, the head of this esteemed organization. I call upon Shri Asit Saha ji, Director General GSI, to deliver the valedictory address and share his esteemed thoughts with us. Ladies and gentlemen, please join me in welcoming Shri Saha with a tremendous round of applause.
I have been just roaming around the corridors of this building and also the corridors of the building at 27 Jawaharlal Nehru Road, doing nothing almost. But I am the happiest man today. Doing practically nothing other than standing before you and sharing my thoughts. I mean, Dr. Mughal said that Western region geologist, Western region team can do anything. I would take it a little bit further. GSI can do anything. I mean, it's not only organizing a conference, an international conference. Actually, I tell it everywhere that give us anything remotely connected to geoscience, we will do it. We have the glorious legacy of 175 years, the knowledge base with us, which is transient, which cannot be seen, but it is there. It is flowing within the veins of each one of us. And usi ke balbute, we can actually achieve anything. Just think of it. Just think of the moment when GSI was there, led by some British geologists who actually probably were not geologists, but curious scientists who started looking for things here and there out of sheer curiosity. And then it started with coal exploration because there were rail lines getting erected, steam engines needed coal. From that point of time, in today, what we are doing, if you see our journey, if you see the transformation, so you will find, yes, what I am saying is true, that we can do anything. You know, unearthing the past, shaping the future. We have been unearthing the past from the very beginning. It's nothing new for us, nothing new for the geoscientists all over the world. What we are actually trying to do is we are witnessing the effect on the earth, and then we are trying to find out the cause. That is what we are doing. And I'll tell you, this will never end. With every passing day, with growing knowledge, you will reinterpret, you will have new knowledge, and this unearthing will continue. Having said that, every step we take toward this unearthing of the past, we'll learn bit by bit, and that knowledge helps us in shaping the future. These 2-day deliberations, excellent deliberations, need not be said, and again, everybody acknowledges it. I did not reaffirm it. This definitely has given us new thoughts, new areas where we can go ahead and shape our future. Future which actually is at stake. There have been presentations which has painted a little bit of grim picture for the Mother Earth. We all know that we have this problem of global warming. There is debate going on, but you know, this debate is something concocted debate. I mean, there is a good number of people who truly believes that there is global warming, and there are some people, because of ulterior motives or whatever it is, they don't agree to that. But we cannot deny the fact that temperature has risen, climate has become more, unpredictable. Rajasthan witnesses floods now, and areas which were supposed to have rains experiences droughts nowadays. So there are changes. Whether it is because of global warming or not, that is debatable, but there are changes. There are indications that this Mother Earth is under strain, is under pressure. And I'll tell you one stark truth. We geoscientists are one of the culprits for this, because it's we who have found out the natural resources. We have shown to the world how to utilize those natural resources, and it's because of that all these developments have been there in this world. And, so please take cognizance of this fact and try to do a recycling of the whole thing. Let us try to, undo the damages which has been caused by us. If this conference has given us some ideas to go forward in that direction, then I would say that this conference is absolutely successful. Do we agree with this or not? We have had a lot of interesting things happening for this journey to this conference. Last March, when we did our first anniversary celebration, and then we started chalking out things which we are going to do over the year, and we decided to have an international conference, and we selected the city of Jaipur because of its regal nature, and this part of the time of the year, it has got a beautiful climate, and of course this venue of RIC, which we thought is absolutely apt for this type of gathering. We were not having this idea that it would become so very difficult to organize an international conference. I'm sure Dr. Mughal has had sleepless nights. His team members must have gone through a lot of tension, I just cannot imagine that. As I said, I have done nothing. We have had setbacks, terrible setbacks in between. We had to do a lot of course corrections to reach to this point today, where we can say, yes, we are happy. Even, many people who were supposed to come, let's say Dr. Karanza, he missed his flight, he couldn't come here. At the same time, Ziggy is sitting over there, he got his visa just before boarding his flight. Thank you for the beautiful message. We have had our ex-GSI senior people sitting with us all throughout the day, listening to the deliberations. Thank you, sir. Thank you for your presence. excellent. I need not say anymore. But, you know, I have seen Harish over these few months while doing VC and while doing meeting in face-to-face. I have never seen him perturbed, sorry, and he has been smilingly taking up all the challenges. So I must take this opportunity to thank you, Harish, and all of the people who have been associated with them, Anil, Shaibal, Pradeep, who has been leading this, Rupesh. Just don't blame me if I forget any names. All of you are gems. Thank you very much.
Thank you so much, Mr. Saha. Thank you once again for your gracious presence and for delivering such an inspiring, lovely, and thought-provoking valedictory address. And now, ladies and gentlemen, as Dr. Saha said, Shri Asit Sahaji said, we would like to invite Shri Harish Mistriji now, Director and Organizing Secretary, to deliver the vote of thanks. Let's have a huge round of applause.
Thank you. First of all, I am taking advance apology for respected dais and from all the delegates that I am going to be taking more time in expressing myself. Please allow me and please forgive me. Namaskar, Khama Ganisa. A very good evening to all of you. Respected dignitaries, esteemed guests, distinguished delegates, colleagues, and my dear friends. As we draw this landmark two-day international seminar to a conclusion, it is my honor and privilege on behalf of the organizing committee to extend a heartfelt vote of thanks to each and everyone who made this event a resounding success. At the commencement of my address, we express our profound gratitude to Honorable Minister of Coal and Mines, Government of India, Sri G. Kishan Reddy Sir, for his gracious presence during the inaugural session of this international seminar, sharing his valuable time, inspire all of us through his leadership and visionary guidance. His encouragement reaffirms our commitment to excellence and progress. We are deeply honored by the gracious presence of respected Sri Piyush Goyal Sir, Secretary, Minister of Mines, Government of India. During the inaugural session, his strategic vision and steadfast support have been pivotal in shaping national mineral policies and strengthening institutional foundations. We wholeheartedly thank to the chief guest, today's chief guest of this valedictory session, and our leader of the team GSI, Sri Ashish Shah Sir, respected Director General of Geological Survey of India. Sir, your unwavering commitment to a scientific rigor and innovation has guided all of us in its quest for geoscientist advancement and national development. Your participation in this event throughout these 2 days, your valued insights have greatly enriched this event, sir. And very special thanks to Srimati Varsha Aglave Madam for her insightful guidance, valued contribution, and constant encouragement which have enriched the discussion and spirit of this seminar. Our sincere appreciation to the team leader of Western Region, Sri Vijay V. Mughal Sir, and the chairman of the organizing committee for his exemplary leadership, meticulous planning, and tireless dedication, truly the backbone of this successful and landmark international event in the Western Region, Jaipur, Rajasthan. The dedication with which he coordinated diverse committees and fostered teamwork has been truly commendable and contributed to the grand success of this seminar. I sincerely extend my gratitude to respected Sri Joyce Bagchi Sir
Additional Director General, Policy Support System, Geological Survey of India, Central Headquarters, Kolkata, for his esteemed presence and valuable support in conducting this event. Sir, your insight, remarks, visionary guidance, and continued support have greatly enriched the deliberation of this international seminar. Your encouragement and commitment to strengthening this institutional framework of GSI have been truly inspiring, sir. We also express our deep gratitude to Sri T. Ravikant, sir, Principal Secretary, Mines and Petroleum, to Government of Rajasthan for his sustained support and his gracious presence during the inaugural session. We extend our profound gratitude to Sri LMS Mora, sir, our respected Deputy Director General, Regional Mission Head, and also convener for this international seminar, for his leadership and unwavering commitments, his meticulous planning and constant guidance to each and every committee members have ensured the seamless execution of every segment of this event. Kudos to Sri LMS Mora, sir. I extend my gratitude to Ms. Catherine Goodenough. Madam, your presence, your representation from British Geological Survey encourage all of us, and definitely it will take India-UK collaboration into a next level in the field of critical minerals and AIML collaboration. Thank you very much, madam. I also extend sincere gratitude to Sri Abhishek Mukherjee, sir, from IIT Kharagpur. So definitely, sir, our collaboration between IIT Kharagpur and GSI, definitely the geoscience will be taken to a new heights. We extend our gratitude to our respected Additional Director Generals of different regions, HODs of different regions, National Mission Heads, Deputy Director Generals of various state units, various missions, for joining with us for full 2 days. Thank you very much, sir. Your constant guidance and leadership has been instrumental in steering various activities of this seminar with clarity and purpose. We deeply appreciate their proactive involvement and the encouragement extended to the organizing committee, organizing team throughout these preparations. Their collective commitment has greatly contributed to the successful convening of this international seminar. I extend my heartfelt gratitude to former Director Generals, former Additional Director Generals, former Deputy Director Generals, former directors who have been present there for 2 days, and they all encourage our team in conducting this seminar. Thank you very much, sir, for your valuable contribution and remaining presence with our team GSI, sir. I really acknowledge our sponsorships. We sincerely thank our distinguished sponsor for their unwavering support, without which this seminar would not have been possible at this magnitude. Their financial assistance, resources, and goodwill have significantly strengthened our organizational efforts. We are grateful for their continued association with Geological Survey of India and their commitment to promoting scientific dialogue and innovations. Their partnership remains invaluable for all of us, and we are looking forward to many more fruitful collaborations in the future. I am naming out them: our event partner, Rajasthan State Mines and Mineral Limited, Government of Rajasthan Public Sector Unit, Hindustan Zinc Limited, Vedanta, our platinum sponsor, Oil India Limited, Hindustan Copper Limited, Shipping Corporation of India, our diamond sponsor, Adani MTC Ahmedabad, Data Code, Greenco, Variatech Private Limited, Tata Steel Industrial Consultancy, gold sponsor, United Exploration, Hindalco, GMDC, Maheshwari Mining, Geosync, our silver sponsor, JSW, Adani Metals, Ramgarh Mining and Minerals Limited, Pixel, Gurgaon, Infratest, NTPC, NHPC, EMIL, SGVN, Excalibur, Macfar Private Limited, MECL, ISRI, NALCO, IIC Technologies Private Limited, and our exhibitors CMPDI, Chennai Metco, Torrent Power, NGOTech, and IR Technology Services Private Limited. Your active participation has been added great value and engagement to this event. A warm appreciation to all international delegates and eminent foreign experts joining us from across the globe your diverse perspectives have truly enriched this seminar's deliberations. Thank you very much. We are equally thankful to our invited speakers and experts representing Indian universities, research institutes, organizations, government organizations, private sectors, whose research insights and contributions have deepened our collective knowledge. Thank you very much, sirs and madams. We extend our sincere appreciation to all the poster and oral presenters. They are representing diverse domains of geoscience. Their valuable contribution, innovative ideas, and rigorous scientific efforts have enriched the intellectual depth of this seminar. The diversity of topics and the quality of their presentations have fostered meaningful dialogues and broadened our collective understanding. Thanks to each one and all. We extend our heartfelt thanks to the chair, co-chairs, and rapporteurs of various technical sessions for their invaluable contribution in the smoothly conducting of the technical sessions during this international seminar. We convey our sincere thanks to Rajasthan Tourism Development Corporation, a government of Rajasthan PSU, for bringing the authentic taste of Rajasthan to this event, for their commendable, seamless support in the event management. Under the able leadership of Sri Tej Singh Rathod, General Manager RTDC, has offered warm hospitality, cultural richness, and seamless coordination have significantly enhanced the overall experience for all our delegates. Our special appreciation to the Rajasthan International Center. This is wonderful premises where we have conducted this seminar, for providing these beautiful premises for conducting this international seminar. We also express our sincere appreciation to the talented artists of Jawahar Kala Kendra, again Government of Rajasthan undertaking, for their captivating cultural performance. Their artistry, elegance, and vibrant presentation beautifully showcase the rich heritage of Rajasthan. Our special appreciation and heartfelt gratitude to the print media, PIB, digital media for wonderfully covering our event. Sincere thanks to all the participants, representatives from central and state government departments, PSUs, exploration and mining companies, academic institutions, research organizations, and students. Your enthusiastic involvement, inquisitive questions, and thoughtful discussions have been the real strength of this event. The success of the event is always a direct reflection of a strong leadership, wherein we committee members work under a single umbrella, and this time also we proved the vision of our respected DG GSI. Yes, together we can do anything. So we are the GSI, that is our team GSI. So let a round of applause for our team GSI. We work in a collaboration from CHQ to the western region, each and every person, starting from the patron to the last member, we work together like a garland, and we make this event very successful. I am listing out the acknowledgement for my complete team, starting from our patron and respected DG GSI, Sri Ashish Shah sir, Director General GSI, our chairman of this event, Sri Vijay Mughal sir, Additional Director General HOD Western Region, GSI Jaipur, co-chairmen for this event, Dr. Joydeep Gua, ADG Finance and HOD of CHQ Kolkata, Dr. Joyce Bagchi sir, ADG PSS, GSI CHQ Kolkata, our convener, Sri Lalit Mohan Singh Mohra, DDG RMS2, GSI Western Region Jaipur, our co-conveners, Sri Sudhanshu Shekhar Datta, Deputy Director General, State Unit Gujarat, Daman and Diu, Dadra Nagar Haveli, Gandhinagar, Sri Anindya Bhattacharya sir, DDG and HOD RSAS, Bengaluru, our joint organizing secretaries, Sri T. Vedishwaran sir, Director GSI Western Region Jaipur, Dr. P. Soni Kurian sir, Director GSI Western Region Jaipur, and of course our Dr. A. Anil Kumar sir, Director GSI CHQ Kolkata, who become the key person and link between CHQ and our team Western Region. And steering committee, definitely it is our role of leadership is starting from this steering committee who hold the steering of this event, and we make it a success. So the chairman of the steering committee, under his leadership, Sri Dinesh Vittal Rao, Ganveer sir, Additional Director General and HOD GSI CR. This steering committee has functionalized. Sri Basa Mukhopadhyay, Additional Director General and HOD SR. Sri Pradeep Singh sir, DDG and NMH 1A. Dr. Saibal Ghosh, DDG and NMH 4. Dr. S. Ravi, DDG and HOD GSI TI. Dr. Srimati Snigdha Ghatak Madam, DDG International Affairs, GSI CHQ. Dr. N.M. Sarif sir, DDG and HOD MCSD, GSI Mangaluru. And the wonderful editorial committee. And they a really very appreciating efforts by each and every member of this editorial committee members who brings the wonderful abstract, who scrutinize wonderful abstracts, and anonymous editors, reviewer of this committee are really did appreciable works under the able leadership and chairmanship of Sri Siladitya Sen Gupta sir, DDG PSS and PNM, Dr. Sudeep Bhattacharya sir, DDG Mission 2B, Sri M.N. Parveen sir, DDG GSI SR, Sri Vishal V. Sakre sir, Deputy Director General, State Unit Rajasthan, Srimati Archana Sharma, Director GSI WR, Dr. Masab Nandan Mahanta, Director Mission 4 GSI CHQ Kolkata, Srimati Debauti Mukherjee, Director Mission 4, Dr. Suresh Kumar, Director GSI, Dr. Manjari Patak, Senior Geologist, GSI SU Uttarakhand. Now next committee is Outreach Committee. Really very appreciable efforts by the Outreach Committee who publicize and they reach out to each and every corner of globes and they select the best persons, invited best person to our India. Under the able leadership of Dr. Srimati Snigdha Ghatak Madam, DDG International Affairs, Srimati Monalisa Chakra Madam, Director GSI WR, Sri Arun Kumar Gujur, Director International Division, Dr. Kevil Thenuo, Senior Geologist GSI. And next committee is PRO committee, a very wonderful committee who publicize this one in live streaming and make a very wonderful publicity internationally under the chairmanship of Sri Devendra Singh, Director, and PRO Western Region GSI Jaipur. A big round of applause for Sri Rupesh Kumar, Director, and PRO GSI CHQ Kolkata, co-chairman and his CHQ team. Definitely they have did a wonderful job. Srimati Madhusmita Swain, Senior Geologist, Sri Chandan Kumar, Geologist, Western Region. Of course, website registration and payment gateway committee, it is also very wonderfully organized under the able leadership, chairpersonship of Ms. Gargi Chakrabarti Madam, Superintending Geologist, Sri Hiten Jaluthria, Senior Geologist, Sri Chandan Singh Rajput, Executive Engineer, PR Team GSI CHQ member. And the most important committee is a sponsor committee, is especially acknowledged. Without their efforts, their arrangement, it could not be possible. Under the able leadership, Sri Pradeep Singh sir, DDG and NMH 1A, that sponsors committee had did wonderful job for all of us and making this event a grand success. Thank you very much, sir. Sri Pradeep Singh sir is the chairman of this committee. DDG and RMH 3 GSI WR, the member of that committee, Dr. S. Ravi sir, DDG and HOD GSI TI, and a wonderful round of applause from team WR, Sri R.H. Chauhan sir, Director GSI, Sri Kirod Kumar Nayak sir, Director GSI, Dr. B.K. Das, Director SU Gujarat, Sri Rajiv Chandra, SC GSI, Sri Mukund Kumar, Senior Geologist, GSI WR, Sri Ashish Bhandari, Senior Geologist, SU Gujarat member. A tremendous efforts has been putting by registration and reception committee to managing all of us and providing the wonderful kits and arranging the things at the registration committee. You really need appreciation under the able leadership. Chairperson Srimati Sonalika Joshi Madam, Director GSI WR, Dr. Mamta Vijay Kumar Pal, Director GSI WR, Sri Sandeep Singh Chauhan, Senior Geologist, Dr. Jaideep Kaur Tiwana, Geologist, Srimati Sanjana Tripathi, Geologist, Ms. Mamta Gupta, Chemist GSI WR, Sri Amit Pandey, Chemist GSI WR. And invitation, inauguration and valedictory committee. Really under this one we have did the inauguration session and this valedictory session is also part which have been executed under this committee under the able leadership of chairmanship of Sri LMS Morasa, DDG and RMH2, Srimati Jaya Rashtrapal Chauhan Madam, Director Co-Chairperson, Srimati Monalisa Chakra, Director, Srimati Satinder Dhillon, Director GSI WR, Srimati Kuljit Kaur, Senior Chemist GSI WR, Miss Maitri Chakraborty, Senior Geologist WR, Srimati Monomita Chakraborty, Geologist WR, Srimati Ridhima Mishra, Geologist WR, Sri KK Shukla, PASU Rajasthan, GSI WR, Srimati Asna Siddiqui, Geophysicist WR, Dr. Gajraj Singh, storekeeper, GSI WR, Sri Wasim Beg, UDC GSI WR member. And next committee is poster session, exhibition, publicity committee. Really, this committee make wonderful things. They arrange the poster sessions and providing the wonderful exhibition, wonderful GSI stalls, very beautiful other stalls of our sponsors under the chairmanship of Sri Satyapal, Director GSI WR, Mohammad Yusuf Khande, Director GSI WR, Sri Mohammad Zohaib Siddiqui, Senior Geologist GSI WR, Sri Sanjay Kumar, Senior Chemist GSI WR, Srimati Triparna Ghosh, Geologist GSI WR, Sri Sayyid Ejaz Ahmad, Director GSI WR, Sri Jamal Anwar, Senior Geologist WR, Sri Narendra Kumar Swami, Senior Geologist WR, Ms. Rituparna Chakraborty, Geologist GSI WR, Sri Sukesh Jhagar, Assistant Geologist GSI WR. And a wonderful task has been executed by the publication committee in accumulating, gathering all the information and binding in the form of a beautiful abstract volume, souvenirs. A tremendous efforts has been taken under the chairmanship Dr. Mridul Srivastava sir, Director GSI WR, Sri Kaushik Shukla, Director GSI WR, Sri Shailendra Kumar Gehlot, Director GSI WR, Srimati Archana KG, Superintending Geologist WR, Sri Manaram Jat, Assistant Geologist GSI WR. And more important committee, that is Finance Committee. So it really required an additional appreciation and gratitude for their meticulous planning and mobilizing the fund for organizing this wonderful event. Thank you very much, sir. Finance Committee that has been led by Dr. Joydeep Gua. A big round of applause for Dr. Joydeep, sir. ADG Finance, GSI, CHQ, Kolkata, under his leadership, the Finance Committee, DDG and RMH4, GSI WR, Sri Joy Mukherjee, Director of Finance, Sri Bijan Jyoti Burman, Director, GSI WR, Sri MS Tomar, DCOS, GSI WR, Sri Nitesh Khandelwal, PO, Sri Subhash Chandra Mondal, Cost Account Officer, GSI CHQ, Sri Raghavendra Prasad, Assistant Cost Account Officer, GSI CHQ, Ms. Prerna Kharol, ACO, GSI WR, Sri Kaluram Meena, AO, GSI WR, Sri Ajay Kumar Sharma, Cost Accountant, GSI WR member. Thank you for managing our finance. Thank you very much. And very well appreciation for Transport Committee, who makes a very wonderful arrangements for bringing all of us from airport, from railway station, from bus station to the hotels, from hotels to the venue, from venue to the respective places under the able leadership of Sri Rakesh Gupta sir, Executive Engineer NFJ, GSI WR, Sudhir Sharma, Executive Engineer, Co-Chairman, Sri MS Beast, Executive Engineer, GSI WR, Sri Himanshu Gar, Assistant Executive Engineer, GSI WR, Sri Naresh Kumar Sharma, Drilling Assistant. And Accommodation Committee is really needed a round of applause under the able leadership of Sri K. Raju sir, who was retired now. Subsequently, it has been taken over by our respected Sri Vedisuran sir, RMH1 GSI WR as a chairman, Sri Subhash Banerjee sir, Director GSI WR, Dr. Rakesh Sharma, Director Chemical, Sri LK Khatri, Director Geophysics, Sri Shakti Kumar, Senior Geologist, Sri Mukesh Kumar Mandal, Senior Geologist, Sri Hemant Kumar Sharma, Senior Chemist, Sri Pradeep Kumar Bharti, Senior Geologist, Sri Deepak Kumar, Senior Geologist, GSI WR. And as it has been appreciated from the first person to the last person, the refreshment committee. A big round of applause for this refreshment committee for providing wonderful refreshment throughout these 2 days under the able leadership of Sri Manish Chopra sir, Director Geophysics, GSI WR, Sri Prashant Parekh, Senior Geologist, GSI WR, Sri Osaf Raja, Senior Geologist, GSI WR, Sri Shishir Bharadwaj, Geologist, GSI WR, Dr. Yogpal Dhayal, Senior Chemist, Sri Hemant Kumar Singh, Senior Geologist, GSI WR, Sri Naresh Kumar ji, PA2 HOD sir, Western Region, GSI WR. And Cultural Committee, really they have bring the best artists from Rajasthan who can showcase the wonderful and rich culture of Rajasthan to all of us. Under the able chairpersonship of Srimati Sini Raj, Director GSI WR, Sri Rohit Kumar Gaur for a wonderful appreciation really required for Rohit for a wonderful song, Padharo Mara Desh. Co-chairman Sri Mukesh Kumar, AO SU Rajasthan, Sri Shirendra Kumar Sharma, Sri Vimlesh Kumar Pandey, JTO GSI. And special appreciation to the Science Committee for meticulously arranging all the lectures, all the planning of completely organizing the things in a very systematic way in 4 plenary halls and executions of all these sessions across the halls. Under the able leadership and chairman, Dr. Joyesh Bagchi sir, a big round of applause for him, ADG PSS, Dr. Saibal Ghosh, Deputy Director General NMH4, Dr. S. Ravi, Deputy Director General and HOD GSI TI, Sri M. N. Parveen, Deputy Director General RMS2 GSI SR, Sri Sanjay Singh sir, Director SU Rajasthan GSI WR, Dr. Basab Nandan Mahanta, Mission 4 GSI CHQ Kolkata. And a very, very special appreciation to the representatives from the Delhi. So, a very well appreciation for Sri Yogendra Singh Bhambu, Director Tech, the team from Ministry of Mines, team from Director General Camp Office, New Delhi, Sri Mukesh, Dr. Mukesh Kumar, Director, and DDG, Sri Manish Kar sir, for providing ministerial support whenever we required and continuously with us for providing all the supports from the ministry side and from the DGO side. I really acknowledge 2 of my young officers who throughout this management, they are with me. They are Sri Ilyas, geologist, and Sri Harsh Puskar, geologist, for providing the personal support and assistance all the time in the preparation and execution of this event. Thank you, both young colleagues. Finally, once again, I extend my heartfelt thanks to each and everyone for your valuable presence, insightful ideas, and unwavering commitment. Your participation has truly enriched this event. We look forward to continued collaboration and to meeting again at future platforms. At last, on behalf of organizing committee and as a organizing secretary, I humbly extend my sincere apologies to all of you for any shortcomings or inconvenience that may have occurred during this course of event. I really apologize from my team. Despite our best efforts, if anything fell short of your expectation, I request your kind understanding and indulgence. Your patience, cooperation, and goodwill have been invaluable throughout this journey, and I remain deeply grateful for the same. I am very much thankful to the Almighty for providing the opportunity in concluding this session. Wishing everyone a very pleasant evening ahead. Thank you. Jai Hind, Jai Bharat.
Thank you so much, Shri Harish Mistry Sahab. Ladies and gentlemen, as we near the end of this ceremony, we request you all to please rise for the singing of the national anthem.
गणमन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल गंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
Thank you so much once again, and on behalf of the Geological Survey of India, we extend our heartfelt thanks to our distinguished guests for gracing this event and to every one of you for your valuable presence. We wish you a safe and pleasant journey back home and look forward to the privilege of welcoming you again at our next edition. And now we cordially invite all our dignitaries, delegates, and our team to join us for a photograph session. This is Anamika, your host for the evening, signing off. Thank you and have a wonderful night. Shaba Khair.